This is Slay Radio, this is Happel, and I just love this station. This is the place to be.
There is a disturbance in the stream. Admiral, move the fleet to Slay Radio. I want that free TCP packet.
Good morning.
Good morning.
Hello.
How are you this morning?
Doing good. Let me get the volume here cranked up a little bit.
All right.
How are
So
you guys
your
today?
last day.
I can't believe it is. It's let me check if the live stream is indeed working as well. It is. I can see yourselves. That's great.
Good.
Oh, we got another treat this morning. We got a machine that very few people have, and someone actually has been very, very active with. That's great. So before we go there though, will we talk a little bit about the schedule for today? Yesterday was
Sure.
great, by the way. Yeah, man.
Yeah. So let's talk about the schedule.
Epic.
So today we have Jim Happel, which is preparing right now. He's going to be doing a talk on the Mega 65 and game development, which is going to be pretty amazing. And then we've got you are going to basically beat up Keith today in his interview on how I turned my hobby into a career. So that'll be a lot of fun.
Yeah.
And then the auctions will end, and the auctions are going crazy right now, by the way. So
And
if you
I'm loving the
keycaps,
auctions.
if you want an original disc notcher in the package from 1980, whatever, it's on the auction. So check that out. And then we have Robin Harbron, who's going to do the enormous Electronic Arts logo Easter egg hunt, which is a mouthful, but that should be rather entertaining. And then Mike Hill's going to be here. He's known as the BitFixer. He's going to do an update on his products and let us know what he's doing for the future stuff, which is cool.
Yeah.
And then we're going to wrap up the presentations today with me doing a follow-up to yesterday's KiCad project. We're going to build a case in Solidworks for that project. And then we're all going to chat about what we can do to make things better for next year, hopefully in person. And then that will be the end of the show for this year.
That's awesome. Can we talk about the auction real quick though? You know, I've been following along with the auction. There's no secret that I like the very bright colors.
Yeah, it's no secret that you are responsible for those colors.
$71 right now for the green, for the neon green. That is pretty good.
The pink is $84.21.
84, that's crazy. How about the yellow? What's the yellow? Oh, the yellow is lagging still. Guys, you're missing out. If you're not if you're not bidding on the yellow, you're missing out. If you want to stand out from the crowd, that will help you a lot. Take the old case, put these ones in. You even need sunglasses. It's very, very cool. I'm hopeful to see at least one of them tip the $100. Come on, we got to be able to get to that. Come on, let's see if we can.
Well, pink's pretty close, so let's see. It'd be nice if I'm surprised if it was yellow that did it. You know.
Yeah, that'd be cool. Well, I got all these colors. I like them. I like them a lot. This is great, and it's a great opportunity because as we've learned, it's gonna take a while before there's gonna be new sets available.
Yeah, that's
quite a bit of a process there still. So,
all right, so Jimbo, are you ready?
Sure. Good morning, guys.
Okay, we're gonna turn the spotlight over to you, and Yuri and I are gonna step out, and we'll have some audio. But we're gonna give you full screen so that people can see your stuff much easier on the live stream.
Yeah. Hey, and Jim, I understood you had requested to at least have me on audio, so I'm gonna put my video on stop. I'll keep my audio on.
Yeah.
Jim, can we just ask you do a quick introduction, because a lot of people know you, especially those people in the hobby for a bit longer. They've seen you in many different projects. Some may not. Give us a bit of an intro.
Yeah, my name's Jim. Hello, everybody. I live near Chicago. Got my C64 out of the attic in 2013 and dove into this silly hobby. Been doing stuff since then. And then in January of this year, I got the Mega 65, and that's really kind of been my focus this year, is learning about this machine and playing with this machine.
So Mega 65, tell us a little bit about that, because that sounds a bit odd to me. We had the C65 prototypes that would come up on eBay for absolutely silly money.
Yeah.
That's but where does this thing fit? And tell us about the C65 as in the first place. What is that thing?
So I've got a little presentation, so why don't I fire that up, and we can go through that real quick, and it kind of talks to that. So great segue. So being totally into this Mega 65, of course I did a presentation on the Mega 65. So let's load that up. So I wrote this program that does the presentation, and wrote this presentation deck. Can everybody see that?
Awesome. On the C60, on the Mega 65. That's
correct. Correct. So here's what I thought we'd talk about today. What's a Mega 65? C65 and the Mega 65 specs, how they're a little bit similar and different. My perspective today is a user perspective, so we'll talk about that for a minute. Then I thought I'd demo a bunch of the features of the Mega 65, and then what I really wanted to talk about, why Basic 65 is so much fun. And as Jim alluded to, I'm like writing a game in Basic 65 right now, and it's just been a lot of fun. Yeah, so the Mega 65 is this team went and said, we want to recreate the Commodore 65. The Commodore 65 was never released, and that really provides some direction for this project. So they're always thinking about what would have Commodore done if they finished the Commodore C65 and released it, and then maybe what additional ideas can we put on top of that.
Hey, and then Jim, just before you get there, will you cover the C65 where it kind of fit in time and what the original intent was? Can you talk a little bit about that?
Yeah, I don't know. I'm not an expert at all the details, but it was in the early 90s, I think, as they started diving into this, and the Amiga was already out, and the idea was maybe we could extend our 8-bit product line and have a system that has better gaming capabilities, but is very cheap, and maybe that would fit in the market somewhere. So they actually created an engineering team and worked on this thing at Commodore. They did injection molded plastic. They did different revisions of the circuit board. They had a kernel and a basic that were, you know, somewhere near completion, but not complete. And then they probably rightfully said it's too late in the 8-bit cycle, and the Amiga is where we need to focus our time and effort. So they shelved the project, and then Commodore went out of business a few years later, and the C65s got wholesaled through distributors. And then so hobbyists ended up with these weird machines that had a Commodore 64 mode, but so then it became this like purple unicorn that Commodore hobbyists really wanted to get a C65 and figure out what Commodore was doing there.
Right. It's really odd if you think about it. The C64 obviously had a very long tenure. Professionals may have gotten to the machine that had triple capability, CPM, C128, and C64. And then this would have followed after that. But not only that, an Amiga was already released. You kind of wonder how that would have fit in any business plan, kind of looking back.
Yeah, and I saw somebody saying, well, it was kind of positioned as a low-cost gaming machine, and that makes sense, but, you know, they were trying to do that with the 500 and then ultimately the Amiga 600 also. So I don't know if that all would ever fit in the landscape of what they were going to offer.
Right.
Yeah.
So the Commodore 65 spec sheet. Let's talk a little bit about that.
Yeah, so it was still an 8-bit processor, but it did run at 3.5 megahertz. It had all the VIC-2 modes for graphics, but they added VIC-3 modes, they called it. And they were really kind of borrowed from the Amiga, the bit plane graphics, a hardware DMA blitter type scenario, high-res graphics, 80-column text, which we'll see here in a minute. And, you know, but it being an evolution of the C64 and the 8-bit product line, they put 2 SID chips in there.
Wow.
128K memory, built-in 3.5-inch floppy drive, and then they finished, or they were working on a new version of the kernel and a new basic 10, and then they had a Go 64 mode on there, and you know, all of us used to a Commodore 128. You type Go 64, you get this like super really good compatibility layer. The way they architected the Go 64 mode on the Commodore 65, it was never going to be that compatible. It was never going to work very well. The VIC-2 timings were a little different. The way people acknowledged raster interrupts wouldn't always work the same on the C65. And then one of the big ones is that with the new processor, they stole some of the, some or all of the illegal opcodes and made them new codes, new commands. And so anything that used illegal opcodes was going to break. So the compatibility was not very good.
Wow. So and the unit that we see physically there, the Mega 65, and you're getting to what is being added there from a physical appearance, though, as we see on your right hand side, is that what the unit would have looked like, the C65?
Yeah, they really, I think they even scanned in the top cover, so the whole A surface here is like identical to what the C65 looked like. Obviously, it didn't say Mega 65, it said Commodore C65. There's a C65DX or C64DX moniker they're using for a while too, but it had the joystick ports on the left. Nothing on the right because the floppy drive was here. And then on the back, of course, the ports were a little different. Okay. And we'll talk about that a little bit here. But on the Mega 65, you know, they pumped up the processor. It could go up to 40 megahertz now, which is amazing. You know, of course, they implemented the VIC-2 and VIC-3 modes, but they also added a VIC-4 mode. And I haven't done that much with this. I haven't done anything with it, honestly. So I was researching it for this presentation, and I was getting excited to try some of those new modes. But basically, a lot of the color restrictions on text and sprites have been removed in this mode, and they've added a raster rewrite buffer, which provides pseudo sprites, so you can have a bunch of sprites on the screen at once, or a bunch of movable object blocks, or whatever you want to call them. Pumped up the memory, not only the main memory, but there's also 8 megabytes of attic RAM, they call it. It's slower to get to that RAM, but it gives you a ton of space to store data, right? 4 SID chips plus digital samples, and then they finished the kernel in BASIC and really added a few more commands to BASIC, rounded it out a little bit more, and call it BASIC 65. You know, like they added an SD card slot and some other niceties that I don't fully talk about here, like VGA out and things like that.
Okay. So really some peripherals to make it, you know, more useful in everyday life. But if I look at the added specs, obviously it can run so much faster now. That's very cool. But in the graphics, did they kind of take in consideration some of the bugs, if you will, for usability that the original had? Is that kind of what it's almost like a bug fix version with a couple of enhancements, it feels like.
So for the kernel and the BASIC 65, they really, they had to finish that. It wasn't done.
Okay.
Especially the BASIC 10 was not completed. So there are deviations from the BASIC 10 to the BASIC 65. But, you know, when they come to that decision, and I've seen this in their Discord forum, they're talking about what did the original C65 do and what can we do now? And we don't want to break old software. We don't want to change like the operations of the chips. So when you're talking about like the VIC modes and things, they're very careful to maintain backwards compatibility. So we're not breaking old software that was written for the C65 or the first versions of the Mega 65. And this is all, I kind of glossed over this, but this is all an FPGA driven machine. So they do have the ability to push new versions of everything and, you know, fix really core bugs that would, you know, on real hardware would be burnt into ROM chips or PAL chips or whatever and not able to be changed. So there is that ability to go back and bug fix some things. And, you know, this is really a fan run project. So there are continual process of tweaking this thing. So it's great. There's a hugely dedicated team. We'll talk about that a little bit here too.
How did you get exposed to this? First of all, did you have one of those unicorns? One of those C65s?
No. You know, I heard about it. I heard about, you know, all of a sudden there was multiple projects that were hearkening back to the 8-bit days of Commodore. And, you know, that's where my heart is, in the 8-bit days of Commodore. I never really owned an Amiga, so I never really played in that area. So when this project first started, got to the point where they're taking pre-orders, and they had like raised money and did this injection molded case, which is awesome. And so then they were doing pre-orders. I didn't jump on right away, but I think as soon as the first 400 shipped to customers with the plastic case and everything, I'm like, okay, I got to do it now. And I jumped right in there. And so, and then I got in, I think it's batch 2, which was delivered in early of this year.
Okay. All right. And then, so, and basically, you've developed quite a bit of software and hardware for the 8-bit machines over the past years. And I know you've also competed a little bit in the one-line basics and those type of things. This is BASIC 10, I think, this is a further enhancement to BASIC 10, if you will.
So they took BASIC 10 and completed some of the commands, added a few more commands. I think they rewrote the whole music section, and we'll see that on the BASIC game that David did the music on. So he was really happy with the way they restructured the music. And
Right.
if anybody's going to know, it's going to be David.
So how about this bass? Was the 128 was basic 7, if I remember correctly?
It was, and it's funny. I've got the Mega 65 book here, right? That comes with the computer, which is pretty cool. But I've been pulling out the Commodore 128 book too, because when I see something that they did in the Mega 65, I'm like, was that the Mega 65 team's decision, or was that Commodore's? And I go back to Basic 7, which I never really spent any time at. I'm like, oh yeah, Commodore was doing this on the 128, so this is not a new decision. So that's been kind of funny, because like every once in a while I scratch my head and say, why did they do it this way? And I look at the 128 manual. It's like, oh, okay, Commodore decided to do this in 85.
Right. So hey, you got this machine in the beginning of the year. This is going to be a machine that will be able to run BASIC at a very different level, I would imagine, with this much horsepower behind it, but also with so much more refinement in the basic commands being available. One of the things I remember from the Commodore BASICs, especially if you were in Europe, you'd get quickly compared to the BASIC of the Acorn BBCB, which was probably the best BASIC that had ever been created. So powerful, could do things on the same processor that were just like unimaginable to be able to be done in BASIC on a Commodore. Do you feel there's a leap from the C64 type of BASIC that you've been used to where we're now at with the Mega 65?
There's a huge leap in the BASIC from BASIC 2 to BASIC 10 to Mega 65 BASIC. Yeah, it's amazing, and I'll show some of that here in a few minutes. But you know, I kind of missed out on anything past BASIC 2, because I had a Commodore 64, and then I pulled that all the way through college, and then afterwards I'm like, oh, I got to go to a PC and grow up, you know.
Right.
And so I never played with the +4s or the 128 until more recently. And you know, the 128 had some really good commands and extended BASIC a lot, but running at 40 megahertz and some of the things that they did differently with the music commands really allow you to do a lot more with BASIC than you could have with the 128.
Got it. Oh yeah, let's go back to the presentation. It's amazing, really. If you look at these specs, it's incredible.
Yeah, it is amazing, and I'm glad. You know, they also debate like how far they should push the VIC-4 modes, because these are all new modes that they're envisioning, and it's really, you know, what maybe Commodore would have done after the VIC-3 modes. You know, with today's hardware and today's processors, you could have OpenGL type graphics in here pretty easily if you wanted to, but that wouldn't be like period accurate. So we talked about this. I'm a user. I'm not part of the team that is developing this machine, but they are very open source ethos there at the Mega 65 group. So, you know, if you want to learn to program in FPGA code and work on new cores or work on the Mega 65 core, very open and welcoming for that effort. They've got, you know, GitHub with change requests and pull requests and all that going on, open source. I think the only portion that isn't fully open source is the kernel and BASIC. They licensed those, the Commodore versions, and then of course bug fixed them and built on top of that.
So you bring up a good point. One of the fondest memories for most people is the community. It's the community of the 64. You know, if you had one and you go to school, you would share listings, you would at home. You know, it was a very we type of setup and help learn together. I know you work on several other hardware projects. You work on robotics with youngsters and things like that. You're very big in both contributing, giving back, and learning from the community. Is that, are you getting that same vibe from this environment?
Yeah, there's as is today, it's a very active Discord community, and there's people from all over the world, the West Coast of the U.S., Central Indiana, Germany, Australia. It's amazing. So whenever I wake up in the morning, there's new comments on there. When I'm going to bed, there's people still on there talking. So it's very active and engaging and fun environment, and so it's really cool.
That's awesome. Now you very briefly brought up the manual as well, huh? Can you just show that one more time? Because I think that is just something just exemplary. Look at that thing. Look at that.
Yeah.
That
So
is
this is
a real spiral bound proper manual.
Yeah, and here's the Commodore style definition of all the basic commands. So there is, I think, 5 books similar to this for the Mega 65, and this is like the user guide that you get with your machine. But then there's more with lots of data on the graphics and the underlying systems, and if you want to understand how the SD card works and the software that controls that, there's information about that. If you want to just look at it as like a Commodore computer, you can look at it at that level. And the documentation is immense, and so that's awesome. You can dive in at different levels. And they're even working on a new version of this user guide right now to get it printed, because things have changed and it's evolved, and let's get a new version and get it printed.
I just love that it's printed. Even that, it's just everything right. This is so awesome.
Yeah. Okay, well, let's go forward. So here's a picture of my setup with the box that it comes with, the user guide, and obviously the Mega 65.
Is that, do I see, are those like Tech2s? I see Tech2s connected there.
Yeah, I got 3
the original
Tech2s.
original 9-pin C64 joysticks.
So there's 2 C64 joysticks here, and then Paul, who basically is the guy who brainchild of this whole machine, basically wanted to recreate it. He came up with a paradigm to add 2 more joysticks to the cartridge port. Gerche documented that, and then I was able to make a little circuit board. This one doesn't have the plugs on it, but you plug that in and you get a 4-player joystick setup for your Mega 65.
Very cool.
Yeah, so that was a fun little project that I did this year. So I thought we'd go through some demos. C65 mode, Mega 65 mode, flasher configure, Go 64 mode in the cores. So let's do some demos.
Yeah.
And then we can talk about why Basic 65. I'm having so much fun with Basic 65 after that.
Awesome.
So break my basic program. That's the presentation program. So let me go to my sidebar and see what our quick demos were. Okay, C65 mode. You want to see what the Commodore 65 looked like that Commodore never released. I have the ROMs in here. If I hold down 1 while I boot it, it'll boot to the original Commodore ROMs.
Oh, original Commodore ROM. So what we're seeing here now is if you would boot up one of these unicorns, this is what you would get. This is like unaltered, if you will.
Correct. So when at the CRX show a few years ago, there was a Commodore C65 there. When it would boot to this screen, 1991 Commodore Basic 10. So this is the original. This is as far as Commodore got with the ROMs. So you can load those ROMs. You can play with it as if it's a Commodore 65. I've spent very little time here. There's some bugs in here. There's some issues here. So so far it hasn't been that compelling to me, but I thought it'd be fun to like download onto a disk like the old Commodore demos and be able to stick it in here and play it just like a C65. But I haven't done that yet. All right, so that's the C65 mode, the Mega 65 mode. I'll just power cycle it with not holding anything down. We're in the Mega 65 mode now. You can see it says Jim's Kick-Ass Mega 65. That's I have it running through a little startup script that launches different loads or attaches different disk images. That's what I'm trying to get to. Yep. So right now, if I do catalog, this is the disk image that's driving the demo program and some other stuff that we're working on today. So I have it automatically attaching that.
So and then the floppy drives, a built-in floppy drive writes on a format unique to the C65 or what the capacity? These what is this? Is this double density, high density floppy disk? What goes in these?
So right now it's a double density. It's rewrite compatible with a 1581. So I took my old 1581 discs and stuck it in there and just read them directly. So that's pretty cool. There is an initiative that, because the drives physically can support it, there's an initiative to come up with a format that can store on high density disks also, which would, double densities are harder to find. So being able to use high density and then use them at the full capacity would be pretty darn cool.
Yeah.
So I'm going to show the flasher and then and demo a game that's being produced for the C65. Let's do that real quick.
Cool.
So if I hold down the restore key, I go into the flasher, which allows me to do multiple things, but mostly people use it to attach new disk images.
So the flasher kind of reminds me of like the Ultimate cartridge, if you will.
It is, and it's so it's like an SDIC plus some utilities.
Very cool.
So you can change CPU mode and frequency, and you can go from NTSC to PAL back and forth here on the screen, which is pretty darn cool. Exit out of here. So I just switched disk images. So this one's different. If I go catalog W, it does a widescreen catalog.
Oh, very cool.
This is the one that we had at Vintage Computer Festival Midwest. Why is mount not working? I know what I need to do it. All right, I screwed it up.
Hey, that's like the old days. So
yeah,
that still works.
So I was supposed to type boot to boot that disk, but I typed mount and then it detached the image. So let me go back and reattach that image. So we're doing this one, VCF Midwest. And here's a shortcut. You can just use $ for directory.
Yeah.
All right, the disk is attached. And now if I do boot, it'll auto boot to it.
I can hear the very satisfying sound of the track head moving on a 3.5-inch drive.
So even though I'm running off the SD card, it cycles the physical floppy drive, so you get this impression of using the real hardware. So that's kind of cool.
That is super cool. The stepper motor going, that's so cool.
So this is like a high-end cool shooter that this guy is working on for the Mega 65. This is just a demo version.
Ah, yeah, an R-type like shooter. Very, very cool. Wow,
and
look
you
at
guys,
these graphics.
Yeah, it's tons of items on the screen at once. High movement, parallax scrolling. It's just obviously more than you'd ever expect on an 8-bit computer.
Right, and remind us again. This is with what, up to 4 SIDs being used? Is that what you said?
Yeah, so in this mode, they're probably using all of the Mega 65 features, which I think it's 4 SIDs. It might even be more. You know, it's
Wow.
they're emulated in the FPGA, and this also has the digital sound generation.
The
You can
sampling.
play mod files and different things on this too.
That is so awesome. Well, so
So
this
that-
looks pretty polished. This looks pretty polished already. So this is one of the games in development for the C65 mode.
Yep, and this is yeah, he's got 2 or 3 levels like fully fleshed out, so it feels like what he needs to do is sit down and just develop a bunch of levels, you know. And I'm sure
Right.
there's more behind the scenes that he wants to do with this too,
Right.
but it is pretty darn polished and pretty darn nice. All right, so what did we want to do after? That's an example of a C65 mode program. We saw the flasher. There's a configure program, but that's not that exciting. Let's skip that for now. Let's look at this Go 64 mode.
You know, the most used command on the 128.
Right. So it does reconfigure the computer with, you know, the C64 memory structure. It hides the VIC-3 and VIC-4. It only's got the VIC-2 exposed right now. You know, 1 SID chip. It reconfigures itself as much as it can to be a Commodore 64. And if we go in here and get a disk on there, load. Oh, and I got to do one other thing. This is a Commodore 64 PAL game. So I switched to PAL mode. Shotgun.
Wait, well, hold on now. Hold on. Wait. Uh-oh. PAL mode. So what you can go between the modes here as well for the C64?
Yeah, so that's pretty darn cool. Not only on the 120, I mean, sorry, not only on the Mega 65 can you switch between PAL and NTSC, but this is in the Go 64 mode, so it's really a subset of the Mega 65. We're still in the Mega 65 or in Go 64 mode.
Yeah.
And so it allows that switching back and forth.
Oh, that's awesome. How do you connect this up to a display, this unit?
So it's a VGA out, 30
Okay.
kilohertz, or HDMI. So
Oh, even HDMI. So you could
Yeah.
even, you know.
So right now I've got the VGA hooked up here in my basement, and the HDMI is going to my capture card for the video feed.
Very cool.
And so this is a game that was written on the Commodore 64, fun 4-person shooter game. You know, it's really kind of like something you'd see played at a convention or something.
Yeah, yeah.
And you know, it's fun, but it's not pushing the VIC-2 very hard, so it runs in the Go 64 mode.
Okay.
If it was doing a lot of raster timing tricks, it probably wouldn't work.
Okay. Is there, do you feel that there is significant effort on the going still to get that mode to be more compatible so that you could realistically use one unit and kind of put the 64 to the side, or?
So that's a great segue. Thank you, sir. Let's look at the cores. Because this is an FPGA machine, you can flash it with new cores. So if I hold down no scroll when I turn it on, I go to this core menu, and there is a Commodore 64 core for the Mega 65.
Okay.
So let's launch that. And so this is reprogramming the whole FPGA to operate like a new computer. It's no longer operating like a Mega 65 with a Go 64 mode. It is operating like a Commodore 64. And this is a port of the MR core.
Support the Nano DE10. Yeah, very good core for the C64.
And so this is a very recent little Halloween demo that was out on CSDB. So I pulled that over this morning.
Now that getting to this mode was very quick, I noticed.
Yeah, so there's what, 7 slots, and you can preload them with the core images.
Okay.
And then then with hold down no scroll during
Oh,
a
holding
boot up,
down. Oh, okay. And is that also with where you held down the numeric key when you boot it up, or is that
I
different?
held down, yeah, you can choose your ROMs with the
Yeah.
numbers here if you have them pre-set up.
Okay.
I only have three. I have the original ROM, I have an experimental ROM, and then the Mega 65 ROM just boots with no
Okay.
press.
Yeah, makes sense.
No scroll selects your core, and alternate selects a configuration menu. Sorry,
Yeah.
menu. All right, so here's the Halloween demo that was just released. So happy Halloween, everybody.
Very cool.
And I haven't tried this on a real on the Go 624 mode or whatever, but probably this is gonna crap out on
Yeah. This is
on
a
half-
modern
half
demo
core.
using all kinds of trickery. Yeah, I get what you're saying. But this via this route you can get to that, and you can get to that in PAL and NTSC. So that's very, very cool, obviously.
Yeah, so that is cool. So because you can flash this FPGA to be different chips, you can do things like do a Game Boy core. So this will allow you to run Game Boy games.
Okay.
Here's a ZX core, allows you to run ZX Spectrum type software. But I'm not sure which ZX machine, but
not that anybody would ever want to try that. I didn't say that out loud, did I?
I booted it and looked at it and like I don't know what to do next.
Yeah.
but this one's pretty cool. So this is Galga, and I booted this, and it did this, and I was like, oh no, it's not.
That looks like an arcade core.
It is an arcade core, and it's doing, I guess, the boot up sequence.
Yeah,
and you've probably
boot
seen
up
this
sequence.
before.
Yeah, that's how the arcade boots up. It's doing its memory test. Yeah, it goes through the full self test. Yeah, that's the original Galaga.
So here it is, and it's like, see which joystick it is. You know, it's running the original ROMs, and it's emulating the hardware. I guess emulation is not the correct term. Simulating or been reprogrammed to be the original hardware
implementation in FPGA. Yeah.
Yeah. So I mean, it is like perfect, just like the real arcade game.
Very, very cool indeed.
I don't know if you guys are getting the sound or not, but the sound.
No,
is
we're
perfect.
not getting the sound, but we can imagine this. This game is pretty easy to imagine what the sound was like.
Yeah, we all know it in our head, right? So that's really cool. So there, you know, been a couple new ROMs or cores came out recently, but you know, there's going to be more and more for this machine.
Yeah.
And like we said, there's 7 slots. Well, really 8 slots. I have 2 still empty down here. 0 is the factory core from the Mega 65, and then 1 is you see it says unsafe 60. So it's a development core that I'm running.
Yep.
And it allows me to do Ethernet transfer of files and some other things that are not fully released but are already working for people. And eventually they're going to come out with a new 0 core that they're going to ask everybody to program in there, and that will coincide with the next batch of delivery of units.
Yeah, so to that point then, it's not a retail unit yet, it's still all pre-order type of stuff, They produce them in batches, from what I understood, right? Well,
they do because of the supply chain issues and the small batches needed for a project like this. So they are actively taking orders on the Trent's website. So that's a professional electronic manufacturing company that's doing all the order fulfillment and procurement and distribution and assembly of the units. So it's really cool that they have such a professional back-end company doing this for them. But in the beginning, they're having problems getting certain chips. Right now, they're going through a redesign of the motherboard, the main board, and they're designing out, if I have the the story exactly correct. They're designing out some obsolete chips so that they'll have longer production capabilities on this new design. They're simplifying the design a little bit. They did add some additional memory so you can actually do bigger cores with the new board when it comes out. But they say for all 8-bit machines, probably most 16-bit machines, the one I have with the memory size will be, they'll fit in there. So I think it's great that they're tweaking it and optimizing it. They're getting rid of some little nit issues that other people had. So I think it's great that they're doing this. This is not abandoning the current motherboard at all. This is future-proofing the design for longer production runs in the future. But right now, they were waiting on some chips, and now they need to finish this board, and then they'll be able to produce this next batch of parts. So I think they delivered like 100 development units, and then 2 batches of 400 commercial units like this. So they're ready to do another batch, hopefully by the end of this calendar year.
All right. Very, very cool. Now we've got about 15 minutes left. I want to make sure that we cover what you wanted to cover. But obviously it's very easy to go on tangents with this. This machine is so much more powerful than I would have imagined. And it's interesting because obviously a hardcore user would have bought this for the strict C65 mode, if you will. But there's so much more you can do with this. It must be hard to kind of focus yourself on like, okay, what do I want to do with this? And I guess I'm trying to bridge to kind of what is for you? What is it for you that made you buy this machine and spend quite a bit of time with it?
Yeah, you teased me, right? You're just going to put that on your shelf and look at it, right?
Exactly.
And, I was a little worried maybe that would happen, but I got it. And I just had so much fun going through the manual, just like when I got my C64 and figuring out the new modes, the new commands. And, I've written a few programs in assembler for the C64, and I definitely want to do that on the Mega 65. But I've been having so much fun just staying in the basic mode that's all I've been doing so far. So let's talk about that real quick then. So basic 65 is fun. Yes, basic is fun. I've been having a blast with basic 65. And here's my top 10 reasons that it's fun. The first 6 all do with like screen editing and being able to like manipulate your program. So I'll show you some examples of that. And then the last 6, so it's really top 12, are all independent. 80 columns helps with editing. 40 megahertz is like just amazing that it gets through this basic program so quickly. If then begin and begin end, that actually was from basic 7. I saw that there. It probably was on the +4 too, but I never used it before. That does wonders for straightening out your code. Yeah. The keyboard's just amazing. It's a cherry keyboard with like beautiful feel. So it's really just fun to be on this keyboard and not, just developing on a PC and pushing data over. I figured out a way to date stamp my file names when I save them. That's fun. You can poke hex values, which is great. And then I've been using this edit on, which allows you to edit sequential files right from the basic prompt. So we can jump in and look at some of this. So I'm going to load my Battlestar Galactica program.
What a fantastic series, by the way. A great timepiece for basic.
And I always forget this. I'm supposed to use deload now. And so some of the things, and I don't know if you even put this on the top 10 list. This definitely is there. You can push F9 and F11 and scroll up and down in your basic.
Oh my goodness, what a luxury. What would we have given back in the day for that?
Right. Both directions. Isn't that amazing?
Oh my goodness.
Um, you know, it's got color syntax highlighting you can see on the screen.
Yeah, so awesome.
It supports indenting, so you can indent items on the screen and you know, see your program logic. So
Yeah.
I have an if then begin. So all of this stuff in here is part of, it only gets executed if the if statement is true, and then it ends the if statement here. So it's kind of like curly brackets in C, right?
Yep.
But once you indent it, then it really highlights, you know, what's really going on there and how the program flows. Here's one with even more indenting. I got one down here that there's no way I could have written this and understood what was going on without doing the proper indentation, because I've got nested if then begins all on top of each other. And I was just amazed this actually logically worked, but it did.
Right. It makes it look so much more professional already. Even if you're writing pretty garbled code, it just helps you kind of find back your way in your own basic programming.
Right, and it's running at 40 megahertz, so I'm not shy about throwing a lot of rim statements in there. I'm not shy about putting in blank lines to separate sections just with a colon in it. I'm not shy about just doing one or two items on a line and moving on, so that, you know, some of these have a lot of text on them, but some of these are, you know, I'm just doing a few things on a line so it's more readable and not worrying about compressing it all on one line.
Yep.
And then, like, let's say, you know, variables are either 1 or 2 characters long. Let's say you want to see if a variable is being used. You can do find b equals, whoops, b equals. Oh, okay. So here's a bunch of lines that have b equals in it. That variable is being used. If you want to find, let's see, I had an example here. Oh, let's say find, so I'm looking for the text string start.
Yep.
Oh, okay. Here's the start the new game routine at 8810. And since that's the last, if that's what I was looking for, start new game, that's the last one on the screen, I can just press F9 and start scrolling right there.
Oh, that's awesome.
Yeah. And it's got renumber, which is pretty good. You can't move sections and reorder sequences, but I could renumber this whole program with all the jumps, and it would maintain all of that. And I can renumber sections too.
Awesome.
So
that's amazing.
Yeah. So we got 10 minutes left. Let's see. What did I forget?
So wait, I think what you demonstrated here is just the sheer usability to maintain your basic code, to set it up, to make it readable, to not have to worry about doing commenting and being able to find stuff back within your code. I think that alone should be an enormous plus side compared to anything that you've used so far in BASIC.
Yeah, and it makes BASIC fun again, right? And it was fun back in the 80s when it was like what you could do and learn from the user manual. But we're so used to modern, you know, editors, and this still is limited, right? This still is the screen editor with numbers and things like that, but it's so much more fun. Like, a lot of the rough edges are gone now. I mean, going back to a C64 and programming in 40 columns is shocking.
Yeah, that must be.
I can't imagine going back to a Victory.
Yeah. But the whole tactile feel of working on a real unit rather than Vice and all of that's got a certain, not just charm, but I guess that the whole tactile feel is a different type of experience.
Absolutely. So why don't we run this game? Let me
So
see if
Jim, what you can do is make sure that your screen sharing has audio selected for it.
my screen sharing from OBS.
No, it's for your Zoom, I think.
Yeah, I have the
Oh, that's right, you're OBSing in, you're not screen sharing in. So
Yeah, no, he's feeding OBS.
yeah, and I've
Yeah,
got
so
the
do
cable
the audio
output.
cable thing, right?
I have the cable output on, so I'm not sure
Right,
why it's
right.
not working today,
Yeah.
but we'll
Okay.
run this. Let's see.
It may be without sound, but I'm sure there's going to be a separate YouTube video on the game itself at some point in any case.
Well, so David Youd, who was on a lot yesterday, he did the music for this, and he took the theme from the 1970s Battlestar Galactica, ran it through composer programs. I don't know exactly what he did, and was able to recreate it in Basic 65, and it's pretty awesome. So I'll run this and we see if we can hear it or not.
And this is running on 40 megahertz now.
Right.
No, we don't hear it.
Yeah, we don't hear it. So we won't be able to fix that.
Okay.
Technology
Well,
setup.
I don't know why. We had that working the other day. But so this is the game that I'm writing. It's all in Basic 65. Here, I'll start and this is a work in progress, so it's not done yet. But I got the main sprite moving around with momentum, with subpixel movement. So I'm actually burning up a lot of the basic time doing that. The enemies are using the sprite move commands, so they don't change, they don't accelerate or decelerate, but they keep going. I'm going to do one thing real quick. Find setup. Oh, that's not it.
Ships are still floating.
Yeah, because of the basic. Oh, here's start a new game. Difficulty equals 0. I'm going to go to 3 so that we get more of a movement of the enemies. So we'll see more movement of the enemies. So now the enemies think they're on level 3. So I got the enemies to fire at you.
Yeah.
You can shoot back at them. I can blow them up. I have damage. So it's really been really cool to be able to do this in basic, right?
That's crazy.
Yeah, and it's and I've done some tricks to try to speed it up and do different things. And I got a little slide on that. We'll look at that in a second. I know we only have like 4 minutes left, but it's been so much fun to do this in Basic 65 and do it at the keyboard, do it on the computer, live with the Mega 65, not doing it on a PC and just shoving it over and running it. And there's obviously use cases for that, and that's obviously a fun thing to do too. And I want to do that with assembly language. But right now I'm having a blast programming on the Mega 65. And we talked about the advantages of this new version of Basic 65, but there's even a Basic 11 environment. So you download this program and you run it, and it's actually written in Basic 65, and it gives you a full screen editor Basic with labels and no line numbers, and it just takes it another step further to bring it in. And when you quote unquote compile it, it just spits it out in line number Basic 65 code and runs it.
That's very cool too.
Yeah.
So the game that you wrote, the intent is to finish it up, polish it up, release it as a Mega 65 game.
Absolutely. So I'm gonna finish that, release it as a game to the community. They have these Mega Vision events with the Mega 65. So the next one that's scheduled, I'll try to get it done for that. So I always need a deadline, right? So
So Jim, I have one question and one comment for you. Question is, does the Mega 65 have a cassette port? Because I'd really like to get Yuri 1 for some suffering if it does.
Oh, bad.
it does not. They've
Oh,
got a peripheral board that they're working on to add a user port and composite out, and I'm not sure if a cassette port's on the deck for that or not.
okay. And then the other thing is that, as you know, CBM Program Studio has a Mega 65 mode. And so Arthur was our guest yesterday, and he was not aware that you had the Ethernet injection capability.
Yeah.
So I wanted to get him involved with that to figure out if he can actually add that into Mega 65 or into this CBM Program Studio for that support, because he would be happy to do that. Apparently, there's no easy way to do it, I guess, otherwise.
Yeah, I wasn't sure if he was talking about injection it into the emulator or a real hardware.
I think real hardware.
Okay. And there, like I showed you on the core screen, I'm running an experimental core that supports that, and it will be finalized and released as the official core when the next batch ships.
Cool.
So it's plenty stable enough for me to use on a day-to-day driver right now,
Nice.
but it could change again too.
Okay, well, I'll let Arthur know.
Yeah. So with the basic, there is accommodations I had to do to stretch basic to work that well, and just doing as little as possible in each program loop was key to this. But I have it so it can go through the program loop pretty much in one screen refresh. And then there's a vsync command where you wait for vblank before you execute any more code. So you're actually using screen vblank in BASIC to time your program, update graphics, eliminate any tearing of the graphics and things like that. It's pretty wild.
I can just imagine a future where we see some of the original C64 assembly demos being recreated in Mega 65 BASIC running at 40 megahertz as a proof of concept.
Right. So I got a paradigm in the game where through each loop, it only really updates one of the Cylon enemies, and then it resets and goes through. And right now I have it updating the position of the Viper, the main ship, each program loop. And I'm thinking about splitting that and only updating the Viper every other program cycle. And then I think I can get all of my routines, even with a lot of enemies on the screen, to fit in one screen cycle, even at 60 hertz. So that's pretty cool.
That's awesome indeed. So Jim, getting to the end of the presentation, you've been a supporter in the second round. The first round you skipped, but the second round you jumped on. You've had it now since January. You spoke of a redesign of the board that's taking place to add some more features, but there's going to be at least one more run in the original setup, if you will, with some bug fixes. I understood, but other than that, the board's pretty much from a spec point of view going to be the same. There's several other options coming in now in these type of retro boards, be it Stephanie's or being the 8-bit guy and several other smaller and larger projects. And
this one is really guided by, let's remake the Commodore 65, finish it, and then add some bells and whistles on top of that. So it does have a very specific project goal and lane to it. So those other projects that you mentioned, they have their own goals and their own lane, and I think they're all cool.
Yeah. So I think let's try and see if we can kind of wrap it up there as well, Jim. Who's buying this? You have, because you support many of these different projects, you're very likely to get yourself involved in some of these others as well. Buy this unit if.
I think if you enjoy basic programming from the 80s, this is a dream machine because you can do so much more with it. if you want to explore this new hardware, these new modes, the VIC-3 modes, the VIC-4 modes, and really push those to the limit, this is the machine for you. It's like a lot of these hobby things where I've gotten into them because I'm nostalgia for the 80s. But like to implement or to download and implement that Galga core, I had to run some Python scripts. So guess what? I had to like figure out how to install Python on my Windows Linux subsystem and run this Python script. So it's also growing my knowledge of modern computers too. So it's been a ton of fun. You can do so much with it, and you can go in so many different directions.
Yeah, you're a fan. You've made me much more of a fan than I was. I hope the pricing at some point will come down. It's an expensive unit. I think we're talking what, $800 maybe even a little bit more?
Shipped to the US, yes. There's a nice emulator, the XEMU emulator. So if somebody wants to play with it, they can download the emulator and really get going on that. And that's all David had to play the music that he wrote in Program Studio. So you know, he was able to develop that whole music that you couldn't hear without the physical hardware.
Yeah, well, I think he got that enthusiastic. He ended up placing an order for a unit as well.
He
so
did.
that even going through the emulator may get you enthusiastic enough to purchase one.
Sure.
Jim,
Thank you.
Yeah, thank you. It's been awesome to kind of see not just the unit itself, but also see you actually use it, and you know, hopefully soon bring an iconic game to this platform in BASIC, no less. Who would have ever thought to see something like this running in BASIC? So that is absolutely awesome.
Awesome. It's been so much fun playing with it, and thank you guys for letting me talk about it.
Yeah, thank you.
Thanks, Jim.
Okay, bye.
All right.
So,
that was awesome. I'm gonna good that this one is at the beginning of the day, because then you're busy, you can't do anything, you can't order anything of the internet.
on Sunday.
You're focused on this.
Yeah. So we'll just get right into the next presentation, which is going to be Keith, and you're going to be hounding on Keith.
Yeah, and I'll put myself. I'll probably put my video off again, so that's Keith has screen. We'll see.
Yeah, good idea. So before we start real quick, I wanted to say that you have put us over the edge with the keycaps on the auctions. We now have one of them that's 102.50.
Are you for real?
Yeah. So remember, the keycaps, all these auctions will end before the end of this presentation. So they'll end at 12:30 Pacific time. So if you want to get in on the auctions, make sure you do it now, between now and the end of when this presentation is. Otherwise, you're going to lose out. So without further ado, let's bring Keith in.
Excellent. You keep an eye on the auctions. We want to hear how that's going. Okay, Keith.
Can you hear me?
Good morning to you.
Yes,
we can hear you loud and clear.
Excellent.
I'm going to step out.
Okay, Keith, thanks a lot for making time for us. Maybe what we do is start with just a little quick intro of you to who you are, and we'll dive in it from there. How about that?
Okay. I'm Keith Greene. I am currently a web developer by trade, although I have done everything from aluminum fabrication to electronic design to garbage cleanup. Everything in between. I got my start back on the Commodore 64. My father was a big gadget guy. He was in the military, served in Vietnam, and went all the way up to Command Sergeant Major. And he was just a gadget guy. I mean, anytime a new Commodore computer came out, we had to get it. It's like, okay. So that just kind of, sparked me to get into it. And I learned some basic programming when I was a kid, and learned a lot of graphic stuff, and just kind of grew from there, So.
Yeah, Keith, I think we made the title of this presentation how a hobby became a profession, because I think a lot a lot of where you're at today and all of the paths that you've taken, both professionally as well as some of the stuff that you do on the side as a hobby and exploring, you know, commercial avenues and other, and giving back to the community on. It's all stuff that, I don't know, had young Keith ever expected to be involved in any of that?
No, not really. Young Keith didn't know what he wanted to do. He didn't. I think at one point I wanted to be an oceanographer, and then my dad took us to see Jaws, and that was that.
One movie did the trick.
End of that dream.
That's
Find
I can
something
imagine.
else.
I can imagine. So you said you started with the 64. And that really was your earliest memory. Were you like most others playing games and kind of maybe reading some of the magazines, typing in some of the code, or how was your early experience there?
Yeah. See, we actually had I mean, my dad had a PET and the VIC-20, but the Commodore 64 is when I was I was old enough to start looking into it. But yeah, I mean, I did all of that. We played the games. We got into there was a drawing. Oh wait, was it Koala Painter? I think it was
Koala Painter. Yeah, Koala.
Yeah, on the Commodore 64 that I absolutely loved, and I drew a lot of stuff in that. Played a lot of games. Went to a lot of copy parties because like a lot of people in our Discord know that I spent a lot of time in Germany as a older teen and young adult. My father was stationed in Stuttgart from, I want to say 82 to 87. So, I spent basically my formative years in Stuttgart, Germany. And then after we came back from Germany in 87, I joined the army and I ended up going back to Germany. And I ended up in Berlin, which was an amazing experience. That's we'll get into that later, but yeah, so the Commodore 64 was basically my start. That was where I started getting into learning about graphics and writing programs and all of that stuff, and it just kind of opened me up to a world of creativity that I hadn't seen before this. I mean, sure, I like to, as a kid, I like to draw, I like to do the coloring books and all that stuff, but being able to create my own stuff, on a computer like that and save it and then come back and work on it later, that was something that was just amazing. So
yeah, it's interesting. Yeah. So let's go back to those early years. Indeed, I remember I worked hard to get myself a Koala Pad, and mistakenly I thought that if you have the Koala Pad, you become creative.
Oh yes,
turns out it was a lot harder than just having the tool.
Yeah,
but that was a pretty magic piece of device. For those that haven't seen a Koala Pad, it was a pretty simplistic, half a sheet, not even maybe a quarter of a sheet size of press sensitive on off only. It didn't have any other pressure.
Exactly. It was all digital. And it was about postcard size.
Yeah.
And pen and
it had a little pen indeed, and you had to press hard enough for it to work, but not so hard that it wouldn't work the second time anymore.
Yep, exactly, because it was so easy to just scar those things just by going. And as a young kid, a lot of kids have this kind of grip on the pen instead of this kind of grip on the pen, and so they're just mashing into it. So let's say you try and buy one off of eBay today, and you'll end up getting a bad one probably.
I agree. So what would you typically be experimenting back then with? Were you really getting your paper drawings onto a computer, or were you trying to what can you remember from how that started for you?
Well, I did it all kinds of crazy stuff. I did I remember one of the pictures I did was a Bosch spark plug that I saw a picture in a magazine and I wanted to replicate it. And so I did. And I went through, I drew lines on the magazine ad, separate, splitting it vertically and then figuring out what colors I was going to, how I was going to make this color. And it probably took me 2 weeks to draw that spark plug, I thought it turned out well. Another one I did was it was based on an old Dodge Challenger. but it was futuristic. It didn't have any wheels. It looked more like a shooting brake than a sedan, but it was meant to be like this kind of hover car
Right.
thing. And I called that image like next year's model or something like that. But it was, it was all fun. But a lot of the other stuff that I did that I think actually helped prepare me for doing work in the adult world was my dad used to do like presentations, because like I said, he was in the military. He was full-time Army, and he ran, he was command sergeant major when we were stationed in Stuttgart. And so he ran, a large company of troops. So he had to do things like briefings and things like that. So I would actually do stuff for him, like make a cover sheet.
That's
for,
awesome.
for one of his presentations because we had an Okimate printer.
Oh, wow. Yeah.
The color printer, the Okimate 10.
That was a real nice printer back
20,
then.
Yeah, it was. Those thermal printers. I love those things. They were so cool. So I would print these cool things for him to put his cover sheets on his presentations. And other his coworkers and everything would talk about, oh, that was such a nice cover letter cover you did for that presentation or whatever. And but it was just kind of neat stuff to do.
Right.
I was so hungry to learn how to do things that I would hey, do you need me to draw any graphics, that kind of stuff.
Hey, you try. So if you kind of think about that 64 time, at what moment in time did you, because you probably traveled around then for a little while, even with your C64, if I kind of do the time mapping of when you were where, so would you drag your machine with you as part of that?
Yes, yeah. I had it with me in Berlin when I was stationed in Berlin.
Wow.
I had my Amiga 1000 with me, and I had my Commodore 64 with me.
so the Amiga 1000, obviously when I remember when I saw it for the first time, and it was by the way at the Hanover Messe back in Germany.
Yeah.
When I saw it the first time, I was like, wait, that can't be real. It had the same effect on me as I remember seeing in the arcade, seeing Dragon's Lair.
Mm-hmm.
I thought that's just impossible. What I saw wasn't real. Can you remember, because you're first gen, if you got the Amiga 1000, you must have bought it right away. What do you remember of that?
I was working in a store. We had in Stuttgart, we had what was it, Patton Barracks, I think is what it was called, where we lived. But then we had there was another area called Robinson Barracks. It was, I think, closer to the main base.
Yeah.
Patton was just family housing and schools.
Yeah.
Right. And then Robinson Barracks was also family housing and schools, but it also had the big shopping area.
Okay.
Right. So it had our little mall, our PX or BX, and the commissary and all that stuff. And there were a lot of what they called local national shops.
Yeah.
Which were, shops run by German people.
Yeah.
And one of them was a computer store, and I worked there. And the guy who owned it was named Wolfgang Durst.
Yeah.
And he was my boss. And that was the first time I saw the Amiga 1000 was working at that store. And it was amazing.
Yeah.
And I talked to my dad about it, and he's like, yeah, we're getting it. And I'm like, okay.
Your dad has been a great enabler, clearly. You didn't even need to convince him.
Yeah, he was.
That is awesome. That is awesome. So tell us a little bit about what changes in the hobby then, because you go from a C64 koala pad using the tools there to then a machine that had, we went from $16 to what, 4,096, and like, wow.
Yep. And deluxe paint, we got the package that came with deluxe paint. It came with Marble Madness.
Oh yes, yeah, I remember.
A bunch of different EA games. Marble Madness was awesome. I love that game. That game is so crazy. Being able to play it with a mouse, it's like that was so different than anything else.
It was the first exposure to a mouse. I did have one on the C64 at some point as well, but it didn't work all that well. GEOS and all, it was all a little bit hokey, if you will.
Yeah, exactly. Yeah, it didn't do as well.
So did you jump right in there? Did you because the Amiga brought two things really. It brought the painting programs that would allow you to kind of go and make stills, if you will.
Right.
But it also had something on the video side, and then a third leg it had, which was for most people the first time they would see it, just because of the processing power, was some 3D and 3D
Oh, yes.
modeling, which was
Oh yeah.
like something you may have seen on television prior, but not something you would have ever, had
Right.
on a home computer.
Right, exactly. The juggler demo was amazing. I'm like,
Oh yeah. Oh my goodness. Yes.
yeah. And then the Boing Ball.
Yeah.
Boing Ball was another great one. It's like,
Right.
man.
So
But
were
yeah,
were you at that moment in time thinking like, okay, now I've seen some of these things, there must be a way I can now do this myself as well? Or how did that work for you?
initially, I don't think I was really concerned about the 3D stuff. I don't know that I made the distinction between 3D graphics and 2D graphics at that time.
Oh.
I just thought it's a cool animation. What did they do to do this? And then I, remember learning that it was ray traced. Okay, well, what does ray traced mean?
Yeah.
Oh, well, they're bouncing light around inside of an environment and figuring out how that light bounces, and then they, basically paint a picture using that. And I'm like,
Right.
well, that's kind of cool. And then I started getting into like actual 3D. There was a couple of cover discs that came out, because I probably didn't get into the 3D stuff probably until about late 87, maybe early 88.
Okay.
And that was because there was a couple of cover disc magazines that came out that included like 3D modeling demos.
Okay.
Right?
Yeah.
And it was really simple stuff. Like you could plot a triangle out.
Yeah.
In space.
Yeah.
And it gave you like three viewports to manipulate it, and then a perspective viewport to view it.
Yeah. Yeah.
Right. And then you would have to and I remember like building a really simple ship. It was basically like a little diamond shaped thing that I built out of polygons, just basically little triangles. There was no texture maps. It was maybe 7 or 8 polygons, most, but it had this little pointy tail and a pointy front, and it kind of looked like a manta ray type thing.
Right.
And I had to move all the points individually on the polygons to match up with the ones from the other parts that I was building. Yeah. And nowadays, you're building, you've got primitive shapes and extrusions and everything's just so much more complex and easier at the same time. But
right,
amazing how far it's come.
Yeah. So at that moment in time, because you'd already be studying for a career at that moment in time, you'd be well into that. Had you at that moment in time made like a career choice that kind of would match up here anywhere, or was this still kind of something still that was a hobby that was just absorbing all the time, separate from what that may be looking like as a career?
Yeah, because 87 is when I graduated high school. My father, he died like, I want to say 2 weeks after I graduated. So kind of a rough time for me.
Yeah. Yeah.
But I wasn't really, I knew I wanted to do something with computers, but I wasn't sure what that was. And I just kind of assumed that I would need to go to college. The problem was at that point, there wasn't really any college for the kind of stuff that I wanted to do. There was there were courses for like mainframe, CS, heavy CS degrees. And I'm like, I don't want that. I want to do cool stuff on these computers. I don't want to work on big banks of tape reels and right.
I don't
want that.
There was a 20-year gap between the school system, 10 years before what was current, and you were already 10 years ahead of where things were going. Right.
And I was like, I want to do something with this, but I didn't know how. And like I said, my father was in the military, and he absolutely loved it. He had just, right before he died, he had passed his over 40 physical, and he had re-enlisted again. He had been in for 22 years and was going to go another 3 years, just because he loved it so much.
Yeah.
And when I was in high school, he would always talk about, you should at least give it a try. He was not one of these one of the
drills. He wasn't pushing it. It doesn't feel like pushing it, but he was just sharing the love for for the great career that
he enjoyed doing the work, and he made a life out of it, and he was very happy with that.
Yeah.
And he tried to encouraged that in me, all through high school. He's like, you should at least try it. You don't have to stay.
Yeah.
Give it a try. If nothing else, it'll give you a good start.
Yeah.
And then after he died, we came back to the States. I was working as a cashier at Albertsons in San Antonio.
Okay. Yeah.
And I'm like, this is not
who
what I
I am.
want to do.
Yeah.
It's not,
Yeah.
I don't want to be a cashier. And I'm like, all right, you know what? I'll give it a try. And I didn't even tell my mom. I just went down to the recruiter and I signed up.
Yeah.
And I signed up to be a 31 kilo, which is a telephone. Wait, is it 31 kilo or 31 try? I don't remember what it was, but basically a telephone repairman.
Okay. Okay.
For
Technical
infantry. I was a cable dog. We ran wire. We set up telephones. We set up switchboards. We also I also cross-trained later to 31 Charlie, which is a radio operator.
Okay. Yeah.
And ended up being a ComSec custodian in our unit in Berlin.
Yeah.
But at that time I had no idea what I wanted to do.
So it's interesting, because you basically you came back to the US when your father passed away, tried something local just to kind of get through the period, if you will, I would imagine, and then enlist and go back to Germany to do a very different part, from Stuttgart and Berlin. For those people that aren't like from that area, that is very different. Berlin is probably the most artsy city. Find maybe in the entirety of Europe. It's super exposure to anything next gen, very so you get a life there based, military. I will presume pretty well paid, not a lot of expense.
Well, that's the thing about the military. The military is not very well paid in terms of money, but what the military does is it covers everything.
Oh, your cost,
Yes, I'm in Berlin. Literally every bit of money that I get from my paycheck is spending money. It's not, I don't have to buy food, I don't have to buy toiletries, I don't have to buy any of that crap. It's all provided. My meals, my housing, it's all provided. So it's pretty much all spending money.
Right.
Or saving money if you want to do that.
Yeah, whatever. Whatever.
What is that?
And you come there in the best time possible because the Amiga 1000 is booming at that moment. In time. So which means that you can spend your free time kind of playing with that and working on that.
Yeah, it was funny because I went to basic and AIT, advanced individual training for the military. That's your basic training, teaches you how to be a soldier. AIT teaches you how to do the job that they've hired you to do. Right. With a specialization. So I went through basic and AIT basically with the same group of guys. We were all going to commo school, and pretty much all of us ended up in Berlin, which was actually kind of a cool thing. But at the end of AIT, they're handing out assignments, and all these guys are, I get handed one that says I'm going to Berlin, Germany, and I'm like, hell yeah. And these other guys are getting them, and they're crying. I mean, like, these are 6 foot tall dudes, standing there bawling next to their bunk, and they're like, I'm going to war. And I'm like, what do you mean you're going to war? And he's like, I'm going to Berlin. And he's like, you're not going to war? Where the hell you get going to war? It's like, no, dude. I'm like, Germany is awesome. You are going to love this place. This is no reason to cry. And the issue was that most of these guys had never been outside. Never been on the paved roads. Yeah. They've never been outside of their small town, let alone, this was their first time out of state, because now they were in Georgia, going through training, as farthest they've ever been. And now they find out that they're going to a completely different country halfway around the world. I mean, I can understand how that would be traumatizing. Right. But still, you have to explain to these guys, no. You are in for the time of your life. Right. Yeah, which is and that's super cool. You're there. How did you continue? Because obviously when your dad was still there and you were very close to him, and you basically got a lot of encouragement from the environment that he operated in, both in just cool gadgets, but also putting it to purpose, right? Creating stuff. How do you get back into that then? Because it's, especially with the Amiga, it's, it could be very easy to start just doing gaming and only do that. You do your day job and at night you game, as many people did with the Amigas. Yeah. I enjoy gaming as much as the next guy, but I'll play a game and then I'll stop playing it and start looking at what makes it tick, you know,
Okay.
and how did they do this particular graphic, and how did they do, you know, this
Okay.
particular sound effect? Because I'm also into audio too. I mean, I do dabbling. I don't do anything professionally audio wise, but I have a lot of fun with it, so I have a lot of interest there too. As far as like development, I got into web development because I initially wanted to. Okay, let me restart that. I didn't go directly into development. I started my professional career with what was it? Damn it, what are they called? EDS, Electronic Data Systems. They do
Yeah.
a lot of
Another
government.
EDS are here, by the way.
Oh, nice.
Best
So,
company ever.
yeah, I started with them back in '93, and I was a graphic designer. We were working on a project called the Knowledge Management Network for the AMED, the Army Medical
I know exactly what you're talking
in,
about.
in San Antonio, Texas.
Yeah.
Oh, and the building, the website was hosted in the building, and they had Fitty Ring, and it was terrible accessing that.
Yeah.
And trying to get anything done, but I did a lot of graphic design work for that, and we had another guy who was our actual developer, John, and my boss, a guy named Dave Nuttall. And it was hilarious. He looked like Benjamin Franklin. I mean, spitting image of Benjamin Franklin, like from Money, Benjamin Franklin. He looked like that. I used to give him shit about it all the time. But he introduced me. I think we were using Perl at the time, and he introduced me and John to PHP.
Okay.
And he's like, it's so much faster than Perl, and we're gonna do the whole website in it. And I actually started messing with it, and that's when I made the decision to stop being just a graphic artist and start doing actual web development. And I learned PHP very quickly and started doing heavy back-end development. I'm like, why just make pretty pictures when I can do this stuff on the web and make things do things, functional websites can use. So that's why I got into development, and that kind of put 3D on a back shelf for a little while. I ended up working. I ended up leaving EDS. I don't remember exactly why. I think the project ended, or the Army abandoned it at the time.
Okay.
Because what we were trying to do is we're trying to set up this network where people could like video conference, like somebody in the battlefield.
EDS ran the largest alternate network to the internet back in the day, and it was a completely private U.S. Army network.
Yeah, and what the goal was to have people be able to, like, if a surgeon in the field in a battlefield has run into something that he can't solve, he can video conference with a surgeon back home who can walk him through it. And the problem was, the idea was great, but the infrastructure just was not.
It was light years ahead.
There was no way to do this. So the project was abandoned, and I ended up leaving EDS, and I went to apprentice with he was my uncle by marriage at the time, a guy named Tom Trebotich, and he was working as the head fabricator at a company called Autotest in San Antonio. They are still around, and they build power supply test equipment.
Okay.
Big rack-mounted, huge devices with serious power supplies in them, and zero insertion force mounting interfaces. And we built power supply testers for everything from PCs to concert, lighting equipment to torpedoes.
Right.
We built power supply testers for torpedoes. I didn't even know torpedoes were electric. It's one of those things you don't think about. But then you're like, well, what is it going to be? A gas engine underwater? Probably not.
Yeah.
But yeah, it was.
So during that time, it's interesting. So you make that move. You all of a sudden find a career in something that you got exposed to on the Amiga, and say, okay, I'm basically reverse engineer. It's kind of like the story of someone that takes apart the radio and sees how that thing works. You would be doing that and being inspired by the software and the games that you would touch. Right. Then you are able to make a living out of something that wasn't documented yet. Thank goodness you didn't go and do that in school, because it would have never been covered.
Right.
But you got exposed to that. what happened with your hobby, let's call it hobby career on the side with the Amiga and all? Was that still with you? Did you box
Yes.
it up and kind of not touch any of that? What did that
Oh,
look
no. I was still, messing with my computer daily. I was in Deluxe Paint, doing some graphics all the time. I did a lot of crazy stuff. I did back in San Antonio. I actually did a lot of ANSI art for Crystal Pistol BBS.
Okay.
In San Antonio. It was one that a friend of mine ran, and he wanted to get some ANSI screens because people were starting to do that now. I think baud rates were up at like 1200 at that point.
Yeah.
So you could throw in all the bells and whistles that you couldn't do at 300 baud. So we started building these ANSI screens, and I did this one with when you leave the BBS, it just scrolls up this big picture of a dude with his pants down mooning you.
That's awesome.
But yeah, so I was still working on the Amiga, and it's funny because at Auto Test I ended up doing so many different things there. Like I said, I started as an apprentice fabricator for Tom.
Yeah.
And then they actually I don't even remember why, but he moved me into drafting. Robert Cox was the guy who owned the company, and he moved me into drafting.
Okay.
And I started, designing parts. Started designing like aluminum.
What was drafting fully digital there already?
Yeah,
or was,
yeah,
okay.
It was.
Okay, they moved fully digital. Yeah.
Yeah, it was AutoCAD, I think.
Yeah. Oh gosh.
And then once we started doing drafting, because we were making me and Tom were basically making custom aluminum parts for the power supply testers.
Yeah,
We built a lot of zero insertion force.
Yeah.
Panels, so we had to lay out pins to match whatever the pins were on the
right
power supply, and that would be manufactured out of like a Delrin board or something else to prevent sparking. And it was a very cool experience to learn all that. They even had me doing board layouts.
Wow.
For making some of the power supply control boards and stuff like that. And then it got to the point where Robert actually bought 3D Studio Release 4.
Okay.
And he had no idea what he was going to do with it. He's like, it's AutoCAD, but you can make cool pictures with it. And I'm like, what do you mean? And then he's like showing me demos. He's like, and I need you to learn this because I want to do cool renders of our products for our webpage. And I'm like, okay, let's this is very complex. Let's see what we can do. But I messed with it, and I basically figured it out. And we ordered there was a course in Austin that he sent me to, like a 2-week getting started course.
Yeah.
That I don't know whether he ordered it or whether it came with the 3D Studio software, because that was an expensive software package back then. I mean, it was like $6,000.
Yeah.
Or something. So I think it probably came with the course.
Yeah.
And I started doing 3D graphics for that, as well as doing, aluminum fabrication and things like that.
How did that at that moment in time? Because you worked with AutoCAD, and then you still had your Amiga as well. From a software point of view, usability, kind of where they are and experimenting with the features and all. How did that compare or not compare at that moment in time?
Well, with the my work machine was not a Windows machine; it was a DOS machine, because AutoCAD and 3D Studio were both DOS.
We're still in DOS.
And
was that the one where you still had the big pad as well with the lens and all? Were you using that, or were you full the old school DOS still? So did you have any additional hardware on your AutoCAD, or was it still?
I didn't have like a drawing tablet or anything like that.
You didn't? Wow. Okay.
No, it was all mouse and keyboard.
Yeah.
Same thing with 3D Studio, and we had what were those drivers called? The Visa drivers.
Yeah, the Visa drives. Oh yeah, I remember the hell of
such
those.
a mess getting all that stuff to work.
Yeah.
And then you had to make sure that you were running at the right resolution and
right.
all this stuff. And we used there was some other software that we ended up buying for some game stuff we were doing at a time, because he moved me to another company called the Multimedia Store.
Okay.
Because he wanted to start getting into games. He was making a lot of money on the power supply stuff.
Yeah.
He wanted to branch out. He wanted to get into like games. But back then, the games he was talking about were like CD-run, like multimedia, like branching story type stuff.
Oh yeah, yeah.
Not like actual arcade
No.
games. He wanted to get into
No.
like the half movie recorded footage, you know, type things with some
decision making, decision tree type of
like a style game. And we started working on one that we were going to call Plunder, that was a pirate game.
Yeah.
And to aid with that, we bought another piece of software called World Builder.
Okay.
Which worked with 3D Studio.
Okay.
It was like they ran in parallel on the machine while you were rendering. So like you would build a scene in 3D Studio Release 4, and then you would launch World Builder, and World Builder would look at the scene data that 3D Studio was working with, and they'll allow you to build landscape like in that scene.
Yeah.
And then it would do this weird composite render where it would 3D Studio would render its part of the frame transparently, and then World Builder would render that part of the frame, and then they would do this weird shadow transfer to cast the shadows on the landscape. It was crazy, but it worked, you know?
Yeah. Yeah.
It worked, and it was funny the way it worked, but it worked, you know, and we rendered out a lot of stuff that way. We did some crazy stuff at EDS, or not EDS.
So that kind of game design, did you kind of like that? Because that was that fun to do? Was that because you know you're at the technological edge of the capabilities, like if you like the AutoCAD and all was very stable. It was a horror to set it up initially, but once it ran and never touched it, it actually would work.
Yeah.
Some of this other multimedia stuff was, you know, that was really cutting edge, and to then you know have that run every day reliably is you know, spend more time on that than actually doing the creative work almost.
Yeah, it was a pain in the butt, but see, I wasn't doing any of the programming on that. So I was literally just doing the graphics.
Wow.
So I would basically spit out images, pass them to somebody else, and they would do all of the rest of it.
Right.
But, that game never ended up getting finished. But it's hilarious because we also had Michael Dell.
Yeah.
We did a lot of video shoots up in Austin. So I remember one scene we were doing was a tavern scene. So we were in this warehouse in Austin, and we had a bunch of like barrels and boxes set up with green screen material over them because we were going to be shooting video and then compositing them over this internal view of a tavern that I was working on.
Okay.
And Michael Dell was involved in it. He actually played one of the pirates because back then he had long hair and a big
He looked like a total hippie on a pirate.
Yeah, exactly. Yeah. And that's pretty much what he was. He was a hippie.
Yeah.
And, so that was a fun time.
That is awesome.
We shot that scene and
so were you at that moment in time, you know, your income still steadily investing in more gadgets, and did you catch the bug from your dad?
Oh yeah. I was early adopter on tons of shit. Like I was always I always had like radar detectors for my car. You know, anytime like a laser detector come out, oh yeah, I got upgraded that, you know. Cell phones, I was early adopter on cell phones. I had one of the what was it, the G1, the T-Mobile one, and then the original Droid. So I try to stay up on my gadgets. I mean, you can see behind me, this is my Index VR headset back there. I've got a giant computer sitting over here with dual 3090 video cards. It's the size of a fridge. So yeah, I stay up on the gadgets.
So when you kind of see so software kept on, you know, improving. The Amiga 1000, there were a lot of updates for them. At some point in time, you know, you kind of like make the jump out of the Amiga world, which, you know, started to decline, obviously. Did you adopt PC early, late?
It was shortly after Autotest when I actually bought a PC.
Okay.
Because 3D Studio on that, I'm like, there's nothing comparable to that on the Amiga, and there's likely not going to be anything comparable to that on the Amiga right now. And I mean, I think Maya was out, but I don't think it was anywhere near as powerful on the Amiga as 3D Studio was on the PC. And in fact, Maya moved to the PC.
They moved to the PC.
Right
Not a
around
lot
that
of people probably know that it actually started back in the Amiga back in the day, indeed.
Yep. And in fact, one of the other tools I used, or one of the early 3D tools I used, was something called TrueSpace 3D.
Yeah.
Which actually also started on the Amiga as Caligari, I think.
Yeah, Caligari. Yeah, I remember that.
Yeah. That was a fun tool. That I actually had a lot of fun using that one, because that was actually a Windows. TrueSpace was actually a native Windows application.
Yeah.
So it ran, you load up Windows and run it in Windows. You didn't have to configure anything or figure out anything. And it was very simple, but it was very limited in terms of you could make something look really cool really quickly, but then you couldn't go farther, There wasn't really anything more you could do with it. It was kind of like an entry level 3D application, which was fine.
So do you feel that, like, going through this, and I know this talk we're kind of focusing it on the creative graphic type of a career path that you've been through in and out because you've been quite a few places.
Oh yeah.
Do you feel that those basics, starting all the way with the koala pad, then the initial light renderings that you were able to do, setting up 7 polygons, that type of, do you feel that you were building upon your knowledge, or did you feel like there's several moments where you kind of like, okay, this is now done knowledge and I got to start from the beginning again? Or do you feel like the industry really matured building upon pieces?
I think I feel like it built upon itself. I don't feel like there's anything that I've learned in my past that was like wasted. Even if the like using TrueSpace, I probably spent 2 weeks learning to use TrueSpace. I don't feel like that was wasted knowledge either, even though I don't use it anymore. TrueSpace is probably not even, I don't think it's in production anymore. But I don't feel like that was wasted learning or anything, because I don't think there is such a thing as wasted learning, really. Even if I'm not using the tool, it taught me things about how to work in a 3D environment. It got me comfortable with that kind of stuff. It taught me what the tools are going to look like, what I should expect from other applications, that kind of stuff. So even if it's not directly applicable, it's still useful knowledge.
So then when you moved to the PC, what happened with your Commodore stuff? Did you put it to the side? Did you box it up, or what did you do?
No, I kept it. I still used it. I mean,
you still used it?
Oh yeah, I still had. I actually retired the Amiga 1000 and ended up with an Amiga 1200. Well, an Amiga 500 first.
Yeah.
And then I went to an Amiga 1200. And that was I think that was the last one I owned back when it was,
Yeah.
It was fashionable. Yes, when it was kind of current. Yeah.
So did you ever pack them up?
I ended up selling them.
You sold, okay.
Yep.
Okay.
Yep.
So what made you decide to kind of start reacquiring some of that, and when did that happen?
That happened, I don't know, Saj can probably answer this question better. Me and him, I met him, I forget exactly how I met him, but we ended up going to one of the Commodore, the local 5Cs club.
Yeah.
Meetings.
You moved to Vegas by then, huh?
Yeah. Yep. Yeah. I moved out here in 2001, I want to say.
Okay.
And it was probably somewhere around 2005 or 6.
Yeah.
That I started getting back into the Commodore stuff. And I think I saw a post. I used to hang out at this forum called Ozu, OZZU. And it was it's like a developer board. It was just a PHP BB website.
Okay.
Some web developers used to hang out at, and somebody was talking on there about Commodore 64. And I'm like, man, I wish I had a Commodore 64 again. I would love to play some of those old games. And And he says, well, I have one, I'll sell you $35. And I'm like, okay, that's
Yeah.
that's cheap. Huh? So I bought one, and then I started looking at forums and getting back in. I found like Lemon 64 and a couple of the other forums. Then I found Reddit, and there's a bunch of different subreddits on there that it's all
Right.
collectors and stuff like that.
Right.
That got me back
So-
into it. Started building stuff too. So
Well, so and that's indeed, because I think what we'll do is we'll fast forward a little bit. So for those that hadn't guessed yet, when we did the two music events yesterday, day before, that was awesome. Every time you would see Saj and Jim coming back, you saw this background of theirs running.
yeah,
That background, all of that artistry, that's yours. You've
Right,
created that 40 event. Thank you, by the way. You created that 40 event. Now, that is way cool. Everybody has been enjoying that. But what people don't understand or may not understand, that's a render. It's a render of a full 3D designed. Every single piece is actually, you've created a room. You've created you didn't make a drawing and then put something in the CRT screens. You actually created.
I've created 3D models of Commodore 64, 1541 drives, the 1702 monitor, Amiga 500, the what's the 1080 monitor, mice, joysticks, floppy disks, disc notchers, disc boxes, Chuck E. Cheese tokens. I've made models of all this stuff.
All to create this one render.
Right,
you know, so here's the guy that got himself a koala pad, just like myself, probably in the very same year, maybe even from a store very close by to where you obtained yours.
Quite possibly, yes.
And and here we go. That it's quite remarkable. And none of that, and all of that, to a very large extent, self-taught.
Yes. I tried college on a couple of occasions. The first time I went to college was I tried to attend San Antonio College for graphic design, and I dropped out within 6 months. I'm like, no, I don't want to sit here and go through courses that I went through in high school. I want to learn graphic arts. I don't want to have to learn all this other stuff. I don't care if I get a degree. I want to learn this. And this is not the way I want to learn it. I don't want to have to sit through 2 or 3 years of 70% ancillary courses to learn some graphic arts. I'm like, I'll learn it on my own. I'm not going to pay for that. That's not, I didn't want to do that. I didn't find any value in that. And then I tried to do electronics engineering at one of those career institutes, the fast-paced ones where the prerequisite courses are like an hour course and a test.
Yes.
And even that one was too slow for me. I ended up getting kicked out for non-attendance, but when they kicked me out, I had a 4.0 grade point average. So I'm like, I clearly don't need to be here to learn this. So why do you have a problem with that?
Right.
So
And I don't know, are we set up to show something or are we not? Do you, Keith?
I have one of the things I have up here on the screen is for Saj's video, we did the spinning chip with the lightning coming out of it.
Yes.
And we did that. That's actually it's a pretty neat setup. I learned it from a tutorial, but it's basically the lightning is created by geometry nodes. Let me share my. Well, I'm just going to switch over to. Is that it?
We can do that. And what I'll do is I'll stop my video, and that way you'll automatically go to full screen. Can you tell us a little bit just on the setup? What do you typically use today? What do you typically use today to work on? What are some of your preferred tools, and what do you run that on? Kind of like the basics of that.
Okay, well, this is Blender. This is Blender 3.6. I don't know if it's the most recent, but it's a relatively recent version of it. The next big version that's coming out is 4, and I think that's coming out in late November.
Okay.
That'll be cool. But a lot of stuff that I do modeling wise, the models I build in an application called Rhino, which is a NURBS modeler.
Okay.
Blender is a polygon modeler, which means that when you're looking at it, it's individual polygons, right? So
Okay.
this is a face, this is a face, this is a face, that's a face.
Yeah.
NURBS modeler doesn't do that. NURBS modeler is surfaces. So
Okay.
whereas this curved surface here takes 1, 2, 3, 4, 5, 6, 7, 8 separate polygons to make up. In NURBS, that would be one surface.
Okay.
And it's an actual curve. It's not flat segments, because that's another thing you see here. This is just flat segments that are arranged so they look like a curve at larger resolution. And to be honest, we're looking at the pin of a SID chip here.
Yeah.
Never going to see those flat surfaces.
No.
When you're out this far.
Yeah.
But the thing about NURBS is that is a single surface that is not polygonal. And if I want to export it with only 4 surfaces, I could. If I wanted to export it with 32 surfaces, I could.
Right.
That's kind of the beauty of NURBS, is it gives you basically resolution independent modeling.
Right.
Whereas in Blender here, when I build something with a set number of polygons, that's pretty much what it is, unless I want to do some kind of weird subdivision surface and then try and smooth out the wrinkles.
Right.
So I do most of my modeling in Rhino, but I do most of my rendering in Blender because it's so much easier. Same thing with animation. I do it in Blender as well. So
Right.
this is a very simple animation. It's just I think it's 430 frames. Or is this? No, this is 380 frames. And I don't know if you're going to get audio, because this does have an audio track.
Yeah, audio, I think audio will probably filter. So we're going to have to imagine that. Oh, no, we got a little bit.
That's probably coming through my mic, though.
Yeah. Yeah, so this is what we recognize, obviously, from Sash's set.
Right. So basically, it's just a simple rotation. But the lightning is actually controlled by the audio. This is the lightning is what's called it's a geometry node setup.
Yeah.
Let me select my pin there. We go to our geometry node editor.
Check
And
that out.
This is what it looks like. This is basically the group input. We create a bunch of branches. The first thing we do is we create a curve, which is a single segment that goes between the endpoint, which is a sphere.
Yeah.
So out here, I've got these spheres.
Yeah.
Right. That's just an endpoint for the lightning.
Yeah.
I've got them set up on a circle, which controls the spinning, but the lightning just basically goes from the pin to the circle. And when you start out in the geometry node editor, it's literally just a straight line. I gotta select the right thing.
Yeah.
So it starts out as just a line. So we end up adding segments to it. And then we create this distortion panel, which has a bunch of different inputs, time input, multiply, noise texture right here, which actually makes it shake like lightning.
Yeah.
And then we add some smoothing, we add some plasma methods, smooth out things a little bit more. And if you can see, it's just a big network of stuff. But right down here is the sound input. And we're basically taking, over here on this side, we've got a plugin called Sound Nodes.
Yeah.
And I've taken Saj's, the sample, the drum beat, the bass loop that he sent me, and I load it in here, and then you analyze the audio. And then you plop this on the scene, and this allows you to control things by plugging loudness into different things. And in this case, we've got it plugged into the combine XYZ for the material, which actually controls brightness. And then we've got it coming in over here to multiply the actual amplitude.
Yeah,
of
the amplitude of the line, so that the
Right.
straight line all of a sudden becomes like a
Right.
graphical.
So when the base goes loud, the lightning goes, you know, and flares out. And it's all done programmatically. So you don't have to, I don't have to manually animate all this stuff. So that's kind of the cool part about these. And now this is just a what's called an Eevee render, which is basically a real-time render.
Yeah.
But even on this, it doesn't render fully real-time. The Glow does not.
Right. But amazing that you can do this right now, by the way. How
Right.
long did it take to render your one light source 7 polygons, Amiga?
Oh, the old one? Oh my God, that was hours.
And here you're doing, here you do a quality level up with how many, God knows how many polygons.
There's 188,000 vertices in here. 186,000 faces.
That's crazy.
Yeah,
It's just
374,000 triangles in this.
so. If you see where you're at now with this, in how much is the creativity being inhibited by the software? The level where we're at now.
At this point, the only hindrance I think is you know, the learning curve, basically.
Right.
Just I see stuff online all the time, and I'm like, how did they do that? And it's fascinating. There's so many cool things that Blender alone can do. I mean, not by, you know, it's not the only one that can do it, but Blender is this huge open source project that just, when I first started getting into it, I'm like, oh, it's a cool 3D program.
Mhm.
But it's not just a 3D program. It's got a built-in image editor. It's got a built-in Illustrator tool like Adobe Illustrator.
Yeah.
Timeline. It's got a built-in code editor. You know, you can write Python code in Blender. It does so many things. And then there's
all open source.
All
I know
open
you're
source.
a huge fan of open source, and you open source a lot of what you've done.
Yeah.
Back to the community as
Creative
well.
Commons.
Yeah.
A lot of stuff like that.
So this is an open source tool that you use by choice. This is not a financial decision. This is just, this product is so good.
Yeah.
That's
I don't have a need to. I mean, like Rhino, I pay for Rhino.
Yeah.
But to me, it's worth it. There's no other NURBS editor out there like it, as far as I'm concerned. And I've been using it for years. So
yeah, that's the thing. You're a user expert on that, and the steep learning curve to move to anything else realistically, if they even.
I mean, Blender has a huge learning curve, although it has gotten better because, and we were discussing this last night. Recently, they changed the UI in Blender to be more consistent with industry standards. Right. So like the Mayas and the 3D Studios and whatever other applications they're currently being used in the professional world. Unfortunately, that has had a big impact on learning because Blender's been around for years. So a lot of the content that was already out there on how-tos is now pretty much, it's no longer correct because stuff is not in the same place that it was.
Right.
Those instructions were made.
You're gonna have to kind of redo some of that.
Right.
So Keith, it's impossible to capture in an hour and a half or more kind of what you do. But I do want to bring a couple of other things because I love you, man. Your creativity, man, is such an inspiration. I've got a creative daughter, as you're well aware. You are, and son, you're always super gracious to them, admiring and encouraging them. Tell us a little bit about all these other things, because I don't think you're going to go back to Albertson anymore, are you?
No.
As a shopper. Maybe as a shopper.
Yeah. So I've been doing, a lot of 3D printing lately is one of the big things I've been getting into. I've got a shop set up downstairs. I've got 3 printers right now. 2 of them are resin printers. One of them is an FDM printer. That's the filament deposition model, the one that draws with plastic spaghetti. The resin models are the ones that basically pull objects out of the liquid vat. And they do that by UV projecting light underneath it and rendering it to cure the plastic. And you can make cool things like this, my little Amiga 500 here, the mouse.
That's just awesome.
You know, it's got the floppy drive on the side. Even my mouse is, there's a bottom on that mouse.
Yeah. Crazy.
You know, and you can get some really cool detailed stuff. I'm working on, I do a lot of Star Wars stuff because I'm a huge Star Wars fan, and my camera just went out of focus.
Oh yeah.
I hate
Technology
that.
hasn't improved. That technology hasn't improved as much yet. So Keith, to that model of the Amiga that you just made, obviously creating parts for printing, and then even between the different forms of printing and fabrication is obviously, they're all different nuances, because you got to keep the production process in mind. I can only imagine that your metal fabrication days are actually going to help you even with this. You kind of know how it needs to be created and the limitations of some of this that you now reuse in your design thinking processes.
I use all the stuff that I learned when I was, you know, when I started designing stuff in 3D at Autotest, and also the manufacturing process, you know. I was working on, we had a nice, it was an old mill from like, I want to say 1953. Right. But it had been retrofitted. So it had all the digital controls on it and things like that, which was, I thought that was just really cool too. Have this thing from 1953, have all digital controls. It's like, how did they do that? Right. But it was still pretty cool. Let me see if I can switch over. Maybe fix my camera zoom, because it's not.
You need to pull it off and on. Yeah, maybe that works.
It doesn't like you.
Yeah, it doesn't.
You want to just get close with your hand and zoom back out?
Yeah, slowly. Yes, I've tried that too, to try and force it. I just put my hand up here, you know, and then do this, and then.
You got a pair of glasses you can put on it?
Here, give me just a second.
Yeah, well, while you do that, I think Jim, you tried to jump in because of the auctions closing, right?
Yeah, so the auctions they ended, and the red was the winner at $132.50.
Holy! Wowzers!
So so the only auction that has not ended is the disc notcher, which ends tomorrow, because eBay only has like 1, 3, 5, and 7 day auctions, and I ended up doing this the day of the event, and I needed a 2-day auction. It didn't work out, so you know, Monday will be the end for it. But yeah, we actually went through 10 sets of keycaps for the auction, so that was awesome.
Wow. That's awesome.
Hey, Keith, we can see you again.
Yeah, Keith is back on.
Not blurry.
Okay, so let me try and wrap up with Keith, and then I think for next year we probably should set up a part 2 as well, Keith. Hey, Keith, I think what's been really neat. This all started back in the old days. I hate to say it, but with the koala pad, which for me ended everything, and for you started everything. It kind of feels like. Now, creating original art, reversing existing objectives into digital art and digital models, fabricating these, making these at different scales. The Amiga 500 that you just showed, that model can also be used for some of the artwork that is used in the performances.
Oh yeah,
same models, but gets tweaked different depending on, is it for on screen versus is it for SLA versus is it for FDM versus is it for. I think being able to kind of combine all of those worlds, and all started out of a geeky hobby, supported by a great dad, clearly a very, very, very cool man. It's just awesome. It's just such a cool story of how many of us kind of owe our career and a lot of the fun and friendships that we've built over the decades from something that started with like a humble little, bag of chips called the
Yep.
Commodore 64 that was made to last about 5 months, if we believe
Right.
some of the family stories.
Yep. Yeah, it's been a fun experience, you know.
There's a
I wouldn't change it for anything.
I agree, and Keith, you know, thanks a lot for all you've done for us as part of CRX crew, for the teams at the C5 as well, the Vegas team. Hopefully soon, hopefully next year we can do a live event again.
Oh yeah,
as well.
yeah, that'll be fun.
You know, funny story, Keith. You know, Keith is always ready for action. A few years ago, I had an opportunity to buy out a complete repair center in Vegas, and I remember flying in, and in the morning I gave Keith a quick call, and I said, "Hey, Keith, I think I've made a bolt a little bit more than I thought it would be, and you know, are you busy today?" He said, "Well, let me take a quick shower and I'll pop over." And I remember saying, "You remember, Keith?" I said, "Maybe not take that shower."
Yeah.
We spent a good 12 hours loading up, you know, the greatest collection of Nevada dust in history.
Yeah, but it was
I think another story made, and something I'll never forget in my life. It was just so much fun, and just very gracious on your side, Keith. Keith, thanks a lot for making time for us, man. Thanks a lot and we haven't been able to show all the other things, the models that you've made over the years.
Next year I'll,
SX64, the SX64 label. That's so many.
I'm actually thinking about doing another run of those. So if anybody needs any, or if anybody wants like custom, like if you want to try and build a DX64, I can make you a label.
Right.
Yeah,
That's awesome.
super cool. All right, Keith, thanks a lot. If you have time, hang out a little bit in the channel as well. There's quite a bit of talks there as well. Show off some more of the stuff that you've done, and thanks a lot, man.
Thank you. Thanks for having me. Take it easy, y'all.
Jim,
All right.
we got a bit of a break still.
Yeah, a little bit. So we got like 20 minutes before we were scheduled to do our next presentation. So we got a little bit of a lunch break, I guess. If you want to grab a bite.
Yeah.
And I can put the Slay radio on, we can listen to, and be back at 1 p.m. Pacific time. And yeah, I guess we could just go to break, I guess, huh? Since you've been talking.
Love it.
All right, man.
Thanks.
I'll see you in a bit.
See you in a bit.
All right, we're back. We're back from lunch.
Yes, and so Robin has some family obligations while we're going to be displaying this video, but he's going to be back on the forums later to jump in. He's next up on the agenda. What was your lunch?
What's my lunch? I had some
what was your lunch?
pepperoni sticks and a cheese stick, I think is what I had for lunch. So, you know, typical quick midday snack.
I had tacos.
Nice, nice.
Yeah, it was nice.
Nice. So I know that we aren't supposed to say much about this video because it's kind of like surprise, really. So I don't know how much setup we can actually do, but you're the guy that did this with Robin. So what can you say?
Well, and to make it worse, we're going to bury the lead in the video for about 15 minutes before we finally get to it. But once we do, it's pretty cool. There's a big Easter egg hunt that went on for a decade that I didn't know about, that Robin told me about at VCF Midwest. Oh. And we've taken the time to show where this all happens. But I'm sure that there's many more things to find than what we were able to find. So it'll be fun to see what viewers come up with in the coming weeks.
Oh,
but that's probably all I should say heading in.
Okay, then I guess I will go and locate this said video.
Yeah, push the button, Frank.
Well, so kind of, yeah, well, you know what? Zoom isn't very friendly about letting you prep anything. Wow. So you have to like go from one directory to the next while you're working. So
it's generally when there's somebody behind the curtain going.
Yeah, pretty much. Are you ready?
Yeah, hit it.
Okay, here we go.
Hello. So for those who may be recently joining, welcome to CRX 2023. I'm David Youd, and I think we'd all like our next presenter to introduce himself.
Hi, it's Robin. Thanks for inviting me, David.
And thank you for joining. It just wouldn't have been the same if you'd not, without the hi, it's Robin. So thanks for that. And it was really good to finally get to meet you in person after communicating online for so long at VCF Midwest. That was the first time I'd been there. I know you've been going for years and years. And while it's not a Commodore event, I've never seen so many Commodore people in one place before. So that was pretty cool.
Yeah, I'm really glad you were able to make it to the show. It was great meeting you in person. There's actually a reason there's so many Commodore people there. Do you want a brief history lesson on it?
Absolutely.
Yeah, VCF Midwest has a direct connection with a Chicago area Commodore users group, their annual show, and I attended it every year going way back to 1997, and that was called the SRAP, or Southwest Regional Association of Programmers, southwest of Chicago. And they finally quit putting on annual shows in 2006. Then my friend Jason Compton started his own show, same time, same place, and called it the Emergency Chicagoland Commodore Convention, ECCC.
Emergency.
For short. Yeah. And the emergency was that the previous show canceled suddenly, and us nerds had been very used to heading for a big Commodore show in Chicago every year. There wasn't going to be one, and Jason solved that by renting the hotel himself. Then the VCF Midwest guys started sharing our venue with us in 2010. And then as the years have gone by, they've taken over running more and more of the whole show. Like now they run the whole show, but a whole bunch of us Commodore people remain kind of a show within a show.
When you and I were there, we were talking about YouTubers and unfinished episodes, how everybody has, you know, these piles of notes and incomplete research, and you got these things on the back burner you want to finish, but for whatever reason, they're just sort of languishing around. And I was saying, do you have one of those that you might be able to turn into a CRX talk? And you do, which is why you're here today.
Yeah, that's right. I've actually got like dozens of video ideas that stalled out for various reasons. I think I've only I started describing them to you, and you really seem to like this particular idea of examining the covers of electronic art games, you know, like here's a couple. And I think, in fact, you had just found a new to you EA game and purchased it and showed it to me there at the show. And then, you know, I happened to point out, did you know? And you took it from there.
Yeah. Actually, I don't know if this is important or not. I think this was the EA game I got. I don't think it qualifies for the list we're talking about. So I think we looked at another one that I didn't purchase that fits in with the theme of our talk tonight.
That's it. That's
Yeah.
it. Okay. Yeah. Yeah. Thank you, Dave.
I'm sorry. Yeah.
So before Electronic Arts became evil, which, well, I'm not saying they are evil, but a lot of people seem to think they are now because they're such a huge corporation. They were actually a pretty cool company when they started for at least a couple reasons. Rather than get into video game consoles when they formed in the early 80s, they embraced home computers, and they especially got into the brand new Commodore 64. And they really gave full credit to their developers to the point of promoting them like rock stars with their name and pictures in and on the packaging. And actually the packaging, I think it wasn't an accident that they imitated the record gatefold. And if you open one up, this is just kind of random, but the authors, and there's a whole page, a whole section there about the developers of the game. So this contrasts with how Atari, for example, treated their programmers, giving them no credit, giving them a flat salary. This was the idea, yeah, you guys are rock stars, and these are artistic endeavors. These aren't just games. They aren't just a commodity. This is electronic arts. There's actually a neat advertisement. Electronic Arts comes to the Commodore, and it was a big 2-page spread, and this was to launch their first 5 games: Hard Hat Mac, Archon, Mule, Murder on the Zindenhof. How do you say that?
I can't pronounce it either. I should have looked that up before we talked. I knew we would run into that.
There's actually a note up at the top of that ad that says, "Make note of that name, Electronic Arts. It may well set the standard for sophisticated entertainment software in the 80s." And I think that actually did turn true. Electronic Arts was definitely one of my favorite developers during that whole Commodore 64 era.
Mine as well. Epic's following closely behind, but yeah.
Yeah, and actually just to name some of those games: Archon, Mule, Racing Destruction Set, Mail Order Monsters, all by Electronic Arts. They were all hugely popular with me and my friends, especially because they all had competitive multiplayer modes. We actually just loved to play those games against each other. And of course, the Bard's Tale series was amazing at the time.
I still have my graph paper maps from that.
Yes.
That took a lot of time.
Yeah. I think I played that when I lived in Australia in 1987. It was actually before I made many friends there. My family moved there just for 1 year from Canada to Australia, and it was playing Bard's Tale that was a really amazing experience for me while I just stuck at home. Yeah. When you load an Electronic Arts game on the C64, there's a very iconic loading screen. That was also the source of many arguments with my friends, and maybe some of you had the same argument in the school ground or whatever. Did it say ECA, maybe Electronic Computer Arts? Or was it EOA for, I don't know, EOA? Or is it just EA with a circle in the middle? Was the globe representing the Earth? Like, was it a sphere? Supposedly all three are just geometric shapes. In 2 dimensions, a square, circle, triangle, or in 3 dimensions, cube, sphere, or pyramid? Or what's that thing that looks like a pyramid but isn't?
Yeah, the tetrahedron. So I was reading a book recently on a flight. I think it was back from VCF Midwest. I don't know. I've been doing a lot of business travel, but it was called Amnesia Remembered. And it's about this game right here, this text adventure, written in Forth, by the way. And the author was reverse engineering it all just to see how it all worked. But a good book. But he was talking about the EA logo. And apparently when they filed for their trademark, they specified it as a tetrahedron. So I have found that online. just to confirm that that's the case. The poster that you see here, this is the We See Farther poster. This is an early EA marketing campaign. You can see the tetrahedron there again. Also on that flight, I was reading this Retro Tea Breaks book. Richard Garriott, the progenitor of the Ultima games, as you well know, was talking about the cube, the sphere, and the tetrahedron because he wasn't getting along with Electronic Arts at the time. And so he wrote in his Ultima 7 game, he said the sphere, the cube, and the tetrahedron were chosen to be in Ultima 7 as the falsehood, hatred, and cowardice, the three anti-principles in Ultima, but they also happen to be the three main shapes of the Electronic Arts logo, which I liked. That's pretty funny. My friend James Brooks worked for EA for years and years. I'm not sure if he's still there, but in the mid-90s, he got me foam versions of these. So I have this foam block.
Huh.
This is the foam circle, the foam ball. And this is decidedly not a tetrahedron. So that's a pyramid baby. It was just easier to cut foam that way. But it's fun to have the actual loading logo in foam.
Yes. Yes. So a pyramid has 5 sides and a tetrahedron has 4 sides total.
Yep.
Including the base.
I got a squishy die one right here. That's a tetrahedron.
There it is.
Yeah.
So it was actually the EA loader that got me interested in finding out the truth about the logo, and that in turn led me to learn something interesting about most Electronic Arts early games, and that is, did I already say this? That the logo's 3 symbols are actually hidden in the cover artwork. So somewhere on this cover is the EA logo, somewhere on this cover, and, well, David?
Yeah, it's we've been burying the lead for a long time, but that logo has been hidden in a lot of games. It's in every single one of these, and it's in every single one of these as well. I have an embarrassment of boxes over here, but we're going to be showing that here pretty soon. It's in a lot of the box artwork there, hidden in there. What's crazy is this was a decade-long thing that they were doing, this Where's Waldo game that most of us didn't even know we were supposed to be playing. So, and people who are watching who have Electronic Arts boxes in their garage or behind them on the shelf, they are hidden there waiting to be found.
Yes. Yeah, it's amazing that I don't think I knew about this. So I just want to show these. Last summer, a viewer, Doug Ham, happened to be here in my hometown, and we met up. And he had actually made these nice little coasters here of EA art. Now, not all of these contain the logo, but a majority do. And I just want to say thanks to Doug for these cool little coasters.
Those are way too nice to put a coffee mug on.
Yes, I haven't used them for their intended purpose.
This is definitely living up to the show and tell part of your channel name. I have an EA thing I'm going to show as well. I made this about a decade ago. Here is the load logo. If I can fit this in the screen. This has been made completely in Lego.
No way.
Now, this is pretty thin. I did violate the cardinal rule of Lego. I used some glue because otherwise it would have fallen apart 10 years ago. Yeah, we'll get some negative comments for that, but can't pass up an opportunity to show that since we're on topic. So
That's awesome.
Thanks.
I also just want to give a shout out to my friend Jim Leonard, aka Trickster, who is a founder of Moby Games, a pretty famous website database, cataloging video games, computer games. And he's also the programmer of the amazing 88 mile per hour demo for the original IBM PC. If you've never seen it, it's an incredible feat to see the 1981 CGA IBM doing amazing graphic effects and audio effects. And Jim also has a great YouTube channel called The Old School PC. And the reason I bring him up is he also has a lot of interest in this subject of the EA logos And he's actually done some research that we're taking advantage of here tonight. So I just want to thank Jim. So what I did, I attempted to make a chronological list of all of Electronic Arts games from their first decade in business. And then I tracked down the cover art online for games that I didn't have a copy of, or, just looked at my own collection as well. And then went through them one by one, trying to spot the symbols on the cover of each game. Now, some of them are really obvious, and some of them are well hidden, and some of them seem to be a big stretch. That is, they're probably just not there, but I want them to be. The reason I bring that up is that some sources say that the symbols were hidden in the first 37 games or something like that, but that doesn't seem to be true. But maybe I'm missing some qualification or something like that. And also, even coming up with a list of all Electronic Arts games is difficult because they also acted as a distributor. So many games that might be listed as published by EA in a database were actually only distributed by them, and they had no influence on the cover art.
Yeah, I have an example of that here. Like this one. So you see the sticker distributed by Electronic Arts on there?
Yes.
Yeah, for the golden oldies.
Yeah, and here's another example. This is Dan Dare. Actually, a bit of trivia. When Electronic Arts was just getting started, they actually were briefly called Amazing Software. Now, I'm pointing at that because this release from 1987, I think, says Amazing Software, but it's published or at least distributed by Electronic Arts. It says Amazing Software, and what they've done here is taken some of the best games from the UK. This is Dan Dare, developed in the UK, and done a North American release of that under this Amazing Software label, which kind of resurrected their original name. And the point is here that, the symbols are probably not going to be hidden in any of these sort of games, since the Electronic Arts studio had no involvement in the artwork. It was done over probably in England. Okay, so enough of all that. What a huge preamble. Let's start our treasure hunt. Or what were you saying? Where's Waldo?
Well, yeah, where's Waldo? Before we start, though, I do want to say that I don't know if anybody out there is listening to the Eaten by a Group podcast, the where they've gone through all the original Infocom games. They have this marvelous idea of the spoiler fence, and it means they'll talk about the game up to a certain point without giving too much away. We are now at that spoiler fence. Beyond this, we're going to show exactly where these hidden icons, the symbols, are in the boxes. So if you want to find them on your own, pause the stream now. So last warning.
Yes.
Okay. Here we go. Game number 1. And now these are, like you said, in chronological order, but not necessarily Commodore release order, because some of these came out on, say, Apple first or something like that, right?
That's right.
Okay.
That's right.
So Hard Hat Mac.
So yeah.
Yeah, Hard Hat Mac. I actually had this. I have this one on cassette, strangely. This was the UK release of it. But the symbols are visible even on here, but they're tiny. So take a second. Do you see them? And go ahead.
There we go.
Right there on the girder. So some of them are really obvious. Just a square, circle, triangle, or they're 3D versions. And some are harder to find. Go ahead.
Okay. This is the inside cover of Hard Hat Mac. Obviously not your tape version, but the album cover version. So
that's right.
And in this one, we can see coming out of the lunchbox are the shapes realized in 3D. You got the tetrahedron up there.
Yeah. Along with somebody's lunch.
Yeah, I don't know how they shot that photo, but it worked. So, next game.
Yeah, Mule, this one was a real surprise. It's a bit less obvious, but lots of great years playing Mule. But the thing is, I think I just had a pirated copy of this one, so never did see the lovely cover art. But go ahead.
And they're there.
Yeah. Little 3D objects that are kind of, I guess they're attached, like that square. Does it look like it's attached to the mule there? Its rear end?
Everybody walks away from art seeing something different, but no, to me it's floating.
They're all floating. Okay. So there they are, floating off in the sky in the distance, I guess.
Next up is worms. This one's a little bit easier, I think. Maybe not with the screens people are looking at, though.
Yeah, I think the cube is a bit easier, and the other objects are a little bit darker, a little more obscured.
There's the reveal.
There they are, hidden in the background. Again, these are the 3D versions rather than the 2D objects.
So on the inside cover, that's Maynard reclining in his probably house. They're actually on this one as well. You can see them revealed there. It's a little bit dark, but what they're showing is up on the shelf, you got one of these. On the ground, you got one of these. And behind the chair, you have one of these. So anybody who has this game, I should have probably brightened up the picture a little bit, but this is an uncommon one.
Yeah, this is a title I just totally wasn't familiar with, Word Flyer, and this Childware did a few kind of semi-educational games for EA, but this has a different way of hiding the logo. There it is. The kid riding the eagle is wearing an ECA or EOA t-shirt.
Next up is Last Gladiator.
Yeah, and this one was a surprise. Took me a while to notice this one because it's so tiny. And this is another game I'd never played. Probably just, is this an Apple or Atari game? I meant to.
Well, I played this one quite a bit back in the day. Yeah, it's a direct soft sprite port from Apple to Commodore.
Oh, okay, you're familiar with it.
Oh yeah, this is a fun one. At least I think it's fun. But it's another one that's tiny, so we got an enlargement here.
Yeah, and there it is near the, what are those, doorways? What do you call those? I can't remember the name for those things.
Arches, yeah. Standing stones.
Yeah, and this one, once you see it, it's pretty obvious. They're below the moon.
Yep.
Tiny little stars, but they're actually the three symbols.
Debug. I had looked at this one and decided it wasn't here, and then your note said it was.
Yeah, it's all coming out of that explosion down just to the left of the debug name.
Yep.
And there they are jumping out.
Yeah, there was so much detail in the picture, it got me focused on the wrong part, so that was well hidden.
Yeah.
Now the one we can't pronounce.
Yeah, Zindernoof.
I'm not going to try. This one's pretty obvious.
Yeah, I always say things wrong in my videos, so.
I didn't even bother to enlarge that one, so.
That's right, yeah, it's just so obvious up there near the nose.
And I'm surprised because I had many of these boxes as a kid. I don't remember having ever seen these because if I saw it, I think I would have caught on to the pattern, but this was a complete surprise to me when you mentioned that this existed at VCF Midwest.
Yeah. Yeah, if you don't expect to find this kind of thing, I guess we just don't look.
Yeah. We stepped into a parallel universe where the only difference is that these symbols are in the EA boxes and the Choco Taco is gone. That's the other difference. So this is a tough one right here.
Yes, and it might be kind of a surprise that Electronic Arts didn't just make games. They got into productivity software, and this was kind of an odd one, the remarkably simple word processor, cut and paste. And actually, the cut and paste feature wasn't very common, believe it or not, on word processors in 1983. Anyway, you'll find the symbol down there on the typewriter. What's that? The bar, the platen, and that roller bar that holds the paper in place. Yeah,
it's meant to look like a 3-hole punch, and so it blends in very nicely, right?
Yeah.
Yeah, that's another one that Maynard worked on after Worms. He kept doing helping out with fourth projects in EA after that program, after that title launch. This is a good one.
Yeah, awesome game. Love the artwork here. And yeah, this game just captured my imagination, running around these 3D mazes with zombies, and oh, it was just the best.
Well, there were so few collaborative games, right?
Mm-hmm.
Back in the day, not competitive, but collaborative. Yeah.
Yeah. Yeah, and there's the symbols, just guy climbing up the ladder there, and just to the left of his head, engraved in stone. Music construction set. This might be the tiniest example of the symbols.
Yep. I'll just zoom it now.
There it is, down the bottom right of the sheet music. Archon 2 Adept. A bit of a disappointment of a game. Did you like this as much as the original?
So I haven't given it a fair chance. Somebody at VCF Midwest was giving me lessons on it because I never really got into it, and unfortunately we got interrupted. I need to give it a fair try.
Yeah. Yeah, so the symbols are actually located on the wizard, the white wizard's robe there. And there's quite a few symbols, but there is just one unique for the circle, square, and triangle, just one instance of each. Skyfox, and there they are colored as well. Yes, right at the edge of the cockpit. Financial Cookbook, another one of these odd titles that I didn't even know existed. Probably written in fourth again, David?
Yeah, also written in fourth, yeah.
And there they are, little 3D versions of the symbols down in the bottom right corner.
This one's an easy one.
Yeah, this one is pretty easy. This game just seemed amazing to me when it came out, and yeah, there they are on the guy's robe, kind of in three. There's lots of them. Circles, squares, and triangles. And yeah, this game seemed amazing to me. The actual game itself, I just didn't find it as fun as I expected. It was the idea of it that was amazing.
Yeah, EA had a lot of construction set games. This was a good one.
Yeah.
Speaking of which.
Yeah, speaking of which, so a little pun. Did you ever think about how Racing Destruction Set is obviously a pun on all their construction set titles? And there it is, right on that car's bumper, the three symbols, another great game. I never played with this Movie Maker back in the day.
I did, but I made really lousy stuff.
I assume you don't have any of it saved, eh?
No,
Do you
thank
still
goodness.
No.
And there they are under that guy. What's he doing anyway? Some sort of dance.
Okay, so I did not find them on this one. I thought
yeah.
Yeah. But
So yeah,
They are kind of hard to spot, but they're just in the three corners, not the bottom right, but the other three tiny square, circle, and triangles in each corner of the squares in the three corners. I guess that's how to say it.
yeah, I'm glad we didn't try to hold up the box in front of the camera to show this to people. That would not have worked. The cool thing about this game is that Mangar is, the bad guy, and he has this chamber at the top of his tower. In order to get there, you have to find a silver circle, a silver square, and a silver triangle in the game. So there's an in-game reference as well.
Lords of Conquest. I happen to have this one. I think this is one you missed when you were doing your own run on it, eh?
Yep.
And there it is on that horse's, what do you call it, like a belt or something?
around the horse's neck.
I want to call it a belt, but like his tie, a horse tie.
Horse tie. There we go. The unscriptedness is showing through.
Yes.
This one I found, so I was proud of myself on this one because this one's a little bit tricky.
Yeah, it is. An Ultimate Wizard is a neat game. Like, this is one that some of my friends, we were mentioning Jason Compton earlier. He loves this game, and I wasn't even aware it existed. And then when I saw it, I thought, this is just a ripoff of Jumpman Jr. or Jumpman, one of my favorite games of all time. But I was aware that this arguably better Jumpman existed all this time with where it's Jumpman, but it's got all these spells and all these other gameplay elements. So it's a game I need to put a bit more time into. But anyway, they are hidden around the border. There they are. And it looks kind of random, but there is only one instance of each of those three symbols there in the border. There's all kinds of other moons and other kind of...
Very intentional.
Arcane symbols.
Yeah. Amnesia, I remember buying this in the bargain bin at the Kmart back around 1990, and it just seemed like what an amazing game to play. And you said you've been reading a book about it.
Yeah, I'll post a link to that in the CRX forums. It's a really good book. The hardback is crazy expensive, but the Kindle is reasonably priced. So,
okay.
And this one's tiny for the smallest one you were talking about earlier when you were talking about really tiny symbols. This one's pretty tiny too.
Yes. Yeah, it's just there over his shoulder. And I actually missed that one the first time I looked at this cover. And it was only on a second pass that I found it up on the, what do you call that? The matinee, the movie.
Marquee, probably.
The marquee, thank you. The matinee marquee, yeah. Robot Rascals, a really neat hybrid board game or card game and computer game. And there they are on the robot. This one seemed a bit more iffy to me, but I'm pretty convinced of it now, especially that triangle under the armpit there is very deliberate. And yeah, the square, the circle on the chin there.
And of course, the tattoo heart on the arm as well.
Yes.
Make your own murder party. And this is the first, I think, of a bit of a trend where they stick the symbols on a postmark or other kind of symbol, or what do you call it? Postmark?
Cancellation mark? Yeah, postmark. Sorry, yeah.
Square, circle, and triangle. And then the Destiny Knight actually has two instances of this. David found in the middle, you've got your square overlapping triangles forming, what do you call that? Is it a Star of David?
Yeah, I think so.
Yeah. And a circle. But then they also did the corner symbols again, like in Bard's Tale 1. Legacy of the Ancients. Super great game. Did you play this one, David?
No, well, I did, but never very far. So maybe I need to revisit.
Yeah. This was like, sometimes I like this better than any of the other RPGs. It's just amazing 3D world, and well, it had a really cool 3D section, and then it had an overworld area that was more Ultima-like. Anyway, the symbols are neatly hidden into the art in a way that's a bit more, well, I want to say advanced, but more adept than some of the others. Skyfox 2, and there they are around on the fuselage. This is really stretching my vocabulary, David. I don't know many words besides like A and hoser and donut and whatever else. So but yeah, there they are. Earl Weaver Baseball, and it's up there.
I think this one counts.
Yeah, it's a bit cheap, but there they are up there in that, was that medallion or something?
Sure, another fancy word. This one I missed. I declared this one not to have the symbols, but I showed it to my wife and she found them immediately. So,
Oh, good.
yeah, on that treasure chest lid right there. I know it's probably too small to see on the screen, but that's why we're enlarging it.
Yeah, nice job. I want to thank David for, he made up all these slides and did an amazing job with it. I just want to not forget to thank him for all this work. especially those zooms and all that. That's great work.
My work skills largely consist of PowerPoint, unfortunately. So now this one is definitely on my bucket list because it is incredibly unfair and it's designed to be unfair and hard. So someday I'm going to try to tackle Deathlord.
Yeah, it's actually one that, I do own the original, and pretty amazing art actually on it.
Here's the reveal.
The reveal.
Yeah, they're just on the inside of the cape. Hadn't heard of this one.
Mars Saga.
Saga.
Mars Saga. Yes, sorry. Sega. Nope. Saga.
Saga.
And there they
Saga, yeah. And there they are on the, on the stock of the gun? What do you
call that part?
Just on the gun.
On the gun.
Bard's Tale 3.
Yeah, same kind of thing.
Yeah, you got the triangle a little bit more obscured or covered up there, but there they are in the corners again. Oh, and the
square's rotated.
That's a diamond, David. That's not a square.
So, yeah, my game box had a sticker over the triangle, and I started looking online, and almost everybody's had a sticker over the triangle. I was finally able to find one example where somebody had taken the sticker off. So,
yes,
that was extra hidden on this one.
Yeah, mine also has the sticker on the corner there.
Yeah. So, FA-18 Interceptor.
Yeah, and there it is. Right up at the front of...
This example is on the nose.
That's terrible. That F-18, fantastic game, by the way. I played that on my Amiga, and that was maybe the first game where I felt like I was really in a 3D world, free to travel around, and just, at the time, amazing.
So this next one, Modem Wars, I've heard... is it Leaf? Is that his name? Did he get this one working with modern hardware, so you don't have to use a telephone line?
Okay, I don't know if he did that with Modem Wars. He's made his own modem games like this.
Oh, maybe I'm getting confused.
That also work over TCP/IP or over UDP, actually.
Sure, yeah.
Yeah, definitely check out Leaf's games. So I helped him with his, what was that racing game called? Anyway, it's like a driving game, but you can play it over the internet, multiple Commerce 64s.
That's cool.
It can be all over the world, yeah.
Well, what I do know is where the symbols are, and they are there.
On the guy's arm.
Yep. There's another one I never heard of, Fusion.
Yeah, so an import from Bullfrog, but interestingly, they did put the symbols on it, even though it would have been, Bullfrog is a UK development company, I believe. So it's interesting that they actually modified their art when, I don't think EA published them in the UK, but anyway, here in the North American release, they add the symbols.
So this is an example, Zany Golf, of a game. Many of these games have multiple covers. Some of them have the symbols, some of them do not. So this is the one that does have the symbols, and it's pretty easy to see on the green right there.
Yes, yeah, just to the left of the burger there. Ferrari Formula One. Oh yeah, I have this one too. And this is another one of those kind of cheating games where you look for it on the main artwork, but it's actually up on this sports legend medallion. So, you know, if somebody wants to exclude these ones from the list, I wouldn't blame you.
Yeah.
Abrams battle tank, and there they are right beside the cockpit. That's a popular place to put them.
So many logos they've shot.
Yes.
This could be the tiniest one, I'm not sure.
Yeah, you may be right. So yeah, this is another one where here's my Atari ST version of Populous, and like David was just saying about the alternate art, I don't believe the symbol's anywhere on this art, but David's got the other artwork. And there it is, kind of this, I call that the flat earth variation. And yeah, that tiny flag next to that castle has the symbols on it. Keef the Thief, a boy and his lockpick. I think that's named after a boy and his dog. That radioactive movie there. Yeah, and it's on his... No. It's in the treasure pile, isn't it?
Yeah, bottom left-hand corner of the treasure pile. It is astounding how many game covers have these symbols in. There's another game I don't know.
Yeah, Magic Fly. That's quite the name, isn't it?
Yeah.
But there it is down at the control panel near the guy. They like putting them on control panels, too. Centurion, Defender of Rome. And again, was that medallion or whatever? But there they are.
Yeah, I wish I had a clearer picture on that one, but it's definitely there.
Yeah.
And we're on to our last one here.
Can it possibly be over? Black Crypt, in this game, 1992. So that's about, 9 years after the first releases.
Well, that's a 10-year span. Yeah, from 83 to 92 is 10 years of this game. So right there.
Yes. And there it is on...
His hoof bling.
Yeah, his hoof... Yeah.
Hoof bling.
Hoof bling.
Okay, these are pretty much, I think, uncontestable. But we have some that are a little bit more dubious.
When I first heard about this, I'd heard that there were 37, or, the first 37 titles all had the symbols in them. So that's why I looked really hard in those titles, stretching credibility a bit, I think. Yes, definitely dubious. And when I was showing these to David, as much as I wanted to believe, David just wasn't having it for some of these. So that's fine. So we kind of settled on making this dubious section. So go ahead, David.
Okay. What I'm going to do is I'm going to outline shapes that might be triangles and circles and squares with these green shapes. So you're going to be able to tell what we're talking about because. So here's the next slide. Archon.
Yeah, Archon. So this one I'm more convinced of. There is very obviously a cube and a triangle. Those seem to be there on purpose. Now, what's missing is a sphere, unless you count the O of the of the name of Archon. But I can get Jim said that maybe it is the concept of sphereness. And when you look at this artwork, it's very angular. Like everything is deliberately, the art style is angular. Look at the dragons, how they're rendered. What's a 20-sided die, David?
Octahedron.
Yes. So this seems inspired by an isohedron. And the first time I ever saw a 20-sided die in real life, I was like, whoa, it's almost like a ball. I was like amazed by it. I didn't know you could get that many sides on a die. So anyway, I agree it's dubious, but maybe that is the sphere.
Next up. This one's definitely dubious.
Yes. The funny thing is that there is a sphere right in the middle, and that's where it belongs in the correct order, right? There's a sphere in the middle. Where it gets really dubious is, are those squares on the tiles? Yes. And if you squint hard enough, the shadow of the left hand really does look like a triangle to me. Like it's darkened, even the way it rides up the wrist there. But again, okay, dubious. Skater die does have a whole bunch of little symbols in there. And if you look hard enough, you can find a little circle, you can find a little square, circle near his skateboard, a square near his helmeted head, and triangles up in the top left corner. But I agree they don't feel as convincing as some of the others. Return to Atlantis. Again, lots of geometric shapes in the diver's mask here. So, I don't know. Yeah, there's cubes up in the upper right there. There are pyramids, but probably 5-sided, not tetrahedrons. And some sort of bubble floating to the left there of the mask. So
there is, if you enlarge it, there is writing on the building that does contain all three symbols, but I don't think that's intentional. Underneath the by the green triangle, yeah, but you have to really enlarge it. You have to have a nice scan, but I don't think it's intentional.
Oh, okay.
We'll see what people find after this video.
Yeah. And Wasteland, to me, it's super obvious that on the buildings on the right-hand side, there is a square and a triangle. There's holes in the side of the building, like they were hit by something. And again, if you squint, it really looks like a square and a triangle to me. But then the circle is the harder thing to find. David circled one possibility. Below the S in the title Wasteland, there's also a car turned on its side, and there's a tire, the dark shape of a tire there. That's also a circle. Okay, David's not having any of it. Dubious.
So that was quite the tour. I had no idea any of those things existed. I was quite surprised by some of the covers that didn't contain them when they took the time to draw custom art and then there was no symbols in it. So, but it was a fun Easter egg hunt. I'm glad I tried it all on my own first. I missed a ton of the ones that you found.
Just to look at a few others that I'm kind of surprised, just so you don't get the wrong idea. Yeah, like you were just saying, there are many Electronic Arts releases that don't have the symbols at all. So the official America's Cup sailing simulation, I looked, the sail is like a triangle or, there's a circle there, but this one really surprises me when you talk about custom art. We have mail order monsters, great game. They made this kind of like sculpture almost of a monster bursting out of a package. Again, it has the postmark here. There was lots of opportunity, but they did not take it. And I want to bring this one up, 7 Cities of Gold. This is one I was talking to Jim about. And again, this concept idea where could this be EOA, like the triangle and stuff? But David found some pretty clinching proof that no.
Yeah, that was a painting made in the 17th century. I think it's titled Arrival of Cortes in Veracruz. So it's definitely not there. But I'm happy to be surprised if some, viewer later on finds something. But yeah, I think it's just the painting.
Yeah. It's a painting that's existed for hundreds of years. At least the artist's intention certainly wasn't to encode the symbols in it.
So you do a ton of research. You present your stuff online, and then people post all kinds of stuff. Sometimes you have to re-release your Patreon videos in light of what they found. I can't wait to see what other people are going to find. I'm sure you and I have missed stuff, but this has been a fun Easter egg hunt.
Yeah, for sure. And did I mention yet this? I just want to say for Team EOA and those schoolyard arguments, for a little while, EA was putting this logo on their boxes with the second E being replaced with a blue square, the O being replaced with a red circle, and the A being replaced with the green triangle. So it just kind of says EOA, very direct mapping there. So maybe for the C64 loader, Team EOA was right after all.
Yeah, could be. I'd always said EOA, so I like your theory.
Yeah, one thing I didn't do was systematically look through EA releases from the 90s and certainly not post Y2K. So if people want to dig into this subject more. Who knows? Maybe there are some neat 90s games with the symbols that nobody's noticed. By the time of Black Crypt in 1992, it seemed like they had pretty much given up on that idea, but who knows?
Okay, well, on behalf of CRX, thank you very much for joining. This was a fun discussion. It was fun looking through all these things, and I'm hoping that your viewers find more.
Yes, that'd be great. Thanks very much to my patrons, and thanks to David for inviting me and for putting all this work into organizing the slides and so on. Thanks a lot, David. It's been a lot of fun.
We get the camera control and Zoom to work. We'll be back. Hey, so that was interesting. I'm not sure how many people actually paid attention to that back in the day, that every single one of these tiles has some kind of magical cube and a sphere and a tetrahedron somewhere on there. So, so take a look at all of your electronic arts, your box covers, and see if you can find something. Oh, Dave's back in here. So yeah, Dave, we should get people to be checking out all their electronic arts box covers right now. Oh, you're muted. There you go.
Sorry.
Yeah.
Yeah. Do you have any around as well, or you just always you have the discs for absolutely every single thing ever made, but you don't have the boxes, right?
You know what's funny is that I do have a whole stack of the EA stuff. So
of the boxes. Okay, cool.
Yeah. I have no idea why I have them, but I do. So
well, put them on auction next year.
well, it's funny. I actually thought about that. It's like I need to auction these because I don't, as you know, I don't like keeping the boxes because I have 10,000 plus Commodore 64 original discs and probably half as many original Amiga discs and all that. And I just don't have any instruction manuals really, or any kind of box other than EA for whatever reason. And then there's one exception. I also have everything that Psygnosis ever made, all the originals, because to me that was like the holy grail of all the developers. Because I got to meet those guys in England one year at World of Commodore, and I was pretty impressed with everything they do. So I kept all the boxes and stuff for those.
That's cool. I only found one of those that Robin didn't already have in his notes.
Oh, which is?
That would be the inside of Worms that had the twisty puzzles, the Rubik's Cube like puzzles.
With the background.
Yeah, I started looking inside of boxes. There's definitely some more things to be found, I'm sure. We couldn't have possibly found everything. But
so do you think all of them have in the fold out? There's probably symbols, just like you've seen before. A couple of them were that way, but do you think they're all that way?
Probably not. The Hardhat Mac and the Worms had some on the inside. I've been looking on the inside of other ones. There's lots of opportunities for wishful thinking.
Well, I noticed that there's quite a few that weren't in there, like one-on-one, Jordan versus Bird.
Yeah, Robin really wanted some spray paint near one of the players' knees to be the symbols, and I was just like, I was not having it. No, it does not receive the Youd stamp of approval. So yeah, but yeah, the one he showed, the mail order monsters, I mean, they took the time to really craft a custom image. It's like, why didn't you just put them in there? But yeah, it's just cool that secret's been sitting on my shelf for so many years, unobserved. It'd be interesting to know if other people knew about this. When Robin mentioned it, I went Googling, and there wasn't really anybody talking about it at all. So kind of fun.
Yeah, I remember back in the day, we always see EA logos everywhere on stuff, but we didn't pay much attention to we didn't, who knew? We didn't know it was going to be a thing, 30 plus years later. So.
Yeah, well, like I said, with the Ultima 7 and the Bard's Tale, there are in-game occurrences of the logos as well. So probably people will be chiming in saying, "Oh, this game has it inside, in-game as well."
Oh, it could be. Yeah. At least it's in games. Yeah, so that's 83. So that really is 40 years.
Oh, wait, what did you say? 40 years?
1983, right?
Yeah, that's when it started. Yeah.
Yeah. So that's a long time.
Oh, yeah, that's a long time for it to go undiscovered. Yeah.
Yeah, it's a long time. Well, cool. So to get Robin on here was great because
Yeah, that was a lot of fun to put together. Like I said, there's he's doing some family stuff right now, but he's going to be on as soon as he's able to and back in the forums.
so great. You can be on Discord and check out and talk with Robin. It was great to meet him at VCF Midwest. So that was a neat thing because I knew a little bit who he was through you mostly. I mean, I knew some of the stuff he'd done in the past, but mostly all the stories from you. And then nice, but
Never met a nicer guy. He's probably the nicest guy in person and probably online, but definitely in person as well. Just
super friendly guy. Yeah.
smart, very gentle, a lot of fun. So,
yep. Okay, so the next segment, we've got Mike Hill, BitFixer. He's going to talk about all of his products. So we got a few minutes. Did you want to say anything else while we got a few minutes?
Yep, I'm tapped.
Tapped, right?
We pack a lot into this weekend.
Yes, we did day 3. So okay, well, great. Then I'll just switch over and play Mike's video. Thanks, David. I appreciate it. Nice, great presentation.
Thanks.
All righty. So Mike Hill is known as BitFixer, and he's been in the community for a long time doing a lot of pet stuff. And the first time I had met Mike was at Convex, I think in 2012. And he had his pet displaying video that was pet ski that was converted from an actual camera. And so the whole entire thing was done in real time. And I was thinking, man, there's just no way this pet's doing this. And I was kind of right because the processing for the camera stuff was done elsewhere, and the pet was simply getting the data to display. But it's a really cool. And Mike's done a bunch of pet stuff, and he's doing some neat stuff. And in fact, this video he's going to talk about what he's working on currently right now. So let me go and find this particular video, and we will give it a go here. So Mike Hill.
Hello, CRX 2023. My name is Mike, aka BitFixer. I make gadgets for the Commodore and other old computers, and I'll be giving a little overview on a couple of those and some recent updates, and then we'll do a work in progress report on another project, which is trying to build a new retro computer from an ESP32S3 microcontroller. So hope you enjoy that. You can check out anything I'm doing, bitfixer.com or YouTube channel BitFixer. Hope you enjoy it. To start off with, I'll just give a quick overview of some of the boards I make. This one is called the Romulator, and it is a RAM and ROM replacement device for 6502 base machines. There's also a Z80 version as well. And you see I have these dip switches on there. You have up to, I believe it's 32... Yeah, it's 32 settings now, where you can have 64K, a full memory map, and then the memory map is configurable where you can set different sections to be RAM, ROM. You're basically setting what sections you want to replace, and then they can either be read-only for ROM, or they can be read and write for RAM, or you can pass through in the case of I/O addresses on your machine. And you can also halt a running CPU with this using either a Raspberry Pi, or there's a separate standalone programming device that you can use to halt the CPU, and you can read out the contents of memory on a running computer. Now we'll only read out the memory that has been replaced on here. It currently doesn't have a way to actually read directly from the memory that you have on your main board and whatever computer you have this installed in. And then this started out as something for debugging broken pets. There was a previous project years ago called the Pet Vet, which was sort of the ancestor of this. And in addition to that, I have the Pet Disk Max. Normally it has a pass-through connector here, so you can still connect your IEEE 488 devices, but this basically, it's not really doesn't directly emulate a specific storage device or specific disk drive, but it is a IEEE 488 storage device for a pet, and uses an SD card. It uses an ESP32 module, so it also has Wi-Fi capability, so you can use this for network drives as well. So you can use a regular web server to act as a drive. Basically, you map a directory on a web server, and you can load and save programs, and it also works with D64 images. After reading through the documentation for the ESP32S3, it turns out that this chip, and I think some of the later ones, maybe the S2 as well, have an RGB LCD driver, which is basically designed for LCD panels that have RGB data coming in either 8-bit or 16-bit parallel. It turns out they also use timing very similar to VGA. They also have VSync, they also have H-Sync, and this supports pixel clocks that are within range that VGA requires. So that's the method we're going to try. To start off with, I'll wire up a VGA connector with the necessary signals. We just need H-Sync, V-Sync, and the 3 color lines RG and B. To start off with, we're going to try for 3-bit VGA, which just means that the red, green, and blue lines will be connected directly to one of the output pins on the S3. And that just means that for each of those we'll have only on or off, which will give us 8 colors total. Eventually we can wire up 8-bit VGA, which just means that 8 total pins will be connected through a resistor ladder, giving analog signals for each of the RG and B signals. Fortunately, there is some sample code available for the RGB LCD driver, which I'm looking at here, and according to the docs, you just need to enter in the timing parameters for the different signals, which you can look up for your chosen resolution of VGA. So I went ahead and did that, and first attempt was not successful, and we had a crash. It turned out to be not finding the PSRAM chip, the external SPI RAM. So I had to go ahead and configure that properly. It was in the wrong mode, and after going back to check, saw that we had not changed the pixel clock to match the 640 by 480 VGA resolution. Once that's fixed, we actually do have an image, not exactly what we want, so obviously there's a problem. So let's talk a little bit about how the RGB LCD driver actually works. You have the option of allocating frame buffers either in internal memory on the S3 chip itself, or it can be in PSRAM, which is memory that's in a separate chip that's connected to the CPU via the SPI interface. So you have a trade-off there. The internal RAM is fast, but is very limited in size. So the internal memory, you're actually space constrained enough that you can only allocate 1 buffer, and that's only at lower resolutions. In SPI RAM, you're not very constrained because you can have 8 megabytes, but you have a speed constraint. But then we saw this option called bounce buffer. If you turn bounce buffers on, then we get closer to a clean image. It's still not quite there, but something obviously changed. So this sample code was using a library called LVGL to draw a diagram to the screen. So I removed that for simplicity and instead just directly drew a blue image into memory, and with that it actually looks like we have a stable VGA image on the screen. And after that I changed it so that every line is a different color, so we can see how that looks. All right, well, we got this. This doesn't look like it's not quite working as expected. I'm going to double check to see if that's something I did or if there is a problem with how fast the PSRAM is able to write out the data into the bounce buffer. So something I noticed was that we were still in 16-bit color mode, which meant that it used 2 bytes per pixel instead of 1 byte if you're in 8-bit color mode. So I switched it to 8-bit, and we actually get a working image on the screen with alternating color stripes, which means that using the bounce buffers method, we're actually able to draw out the pixels fast enough to meet the pixel clock for our selected VGA resolution. I just want to show you here some detail about the pixel clock. So the actual pixel clock frequency for the VGA 640 by 480 at 60 hertz is 25.175 megahertz. And if you look over here at the screen, hopefully you'll be able to see it, but that line is not very straight. You see, it's kind of noisy and it's wiggling around left and right. And I suspect what's happening there is that the CPU is not able to generate the exact frequency that we want. And I know that that frequency is derived from either a 160 megahertz or a 240 megahertz oscillator on board. So I'm just going to try adjusting the frequency to something like 25 megahertz, which is close to the nominal pixel frequency, but should be a lot cleaner because the oscillators should be able to get a lot closer to the real frequency. So let's try that out. Well, I changed that frequency to 25 megahertz, and hopefully you can see it. The line is much cleaner there. So we'll give it a try on some different resolutions and see how well it keeps up. So I'm going to move forward a little bit. We saw that using the bounce buffers method, we were able to get a stable VGA picture because the internal memory where the bounce buffers are located is fast enough to be able to DMA out the pixel information to the VGA screen. So I have taken everything from the initialization code. I made it my own VGA class here, and we have options for different resolutions. You can go up to 800 by 600, and the constraint really is the pixel clock. The pixel clock for 800 by 600 is 40 megahertz, and above that, really the oscillator is not able to generate pixel clocks faster than that stably, so the driver just fails when you try to do that. So 800 by 600, 640 by 480, 640 by 400, and 640 by 350. And we have all the initialization stuff in here, the timing information. We actually don't allocate a frame buffer at all in the driver. We do it ourselves, and then we get a callback when the buffer needs to be filled here. It's a bounce event callback. And what I do in here is I read from the SPI memory or the main memory if you have enough of it, and you, on the fly, you copy pixels into the bounce buffer as you're going along, and that lets you have control over how you're going to draw pixels and update the screen. Then you can actually scale down the pixels. So if you have a native resolution of 640 by 480, you could draw at 320 by 240, for example, with each pixel mapping to 4 screen pixels. So let's take a look at some demos I put together here, showing VGA drawing on the device, and we'll go from there. And I just hooked up the the green and blue lines as well and separated out the colors. So those individual colors are working right now. This is just a 3-bit VGA with just on or off for red, green, and blue lines. But if we want the full range, we're going to have to make a resistor ladder so we can get some analog values out. So now we're going to set up a full 8-bit VGA by getting all 8 outputs from the device, and then we're going to run it through a resistor ladder so we can generate red, green, and blue analog values for each of those pins. So after adding a whole mess of resistors here, we have the 8-bit VGA going on, and we can even display a bitmap here. This is a dithered 256 color image, this computer right here, and looks pretty good. It looks like the bright colors are a little blown out, so there's possibly some adjustment that I should do in the resistor values. But yeah, pretty cool. We have 8-bit 256 color VGA coming out of the ESP32S3 now. To make things easier to experiment going forward, I had some breakout boards made up for 8-bit VGA, so you can have 8-bit digital input or 3-bit RGB, H-sync, V-sync, and ground, and then there's a bunch of resistors on the bottom to make the resistor ladder. And I'll go ahead and build one of these and just make sure it works. Got it hooked up and running a 3-bit VGA demo, and it is in fact working. So that should be convenient to have this breakout to build on this further. So quick update, I was trying to add an SD card to the S3 and expected this to be a very quick thing. Just connect the SPI lines to the breakout board, but it turns out to be a little more difficult. I'm getting timeout errors. Then saw some indications that you needed 10K pull-ups on the SD lines, tried that, but still getting the same timeouts. So I'm gonna look into this further, maybe look at it with the scope, see if the signals are looking correct on the SPI lines, but not quite sure yet. So at long last, I finally got this working. I really don't want to talk about how long I spent on this, but I think in the end it was probably just a bad connection in the breadboards that I kept hitting over and over without realizing. But, you know, I tried the ESP32 board, I went back to this, I tried changing the pins and that wasn't working. I put pull-ups and took them out. But finally, once we got it to work on the ESP32 board, then I just like moved it over to the other one, and yeah, it started working. So good news. Kind of frustrating, but now we have storage attached. But now we can see a little demo of some video playing on the S3. This is a little video of a toy train going around the track. And right now this is dithered down to 3-bit VGA, so you only have red, green, blue. And this is the same video in 8-bit mode, so we have 8 total bits for red, green, and blue. I believe the blue channel has, yeah, the blue channel has 2 bits and the others have 3. And the frame rate is about half what it was on the 3-bit. This is running about 8 frames per second. The other one is running at 15. And again, that's the bottleneck is the reading uncompressed frames from the SD card right now. And that can be improved if we connect the SD card in, I believe it's called MMC mode instead of SPI, but we'll look into that in the future. And in the meantime, if we want to get a much better frame rate, we have the option for 1-bit video. And this VGA library is up at BitFixer/ESP32S3VGA on GitHub, so check that out if you like. So looking at some sample code, we're again lucky enough to have some relevant example code here. This is a USB HID class example, which should let us connect a USB mouse or keyboard to the ESP32S3 and be able to read the keystrokes. And we want to connect it like so, GPIO 19 to D-, GPIO 20 to D+. So let's give it a shot, wire this up, and see if it works. All right, well, after a while I managed to get this working. The problem was that this, the USB-C port there, it wasn't directly, it's not directly connected to the D- and D+ lines on the ESP32S3 chip. It's actually connected through another part here. So this pin 6 and pin 4, these are the only other places on the board that the signals come on. So I had to actually solder 2 tiny little wires right there to get those signals out. So that's an unfortunate thing about the Pro S3 board, is that those 2 pins are not brought out conveniently. But now we're connected to the keyboard and can type on it, and it's working. So that was not too difficult, and it was just a problem with the development board. So yeah, so we have a USB keyboard connected here. I'm going to get that code cleaned up and brought into my project, and then we'll see where we go from there. Probably add something else to this now. All right, I'm going to show a little bit about how we got the keyboard working here. So I created an IDF component over here, USB keyboard. It's basically just a directory with a CMake file, and pulled in the IDF sample code for the keyboard. It more or less just works as is, but mostly what I did was I added a few key codes here. So there's a key code table where you get the raw key codes from the keyboard and it translates it into ASCII characters. And it was missing a few important ones, like I'm looking at here. We have the alphabet, we have the numbers, and I think some of these were missing. Some of the, I think there was a function key missing as well. Yeah, actually, here were some. There's the arrow keys. Needed to make sure the arrow key is working. Backspace, delete. So for the most part, the IDF sample code just works. So let's build this. And the way you do that is pretty simple. There's IDF pi, and then you port. So this is going to flash the firmware onto the ESP32S3 board. Got some warnings here that I will need to fix. But in this demo program here, all I have going on is basically a TV typewriter type thing. So let's see how that works. So let's verify that this is still working. Okay, there. Let's maybe move in a little closer here so you can see that. So we do have keyboard input, and A, B, B, B. So yeah, so we're reading the keyboard codes here, and I'm actually drawing it on the screen. And that is using the VGA driver that we saw before. So now let's take a look at how we're actually going to get this to emulate a CPU and do something a little more advanced. Okay, well, next step, I want to get an emulated CPU running on this and actually do something with the computer other than just typing out letters. And it just so happens that many years ago I put together this emulator for a computer called the Digital Group, which is a late 70s Z80 based computer, a little bit lesser known, but pretty interesting computer. It was actually the first computer in our house. My dad had one to use with ham radio stuff, and I just became kind of fascinated with it, so I put together this emulator, and it's fairly simple architecture. It's more or less a Z80. There's a TV card where you draw characters directly from RAM on the TV card, and you write to the screen through an out assembly command on the Z80. So what I'm going to try to do is take this build. It's currently designed for building using libcurses, which is a Linux kind of terminal drawing library, but I'm going to take all that stuff out and adapt it to run on this. And basically it's just it'll use the same simulated Z80. And right now I'm using what is the library called Z80EX, which seems like it works pretty much fine. It's a Z80 emulator library, and I pulled that in, and let's take a look at how that was adapted on the ESP32. So over here, let's see, DG-EMU, and I just exposed a few of the crucial functions here. You basically have a step function, and that you just call that when you want the CPU to run, single step the CPU, and you initialize the emulator, and then more or less I'm drawing from the RAM in this TV card class here. So the TV card is to simulate the display, and you can do cursor back, cursor forward, or you can draw characters on here, and that's actually what we're going to see when we run it. And in the emulator file itself here, it's pretty messy at the moment, but normally this computer loads from tape, and what I did was I have a modified version of the ROM. So this is the original Z80 ROM for this computer, and I've modified it so that there's a read byte subroutine in here, which normally will, let's see, this part here is where it was before, but I've taken that out, replaced most of it with no ops, and the only thing in here is an in. There's an in from port 1, and then that's handled here in the CPU. So when you're handling an in operation, you're just reading directly from a binary file that has the program you want to load. And I'm just remembering how to do this. I set this up a while ago, but let's go back to the main function here. So I've set this up so that we're going to switch from typewriter mode into the DG-EMU mode, and current mode will be, so let's give that a try. Kind of running by the seat of my pants here, but then just out of this IDF Pi is the build system for ESP IDF. And then you specify your port. You put different commands on here. So build builds the firmware, flash writes it to the flash on the device, and then monitor runs the serial monitor. So you can see your debug output, which is very useful. Here we go. Let's go ahead and flash it. Hopefully this works. Oh, we had an error. So let me take a look at what's wrong there. Okay, and that's kind of useful to show here. What I think is happening is that this is probably, sometimes it gets stuck not in programming mode, so you have to hit the boot, this boot, and then reset in order to get that working. Because you hold the GPIO 0 low, and then you reset, and then it puts it into programming mode. But actually, it looks like something else is wrong. Do a little debugging here. Let's try again. There we go. The good old unplug and replug technique works every time. Okay, so there you go. I think I have something set up incorrectly with my resolution, because, or maybe not. Oh, there you go. Yeah, it actually worked. Okay, so those numbers you saw in the beginning were that's what you see when you load up a program on the digital group. It's scanning out the index of the bit that you're currently reading from tape. And now we're in Mini Basic. I don't really know any of the commands in Mini Basic. Okay, well, I'm going to cut in here. I'll load up something more. I'll load up a game or something so you can see the emulator at work a little more clearly. Okay, so let's try that again. Just wanted to note that the software that's running on the digital group emulator is on the SD card here, which let me show you that a little better. Here's the SD card. So this is wired up to the ESP32S3, and it's running a there's a FATFS library built into IDF, so you can fairly easily mount a FAT32 file system on an SD card. And I'm going to try loading Lunar Lander. Normally I'd have a little bit of a menu on here or something, but right now I just have to hard code it. And let's find the window that I need to get. Ugh. Here's the window, and let's try it again. So this is kind of interesting. You see a lot of the software on here, it boots up to sort of the Z80 operating system on here, and you have a few options, and what we want here is option number 7, Lunar Lander. So we hit 7. You go, congratulations on being chosen as pilot for the first experimental lunar landing mission. Okay, so I think it's space or something, or you just have to wait here. Let's see if that. Oh, here we go. It's very slow. Okay. Yeah. So yeah, it's redrawing every time. Interesting that it's running so slow. I'm not quite sure why that is. I'll have to look at that. But yeah, it is in fact running Lunar Lander now. And yeah, on the digital group, the screen updates were not very efficient. Basically, you have to rewrite every single character on here in order to clear the screen. It's not really a direct memory map. Like, you can't just do CPU reads and writes directly from memory. You have to do a Z80 out. You do an out to port 1, as far as I remember, and you have to do you have to do one out operation for every single character on the screen. So it's pretty slow. But yeah, so now we're running Lunar Lander, and you can see we're about to crashing into the moon here. It's a tragedy. But anyway, so they're running a emulated Z80 on here with screen updates. So, oh, I crashed. So now maybe we can try something a little more Commodore related. I want to see how complicated it is to try to run a PET emulator on here with the 6502. That may be a little too ambitious for the purpose of this video, but let's see how it works. So I took another look at the digital group emulator here, and I think I might know why it's running slowly. And in the DG step method here, we see this get time microseconds, and that just calls one of the native ESP methods here, ESP timer get time. Now my suspicion is that this was an attempt to perform accurate timing to get close to the real clock speed of the computer, which I believe is 2 megahertz. But my suspicion is that just the timing function itself is slowing everything down. Just the act of measuring the time is wasting time. So let's try taking that out and just see how fast it runs. And I think it's going to go a little bit faster. So let's go ahead and build. And I'll plug in now. So it looks like the screen updates were a lot faster. We'll go to Noodlander. And I don't really know if there's a key press that needs to happen there. If it's just, I think it's just timed. Okay. So yeah, that looks a lot closer to, that's pretty close to what it looks like on the real computer. So I'm pretty sure that just the act of timing was what was holding this thing back. And yeah, you can see this is not really not real graphics performant machine, but it seems to work.
All right.
I'm in awe again. It's always so fun to see Michael work on stuff. He's an interesting combination of a very creative mind and someone with deep technical knowledge. And you know, it's just, you know, and then he's got that background where he's got like a museum worth of stuff there as well. And every time I got to make sure, no, focus on the video. And my eyes keep on wondering, like, what new has he got there as well? It's he's a regular on VCF West with the display of the Petsky, the Petsky video. Always a lot of fun. Obviously, for anybody that owns a pet, they'll probably, if you do some pet care, you probably have his products. It's really, it's becoming
For sure.
pretty hard not to work on them without his products. So always fun to see. I like this. He's taking a very modern, super available component, cheaper than chips, and demonstrating what you could run on that is it's just amazing. The new technology that we've got available to us and what it can do as far as running old technology and combining that with things that we couldn't do and the ease of access and all of that. It's pretty cool. Very cool presentation again. So, Jim, are we going to pick up where we left yesterday?
Yeah, it's funny is that for some reason Zoom says that I'm sharing my computer sound, and I'm trying to tell it not to. Okay. So I'm not sure what the deal is with that. So, as long as you can hear me, it's fine, I guess, huh?
I can hear you loud and clear.
Okay, so yeah, so yesterday we built a extender for the cartridge port on the Commodore 64, and we built basically a right-angled extender. And so let me actually share my screen here real quick, and if Zoom will cooperate today. Yep. Okay, so that's what you see then, right?
Yep.
Okay. So this is the main thing for KiCad, and if I slide this over here, we should be seeing this now. That's the schematic of it. So this is the schematic that we made yesterday, and at this point yesterday, we were actually wiring up the board, and so I did finish that yesterday, and this is what we've got. And so if I go and show you the 3D version of it, this is basically what we ended up with.
Yeah.
Very simple.
And as you said, you would replace the micro switch with one with a little bit of a bigger stem, because we would use that later, huh? For
Right.
the keycap to fit on.
Correct. Yeah, exactly. So we don't know what the distance really is. We know that this white line, it should be the back of the 64. So there should be a little bit of space, and then the space for the cartridge.
Right.
So this is one of those things in our design, what we need to figure out what we want to do as far as a case that we're going to make, and some ramifications about having a device like this. So if you're ever familiar with any of the cartridge expanders, either they're super duper long, so you had a big area to physically grab a hold of with your hand to hang on to, because let's face it, getting a cartridge in and out, it takes some effort.
Yes.
And so the last thing you want to do on a board that sticks out, that is flush with the back of the computer, so it sticks out horizontally with the computer. If you push down on a cartridge and you don't have something under it, or on this connector, it would actually force it downward, and you could actually break your 64 cartridge board by doing that. Likewise, if you're pulling the cartridge out, the board would tip upwards, and now you're going to put pressure on the top of the case of the cartridge board, and you might break the cartridge board as well. So we want to prevent the up and down motion. So we got to think, how are we going to do that? Well, downward is pretty simple, because we could put something under this to allow you to push down on your desk. But what are we going to do for the upward motion? Any ideas, Yuri?
Yeah, I don't know. I normally would have. I'm trying to think. Yeah, downward. I only actually had thought of downward. For upward, I would have just rested my hand on it and then kind of push one down with my hand and pull with my other hand for the cartridge.
Right. So that would work normally, but the reality is, remember that this white line, the lower white line below the switch, that's the back edge of the 64. So this doesn't stick out very far. So
that's true.
You're not going to be able to grab it.
Maybe a casing that allows it to have less play if you just have the board.
So we could do that, but what other option we could do is we could flare the case out on the left and right side and put little pads here where you could put your fingers down, like your thumb and your finger, and hold it and then pull the cartridge.
Oh yeah, that makes sense. So extend the PCB to the left and the right.
Well, we could do the PCB, but we could also do it in the case. We don't have to change the PCB.
Yeah. That makes sense. Yeah, that makes sense.
The reason why it might be better to do in the case part is it's a lot easier to 3D print different types of case designs than it is to get different circuit boards made.
Yeah, makes perfect sense.
You and I can do that.
You could reuse the same PCB design and just tweak the casing instead.
Yeah, so you and I, could print in multiple cases every single day, testing things. Where getting these boards made is going to be a week.
Yeah, it's going to take you a week for them or 2 weeks, whatever time to get them back, and plus you get multiples, and it becomes a very costly exercise very quickly.
So you can see it's a pretty simple board, and for the trace layouts here, I didn't do any ground plane in between. This isn't really required. Normally you could put some vias in here and try to tie ground layers together. And in fact, I actually cheated slightly. Let me pull this off of here. So now you can see the board by itself. For the switch ground itself, I just made a trace that goes up into this the power plane here, which this is the ground plane part.
Yeah.
So that's a pretty simple way of doing it. We don't have any vias in this board. So, and a via is a pass-through. So it lets you connect the top side to the bottom side. And so we're kind of relying on the fact that this is the reset pin here. We follow this trace up to here. You can see it goes into here. But if this needed to go on the bottom side of the board for some reason, we would have to put a via, which is a hole, very small hole.
Yeah, and then an electrical connection between the two planes.
Yeah. So
Yeah.
fortunately for this one, this is like a super duper easy for production because we don't have any, vias at all. We have pretty much, in fact, if we wanted to really make it even easier for production cost and stuff, these hole sizes could be the same if you could make them the same.
Yeah.
And that way you'd only have one drill bit used in this. And so when you're doing mass volume, it cost-wise isn't such a big deal when you're doing like 100,000 pieces, but time is, because you got to do a tool change and things like this. So sometimes it's better just to try to make the hole sizes the same if you can. If not, then it is what it is. But you think about those kind of things during your design work of what's going to minimize the amount of time and expense when I'm developing a product.
Yeah, makes sense.
So I'll put this back here. And so you can see how our traces end up being on here. I will move this out of my way so I can see. So this is the top side of the board. And this is the bottom side of the board for traces.
Yeah.
And I made the ground plane all the way around over top of here. And I have a little extension. So let me go back to this. I'll re-enabled here. So on the back side of the board here, where the connector goes in, I actually made a little lip right here on purpose that sticks out. And I like trying to do that. This is another thing we can use for a locking mechanism to hold this down, hold it in place. And this is a dual purpose thing. So not only does this give me a surface area to actually put plastic on, like to do a lip, but it also gives me a little longer circuit board, which gives me a better power plane as well for ground in this case.
Yeah. Yeah.
So it's a dual purpose thing. That's just a lot of experience doing things like this. So what we're going to do, I'm going to show you something nifty about KiCad. So if we go into the pull down menus, well, first of all, we had that DRC check that we did yesterday. And once I added all the traces to everything, we got 0 errors and 0 warnings.
We're all clean now.
So we're good. So we know we're 100% guaranteed that whoever made this, the schematic part, this is going to represent that.
Yeah.
So
So
it's
as
not gonna
long
have
as your
any errors.
schematic is correct, the PCB representation of that is showing that it got correctly
Correct.
traced.
And so when you run the DRC check, it's gonna basically tell you that everything is connected together. There's no unconnected traces. The parity is great, and I've got some ignored tests for like boundary checking for things that it's fine. So this basically is a board that should work right off the get, providing that this guy who designed this did it right. So that's typically where you're going to find your problem is some kind of design issue itself, and then you put that design into your schematic, which gets put into your board, and that's where it goes.
Right.
Not very common. Now, if you're going to do this as a developer board, say you're doing product development for something like it's a little more advanced or something, and you needed to know like the signal levels of all these pens, then you can put out little test points everywhere. And at that point, now when you're doing your development work, instead of having to solder leads or something like onto the backside of this thing, all these pins, it'd be a lot easier if you had little holes in the board you could just poke your probe into.
Right.
You could be testing. So you got to think about
So,
it.
so to that point, so if you want to put like a test point in here, let's say on a ground line and the +5 volt line, is that something where you would need to reroute then, or can you just add one on top of it here? Or
well, you can do it a couple different ways. With KiCad, I could just go to put a test point in here. In fact, you can do a place apart, and then I think it's actually what's called test point, isn't it? Yeah, test point, and you can pick a test point.
Okay.
What you want it to look like, and then I can say this is a test point, and if I want to copy this and make a second test point.
Yeah, and then at
I'll take
+5
volt. Yep, and I'll connect the 5 volt to here, and this is going to be the ground one. We can do that, and then we'll tie the traces from the connection points together like that, and then we'll go into here, and we will update the board. Now, we got error messages here because I don't have a footprint assigned to the test point.
Right.
So we have to go back to the schematic, and then we have to decide what do we want the test point to look like. We have to give it a footprint. And so we want to do, let's see, connector. Actually, I have test points, I think, in here. I have my own library of test point things that I normally use.
They're on the bottom, test point.
There it
Left
is.
bottom. Yeah,
Yep,
there you
there
go.
you go.
Yeah.
So now do you want to do two pin, one pin, you know, how you want to
Yeah.
do, you want to do a pad? Pads are pretty common. Usually a hold pad is good. Or you can do a loop as well. This basically this is like a piece of wire that's soldered in, and it's got like a little hoop to it, which makes it easy to put a clip lead onto.
Yeah. We can book like a crocodile connector or
or a test lead of any kind.
Yeah.
So we could say, okay, we'll just do this one. I'm curious to see what it looks like when we're done. And so I always like cheat, so I'm just going to copy that, and I'm going to go to this one, and I'm going to paste that one in. So it makes it super easy. Now we can go back to here, and we can do an update. And so it says there's no errors on the board, and then now it gives us 2 test points. And then so now we can take a look at our little rat's nest to know where it needs to be connected to. So this is a 5-volt one.
Yeah.
This is a ground one. Now the ground one's going to be easy to do because it's a ground
you
plane.
can just put it right in the middle of the ground plane.
Yeah, so we know this is kind of a big anyway, so we probably need to fix this. We're going to keep this. I might keep our design. Now for here, this was going to be a little bit tough because of the fact that we know that these two are, in fact, let me switch to the other side of the board. There we go. It's a little easier to see. So here's your dilemma, is if you do this, that looks like it's going to work just fine, right?
Yeah, but it's the wrong side.
But we know that on the
isn't it?
bottom side of the board, now we've just gone across 2 traces.
Yeah.
And so to resolve this issue, we can simply just move this around. KiCad's pretty smart about that, about how to move things.
Yeah.
We can move things, move this. Actually, if I can move it over, grab it and move it. So just enough clearance for it.
Just move it out a little bit.
Yeah, it's like I said, this is a really big test point, and then we have to make sure that these are going to get fixed. We got to move these up so they don't encroach on our spacing requirements. So that would work, and then we could run a DRC to see what it says about it. It's probably going to complain. That's fine.
Yeah, it says it's
so apparently
fine.
we're well within the area. So now we can go take a look at our rendered version of it.
Oh,
yeah.
Nice loops on them. Yeah.
So yeah, that's simple to do. So we can do that in the schematic this way, but I'll show you another way that's even faster. And I will, I'm going to just going to use the handy undo function because it's a gazillion levels.
Yeah.
And I'm just going to delete these like this. And what you can do as well is you can say in the main circuit board editor part, you can say place, and then we can add a footprint.
Yeah.
And then you can do test point, and we can do like a hoop like we just did. Unless we can find where the hoop is, or let's do that one. And so
in this case, you may even decide to put just a pad instead of a full.
Right. So we can do whatever. Yeah, you shape it differently, all kinds of stuff you want to do. So we could actually we'll copy this one because copy and paste.
Yeah.
And we run into the same issues, so we're gonna have to, move this. And come on now. So this is a good example of one thing that I do like about KiCad as well. A lot of times you got a border or something really close. Like this is a no pore lane. So basically what I've done is that I've clipped this edge of this tire pore so it doesn't encroach in here. And it's over top of the trace. So sometimes you're trying to grab this and you can't grab the trace. But if you press and just hold the mouse button for 2 seconds, it pops up and lets you select which one of these you want to select.
Yeah, makes sense.
Which is nice, and you can hit drag, and now we just, okay. So now we've done basically the same thing without having to put it in the schematic.
Yeah.
When we run the DRC, this is where we're going to see an issue though. There's all kinds of problems here, right?
Yeah.
And there's clearance by all kinds of things that are wrong. Clearance violations we can fix by making sure that we assign this to a layer. Like there's no net name for this, so this one's supposed to be ground. So we can assign this to ground, wherever ground went to. How come we don't have ground at this bottom? Well, that's not clock. So we assign it to ground, and that's going to fix the problem with this particular issue here. And then this one is it also doesn't like the fact that it's not connected to 5 volts.
Yeah.
Because that's the 5-volt one. So now we've done this. So now when we run DRC, we're going to have a lot less errors. Actually, we have 0, and we have 3 warnings. And so the warning is that there's no footprint description because we don't have it in the schematic. So to resolve that, I can't stand seeing warnings even on my stuff. You can go to the select it and hit E for edit, which is what everything does. Actually, not select the copper part, select the actual part. Let's see, how can I grab that? Come on. There we go. The footprint, E, and then you can do not in schematic.
Okay, and then it won't warn about that anymore.
Yep, it no longer, it considers it part of the schematic, and so I can do the same thing for over here. I'll pull this up for the footprint, and E, and not in schematic. And now I theoretically shouldn't be getting any of the warnings, except there's going to be one, which is what? Footprint, reference designator. I wonder what that one is.
1 and 1. I think you named them both 1 and 1.
Oh yeah, you're right. You're exactly right. The designator. Thank you. Yeah, so that's how well this thing works. So we can click on the ring, and then we'll call this pen 2. Yeah, and that should be.
That should hopefully resolve it.
You don't have to call it a pen either. You can actually. I've done it a lot. That where you just have it empty, so it doesn't have any kind of reference at all to it. And no, so it's the same thing.
Oh, didn't like that.
Okay. Let me go and make sure it's turned off then. Oh, come on. So I'll delete the reference. Maybe that'll fix the issue. So sometimes it's much faster to do it through the schematic because it handles all these little things like this automatically. Yeah. And then other times it's quicker if you just want to add a whole bunch of things for testing. And you don't even have to like fix some of these things if you don't want to, as long as you know that if you've got a good board to start with. And I didn't fix it either. Weird. So, oh well, we're going to delete this anyway.
No, it was more to indeed to demonstrate kind of how to add some of these things and how to think about that if that's something that you're going to be using or think you're going to be using, to maybe try and put that in right from the start.
Yep.
Okay.
So now we're back to this. So once you've got your board designed and everything's peachy, a lot of people want to have like logos and things like that. So one of the things that the new KiCad 7 has is the ability to add text with fonts that you can actually change the font. So that didn't used to be that way. It used to be strictly KiCad font. So now if you want to add a text of some kind, like a text, like who makes it, copyright, or whatever you want to do.
Right.
You can go to your silkscreen layer and type in, this is a test. And now literally you can put this anywhere you want on your board. And then you go back to your rendered version.
It puts it up. That's fantastic. Yeah.
Yeah. So, and you can do the same thing with logos and graphics. You can actually import a logo or a graphics, and you can place it anywhere on the board you want to. You can place it on the top layer of the silk screen, the bottom layer. You can actually even superimpose it into the copper layer. And so there's like a burn layer around it, so that, or it's embedded. So that's how you want to do it, but it's a lot of options now. With KiCad 7 just added, the ability to change the font was like a game changer, because all of our fonts for, and this for years now have been the same. Yeah. So if you want to change it to, this is.
Yeah.
So like this, and like, well, I don't like that size text. And so now you can actually make the text however big you want. So now we've done it. We can go take a look at our rendering piece. And so this is what it looks like now. And so it's really super handy to be able to do this in real time. For when you're doing development work, it makes it super quick. But the handiest thing in this whole thing to me is that, this uses FreeCAD to do the rendering. That's a open source program that's free, and it uses the rendering engine inside of KiCad for this. And because it has a rendering engine, it has the ability to export the same kind of data as well. So you can actually export this whole rendered PCB as a step file, and the step file is the industry standard for a 3D model. And so you can make a complete 3D model of this. And so we're going to set this as a board origin so that the X and Y axis are dead center of the board. That way it's not off in a corner somewhere. And then these are settings that we use normally. And we say export, and it's going to export the 3D model to our directory that our KiCad project is in. So it actually went to here. And so now what we can do is we can load up SolidWorks, which I probably should have done a while ago because it takes a little bit of time to load. It's loading. Okay, let's go and do this while we're waiting here. Okay, so we talked about our switch yesterday. So I did make this I think it's 9.3 millimeters. It's a very common size switch stem. And the goal here really, I tested yesterday. I looked at in fact, that's a good thing that we didn't talk about yesterday either, but we need to do that while SolidWorks plays in the background while it loads. So we need to know space-wise between
oh, that's true. The placement of the switch and how far back the connector would need to go in order for a keycap to fit in.
Yeah, we wanted to make sure there was enough space here. And so one of the things that you can do with KiCad is you can use the measurement tool. So on the side over here is a measurement tool.
Yeah, the little ruler sign, yeah.
Yeah, and so we can look at, we know this is going to be the edge of the switch.
So that's another good point, eh? That light blue type of color or whatever color that is called, that is basically the end of the physical dimension of the switch, right?
Right. This is basically the size of it where it's going to be sitting inside. So if I switch over to this, you can see that. Let me hit.
Yeah, you can see that the pad overlaps the physical size.
Right. You can see exactly how much space is between the white lines here of where the switch is going to sit in here.
Yeah.
So we have an idea the switch is definitely going to fit inside of that area. Let's get back here. Okay. So what we measure, what we want to know really is center of the switch. And you can see it automatically snaps to the center.
Yeah.
Which is super handy. So we know if we just click on this and then we just move this around, this is our ruler we can use anywhere.
Oh, that's really neat. Yeah.
So we can measure degrees of angles.
Yeah.
Which is super handy if you're going to do like, okay, we need a 130-degree angle of something. We're drawing a line. We want to see how close we are to it. We can just simply check it like this.
Yeah.
I use it primarily for doing this, to measuring how far it is from the center of the switch
point
to this blue line.
Yeah.
And so if you take a look at the, let's see if I need to move this up a little bit so we can, there we go. We can see everything. So notice that in the angle, we've got the very bottom thing, it shows 90.1 right now, and then I can move it over to, so it goes into 90. So you can actually zoom in and get very, very close. So it shows me now that it's 384 or 384.4 millimeters.
Yeah.
That's how far it is that way. And then I can look this way to see how close it is to the back of the 64 itself. And it's like 384.6 there. So it's very close to being dead center.
Yeah.
And as I demonstrated yesterday, one of the things you can do to make sure it's centered wise is you can take this and you can take this line and take this line and use the option in here for doing distribute vertically. And it's going to put your switch dead center between those two lines.
Yeah.
So it makes it super handy for that. Okay, so let me grab this and see if I smooth over so you can see this being shared. And
you want to go back to the original file as well? Or you already did? You exported based on the original file.
Yeah, I just exported the 3D model, which is what we wanted. And
the step
for some
file.
reason, you do not see the SolidWorks screen, do you?
I don't, no.
Interesting. So let me turn on a new share. Oh, that's why. There we go. It's a new share. Okay, so let me share this. Ah, there we go.
Yeah, we got
So
it.
this is SolidWorks Maker. If you've never used SolidWorks before, it's probably because, if you've known about it, it's probably because it's really expensive. So, regular seats for this are super expensive and only real developers use it typically because of the cost. And when Fusion 360, last year, or a little over a year ago now, they decided to release a inexpensive hobby version of Fusion 360. And I was very surprised that this company that makes SolidWorks Dassault Systems, they did the same thing with SolidWorks. And so you can get a license for SolidWorks for $99 for a year. And the only stipulation that they say is that they don't want whoever's using this program to make more than $2,000 in income from using this program.
Okay.
So other than that, it's almost identical to my full seats. It's missing some things like plug-in modules and stuff that we've got on our full-size ones, but it's got everything else. In fact, it's got browser-based versions that you could actually run, like you'd be in a library in Berlin and you can pull up your project and run it on, the library's computer right there and work on things. This particular installation is the actual desktop application. So when you get your license, you get everything that they give you. And in fact, let me see if I can pull this up over here. I'm going to try to pull up my account real quick because I think it's really worth talking about the value in this. And let me change my screen to be this one. And there we go. Okay, so this is what you get when you, like this says Jim SolidWorks Launcher. So I have these set up because this is the two programs I use the most here is the SolidWorks Connected, which is what we're using now, and then the SolidWorks Visualizer, which is the rendering station for SolidWorks. So when you've created a model, you can go and render it in like 4K, high res, and huge resolution. But these are all the apps you get with this. It's nutty that the stuff they give you. X Shape is in here, which is or X Design. So it's like a NURBS modeling thing. Actually, there's X Shape as well. That's the one that does NURBS modeling, and then X Shape. So this is the online version of SolidWorks. Basically, you click this, and you can actually pull files from your cloud and work on things if you want to. You can't do that with the desktop version from a browser because it's an actually installed application. So, but yeah, it's basically you get all of this stuff in this thing for $99 a year.
Very cool.
It's like the holy grail really for hobbyists because it's SolidWorks. I mean, it's an insane program for what it does. And so let me show you now that I am going to go and open the file that we created out of, let's see,
out of the step
yeah, the step file. So the step file got generated here, and so when you open this, it's going to open the step file, which SolidWorks can open pretty much every kind of format there is. And so this is what you get.
Yeah.
And so what you're missing, obviously, right now is we're missing all the traces, we're missing the fingers, we're missing the colorization.
Yeah, all irrelevant for a case design, obviously.
Well, it's interesting to me. So I actually, last night when I was playing with this, I made a full color version of this in SolidWorks so we could actually see. And it was actually more difficult, and I typically forget about this. So when you've got like a gray connector, but all these colors are very good for contrast. So when you're developing things like this, almost all of my boards nowadays are black. The connector's black. And so when you're actually trying to work with something in black, it's actually hard to see.
I bet.
And so you can do things like turn on the, real view graphics, which gives you better lighting and shading and things like this, but it's still dark at that point. And so let me see if I can load up here. I made this project already. Oh, no, it's in SolidWorks. There we go. SolidWorks part. I think that's the one there. Oh, I guess we got to close this first before I destroy something. And then so the option in SolidWorks is you can save to your PC or you can save to their cloud service. And I'm not sure how big the cloud service is, but it's pretty big for you. Oh, that's a switch.
Yeah.
So that's a switch that I colorized because it was gray before. And it's interesting. I'm not sure as to why SolidWorks doesn't like the output from the KiCad libraries. Sometimes I find that all the parts import the right color and they're perfect. Other times they're gray, and I'm not sure what the mystery is there for that, but that's what happens a lot actually. And so it's not a big deal to me because what I end up doing typically is importing just the PCB, and then I will put the parts on top of it. So here's a green PCB with a black connector. So if you made this PCB black, then it would be really hard to see against this for doing your lighting and stuff. Yeah. So basically, here is our board, and it's a part. And so now we know exactly what we have to do for a wraparound. So the only thing we need to figure out really is how big of a case we want. We have to know the size of a Commodore 64 cartridge port. Yeah. So we have to measure those kind of things. And so I think my window's still open up there. You know, a standard cartridge port is going to be this thick, and that we're used to. And so we measure this out. And we're going to keep, do we want to make this as a left and right half that bolt together, or do we want to make it a top and a bottom?
I would prefer personally, I would prefer a top and a bottom.
Yeah, well, I would as well. But these are things that, you know, you may find in your design, like, oh, you know, we have to insert something inside of this board. We can only get to it by having a case that's left and right side.
Oh, got it.
So it all depends on what you're making.
Depending on what the mechanical attributes are going to be of the.
Exactly right.
Yeah.
And so in SolidWorks, we do what's called parts and assembly. And so this is actually a part, which is made as one piece. And an assembly is what you join all your parts together with. So that's what we're going to go ahead and create first here. Is we're going to make a new assembly. I don't think, does this show? Yep, it does. So a new assembly, and we're going to say okay, and it gives us a blank slate. And so SolidWorks is a very simple concept as far as how it all functions. You have a front plane, a top plane, and a right plane. So this is all the planes that's possible to be drawing on something. And so this is really very, very simple concept once you understand that you're going to be drawing on one of these planes. You can do a sketch, and then you can extrude it, which means bring it out, and then you can draw another thing on your sketch on your surface, and then, you know, maybe extrude part of it so it's gone, or recess it or whatever. The whole idea is that you're working with something from a face. Yeah. And so in this case, we're going to do an assembly. So I'm going to normalize this. Let's do from a top-down view. This is our top-down. So we're going to be looking at the cartridge downward. And I'm going to go into the menu, and I'm going to do component. Actually, let me do, where's my insert? Oh, insert. Ooh, where is everybody? Is this actually an assembly? Okay. Oh, there it is, existing part. Okay. So I have this, I can select because I already have it done. And you can adjust your X and Y here. And let's see, I want to make sure it's upside down. Okay, I don't want it back like this. There. Okay, so this is the view I want to be looking at the whole entire case in from the top side. So I'm going to just hit the button and it's going to stick to it. So this is the first piece of our puzzle, is this. That's in the assembly. And so I'm going to float this on purpose. So now I can actually move this piece around in space. I don't want it to be locked to anything. But when you're designing something on this, if you're going to design a plastic enclosure or anything that attaches to your main unit, the main unit's what you want to have frozen in time. So that's your center origin for everything. And so what I like to do is go and figure out where all my planes are. You can see this is the front plane, and this is I'm going to find the matching plane. And so I can actually align these, this is wrong because I'm not sure why SolidWorks did it wrong. Oh, I picked the wrong board design, or from yesterday. So basically you would lock each one of these to a plane. And once you do that, this becomes locked in time, and everything wraps around it. And the reason that's important is that we start moving your case pieces around and you accidentally grab this, it'll actually move it someplace in space. And you don't want that to happen. You want it to be fixed in space. We're going to move things around it. So we'll insert another part that is an existing part, and I can just browse for that. And this one should be pretty familiar looking.
Hey, we recognize that one.
Yeah. So
But
this
without having it looked up, you could immediately see what row it is as well, or not? You've seen them so often
Oh,
now, these keys.
actually, I'll show you in a second here. I'm trying to get this the right orientation for our little product here. Let's see, what do this way. Actually, so that's upside down. We got to go this way. But how do we want to do? So what do we want to do about the angle of this? We want to have it so that
To me,
backwards,
that's the original setup. To me, that would be.
or do you want to have it 180 degrees rotated?
Yeah. I'm looking at a Commodore 64 here.
Like
I would
this?
imagine what that would look like.
Gotcha.
That's not how you would. It would make sense if you didn't have the keyboard there. I would probably have it like that because that's the original orientation of the Commodore logo key.
I will just push this down. So now if I put my mouse down on this board, it doesn't move anywhere. But if I grab the keycap and do it, it moves anywhere I want it by just dragging with the mouse. And so what we have are mates, what's called a mating. So you mate everything together. So these parts are already pre-mated by KiCad because they generated all the data this way automatically for us. So that's great. We don't have to deal with those. But when we're adding other things, we have to mate them. So we have to put this, so it's dead center over top of this shaft. And so to do that, there's a lot of different ways to mate. The easiest way to do it is to do accessing, like an access lock. And so if you take a look at the keycap, this is the actual row 4 SolidWorks data, by the way. This is actually what's in the campaign. If I go here and take a look at these planes, you can see that's the dead center of the keycaps right here between these two. And so if I look at the origin of this, the origin is dead center inside of this stem receptacle right here. And if I take this origin and I try to wrap it around here, I can do a concentric mate.
Yeah.
And so now it's going to pivot and stuff around this because I try to move it up, but it's going to be matched on origin. So the origin is probably not a very good way of doing it because of the fact it allows it to actually wiggle back and forth. We want something with more of a planar line, straight line. And so if you're better off doing something like, I'm really surprised I don't have an axis in here. Maybe I should go put one in here real quick. So here's the keycap, and you're asking about row 4. So this is what's actually embossed inside the keycap is R4.
Early great decision.
Oh yeah. I mean, I knew this was going to be something we need. And then so it turns out they didn't actually use this. So these aren't really there in the production keycaps. They lasered these in, so they're embossed instead of being actually embedded instead of being embossed like this. So they're laser etched in. So it's the same thing. It has an R and a 4 or an R and a 3 or an F7 or whatever the keycap happens to be. So I'm going to do this. I'm going to put I'm going to put an axis in here. So now we've got a center axis point in here. I just took these 2 planes and created an axis so that's down the center of it.
Yeah, a flat one. Yeah.
You can see that's perfectly dead center.
Yeah.
So I'm going to go back to our assembly. And now I've got something I can lock onto this to be concentric. And now this will move, it'll rotate, but it'll actually be rotating on the center.
Yeah.
And so now we want to stop the rotation piece. So there's a lot of ways to do this. You can just pick an edge if you want to, and then say it's going to be parallel to this edge. Actually, in this case, I can't because it's a rounded, this keycap is rounded. So you have to pick a plane to do it. So it's not rounded. So I will say this is going to be parallel. And so now that I made this parallel and I made it concentric so it wraps around this, I can grab it, I can move this up and down, and it's perfectly in line now.
Right.
If you want to verify that, you can actually go into the pop-up menu and I can change this to be transparent. So you can see now that the keycap itself is transparent. Totally. And so now when we drag it, now there's going to be no mystery. We can see exactly.
Yeah, that's super cool.
And then we need to figure out also depth-wise. So we don't worry about the keycap coming down. We've got plenty of clearance here. but how much clearance are we going to have in here
Yeah.
for this thing, the plunger to pop down?
Yeah.
And the reason why I picked this particular keycap, this is actually for the Cherry MX switch, by the way.
Yeah.
And you can force it over top of this stem, the push button stem. So we don't need an adapter for it, actually. You can just push
that's
down,
great.
and actually will go in place. So that worked out kind of good with that. So there's a little bit of a crush in the plastic, but it's plenty enough where we can actually do that in here.
Yeah.
So it's pretty cool. So what I'll do though is I'll remodel this so it's round, and I'll put a stop in the top of it so it can only go down so far. But
Yep.
for our model, we need to figure out what depth do we want to have this off the board. So again, we can do a mate like here to the board. So I'm selecting, I'll select a surface, like I'll select this surface to this surface, and I can say there's going to be a distance of how many ever millimeters. If I want to say this is going to be 4 millimeters, that's it. So now it's going to be locked here. So if I grab this, it won't move. And it's going to be 4 millimeters off the base. So this gives us a really good idea of where our switch is going to be, because we got to wrap a case around this as well. We have to have a hole in our case for this to pass through and a space for this to go up and down. So this basically, we looked out also here. Do we have enough clearance on here? Let me normalize this. Yep. So we've got clearance to here, but obviously we're not going to have any plastic in the front of this side. So it's going to be a U shape that wraps around this on the case like this. Do you follow that?
Yeah. Yeah. That makes sense.
Okay. So we're going to have a little bit of clearance in here, which is great because we have some wiggle room here. So the only thing we have to worry about though is when we did this, so this cartridge connector here, we know that here to here, what the distance is, we can actually measure that with our measuring tool. And so that's 9.38 millimeters. That's great. But this is not going to work, Gary. And I'll tell you why it's not going to work. It's not going to work because of Gideon or anybody else that's got a bigger cartridge. So if you take a look at this, my little window here,
Yes.
you know, the cartridge itself fits inside of the connector, fits inside of here.
Yes.
Inside of here. But
Yeah.
look how big and fat this is.
Yes.
So if we take our handy micrometer out and we want to measure this to see how fat Gideon's cartridge is. And of course, today my micrometer's battery starts flashing. Oh, go figure. Grab the other one. Okay, we'll switch this into metric for the metric folks. I don't use metric ever. So this is 20.39 millimeters.
Okay.
How wide the cartridge is.
Yeah.
So we're looking at this only being, if I measure this side to this side, and I ask Solidworks how big that is. So it's 9.39 millimeters. Well, that's a lot smaller than 20 millimeters.
Yes.
And so we're going to have a hangover of each side. Let's just say this was 10 and this is 20. That's going to be 5 millimeters each side. So do we have 5 millimeters of clearance between this and the keycap? Let's find out. No, we have at the smallest section, we have 0.37 millimeters, and then we can actually set up on our tool here the minimum and maximum. So the minimum is that, and the maximum clearance we'd have is going to be 0.5. Yeah, so 0.5 something. So obviously 0.5 is a lot smaller than 5. So this design right now, we would know would never work for what we want to do.
Okay.
And so what we would do is do one of a couple of things. If for some reason we are stuck with this board layout design for some reason, like for example, that we didn't design this, somebody else
we
did.
got 1,000 of them laying in front of us. Yeah.
Well, it could, that could be as well. We don't want, that happens. So we're like, okay, do we take this and do we change this so we use something completely different, which is a possibility. We could also try to scale this. We scale it down so it's a smaller version of this, and we simply 3D print this ourselves.
Yeah.
One of the options is in SolidWorks is you can scale things, and so if you do a search on here, you can see pop up all the different functions in here that you don't see in the pull down menus. So
Right.
you can do scaling. So do we make this physically smaller, and do a 3D printed version instead of the original keycap version? Or do we extend this out the back a little bit further and then change our circuit board because we can? Or do we move this? We can't really go any further.
Yeah, we can't
in
go
this
further
direction.
close to the case. We were already fairly close to that line, huh?
Right. So that's the thing, is that we don't have the line here, which is unfortunate. But what we can do is we could open up this part again, which is with here, and we could actually do a sketch on this PCB surface, and we can put in a center line, and we're going to draw a line. This is much like the fabrication lines we saw with this program with KiCad. So in our fab, we had our little line here, and we actually drew a line on top of it on purpose. Let me put this there. So our fabrication line that we had, get rid of these. You can see this is what was in the.
You're sharing one screen. Remember?
I'm sorry. Yeah, let me. Yeah, there's a new share for this. My bad. Okay, let's do. Oh.
Yeah, we're in KiCad now.
No, you don't see one, do you?
I can see KiCad.
Okay, so you see KiCad now. Okay, good.
Yeah.
So, okay, you see, it's really light text on my side. So you can see this line here is what was put in the fabrication lines, which is the same thing I'm be doing in SolidWorks. I'm putting this a simple line in there that's not part of the design. It's simply letting me know where the stuff is. Now, while we're here, we can simply go and use our measuring tool, and let's figure out how far this is. We'll go select millimeters because we're using millimeters on the other one. And we will just draw from here to here. And we can see that we're about, what, 35 millimeters or so from the line to here.
Yeah,
to the edge.
Yeah, that's what it looks like, yeah.
Okay, so great. So we'll change the screen again, now that we know we can do that. And we'll go back to SolidWorks. And you've got this. So this is our line here. So this is one of the patented things that's in SolidWorks. This thing's called Smart Dimension in the pull down menu. And I can just simply click the line, and I can click the edge, and I can actually go and set this to be
fantastic. And now you can just
whatever I
change
want it to be.
5.
So 35. So now that's exactly where our line is that comes out of the 64.
Yeah, which makes sense because we had centered it between those two.
Right, and exactly right. So now if I exit this and I switch back to our assembly, you can see the line. It's like very faint. There we go.
I see it.
Faint. So we're kind of in the same pickle here, really, because if this really is the back of the edge of 64, our switch is going to be so close to here.
Yeah, I would argue that there too it might not fit or badly fit.
Right, and so.
You didn't press order yet on those on that 1,000 run, I hope.
Yeah, don't press the go button. So what will we do? We extend the board. So let's think about this from a couple different points of view. Let's say we had those 1,000 boards. What would we do? We'd be stuck really changing this probably.
Yeah,
right?
changing that the keycap ID would need to go and just get some standard.
I would go to the production manager and I would say, okay, here's what we're doing.
Yeah,
we're just going to be doing this, and we're not going to be providing.
Yeah, exactly. And find us somewhere in the warehouse 1,000 buttons, super cheap.
Or just do this and then
leave it like this.
Stem height.
Yeah.
Change the stem height, so it's just simply push button and we're done.
Right.
And that way we don't have to worry about this mess, and that's how you end that mess. But if you really are stuck on having this, then we're going to have to go back to KiCad. We're going to have to stretch the length of the board. And that's going to be, more work to do. But however, it's a lot less work than having 1,000 boards laying around you're going to throw away.
Right. Yeah, very much so.
So let's just pretend this was okay, because we're going to actually start looking at doing the case around this for our standoffs and things that we need to do. So one thing we have to do is we have to measure, and I'm going to stop sharing here real quick.
So in this case, because we've decided this is not going to work. The key doesn't work. But
we're gonna
what
have to
we could
redo the
perhaps,
board.
but perhaps what we could do is just create a secondary 3D printed part that extends the stem of the switch through the little hole so that you can press it through the case.
You could do that, you know, but the area back there is pretty small. I mean, that's, you look at that.
No, but you
width of
would
that.
keep the same stem width and just make it go through the case and just imagine that it's now a what is it, a 6mm stem. It
Sure.
would be a 30mm stem, if you will.
Right, so the highest stem you can actually buy is 12.
It's 12. It would still not be enough, so you would need
Yeah.
to 3D print something or
You
use
could do an
whatever.
adapter piece for it, or
Right.
on top, and then you could do a button that's actually comes up from the bottom side of that, instead of having from the top side, and that actually catches the stem. But I think realistically, this was not a very good choice as far as the spacing is concerned, because of the fact that we don't have a lot of room, and that we got basically one keycap's width of space back there.
Right.
And so if the goal was to keep it as short as possible to the computer, we obtained that goal, but I just don't think it was very good in general for the way it would work, which is, I knew that when we were doing it yesterday, so it's okay. So one thing we need to do for building a case, let's just say that it was perfect, we're fine with the way it is. We know that when a cartridge is inserted, we've got a cartridge here. So this is a handy dandy Commodore original desktop or test cartridge. So here's the dilemma that we have. You can see the cartridge, they're almost at angles sometimes, but the space here, we can do this. You can see that there's a gap in here, and there's actually a little more gap because there's feet. So we don't want our board to droop. So our cartridge case is going to have to come out, and then some point back here where we're going to support it, it has to come down to the same height of the bottom of the
Yep.
So it's going to have basically like a foot that comes down.
Okay.
And we want to make a foot. So we got to know what is the distance from the bottom edge of our cartridge now to here. And then what we'll do, because we know the cartridges are split 50-50, we can simply measure the depth of our existing cartridge, add that to the foot, and that's how we know exactly how far.
Yeah, makes sense.
So we're going to have a little jog in this. Basically, it's going to come down and then up and over and then into it. Like that. So we'll measure this, and we're going to use the pen piece to measure it. A little end piece here. And if we can do that with this one, I think it's pretty easy to do. So yeah, we're looking at basically, that's a fluke, huh? Yeah, it's right at 8mm. So so, and then we have to account, because that's flush against here, and then we've got our feet, little rubber feet thing that goes in here normally
that you need to add to it.
We've got it on the front. I don't have them in the back of this particular one, but we have to measure that depth as well to be able to add it. Or we leave it the way it is now, and we've also put these little circular pieces with a rubber foot piece on it.
Now I kind of like that idea because of multiple reasons. Because I don't know if there's a lot of difference between this and the bread bin, and then from a height perspective, so that allows you to probably cater for both.
A little fudge factor in there. Yeah, I agree. So this is probably going to be what, 50,000. Yeah,
that's another half. That's another millimeter or so.
1.3. Yeah. So 1.3 millimeters for the height of the little circle that really is actually off of the surface a little bit. You can see. And then, so like I said, these are, a little hole here, and on the front side of here, you can see there's actually a little rubber. These are the ones that always are gooey, usually.
Yeah. Normally it would have 4 of them, and they'll come in, and if you're lucky, you'll have it's like chewing gum stuck on them.
Yeah, like they're just gooey. I actually pulled the back ones off because they were that way.
Yeah.
So
never come off your fingers. They don't stick on anything but your fingers.
Yeah, it's magical.
Exactly.
Okay, so we know 8 millimeters is going to be our jog depth, and then our cartridge itself. We've got a cartridge. We're just going to copy this. So last year we actually made this project, and so this cartridge is I think it's like 11 millimeters.
Okay.
Basically, so 11 millimeters thick. So what we'll end up doing here is we're going to put a little jog down here
Yeah.
that's going to match our, in addition to what we've got here for our half thickness here.
Right.
So it's going to come down 8 millimeters from here, and then we can figure out width-wise what we want to do. For, is it the full width of the cartridge, or do you want to have 2 posts that come down?
Right.
You got to think about when you're doing 100,000 pieces. This is why Commodore did the cost reduced version of the 64. That's why they did. I'm sure it's why they did the 2 different keycap stems, where one's 3.5 millimeters. Because if you make a couple million stems that are 1.5 millimeters smaller, that's a lot of
plastic safe.
Yeah, that's a lot of plastic. And so if you're building 100,000 cartridges to wrap around this as cases, and you're going to do a full width of it is the foot, as opposed to 2 posts that are 2 square posts that maybe are going to be 12 millimeters or whatever.
Yeah.
You're going to save a lot of plastic in the center part of that.
Right.
So I mean, that all depends on your design goal. Do we care? No, let's use as much plastic as we can, because we're going to be 3D printing these anyway.
Right.
So we don't care. So I'm gonna go back to the SolidWorks thing here. So we have this as part of our assembly. There are 2 pieces in our assembly here. And so now what we can do is create a new part. So we're going to do a new part, and the new part is going to be the first half of our case. And there's so many different ways. If you look at last year's video on the SolidWorks I did, there's a bunch of different ways to create cases. You can do it as one solid case and then split it in the middle when you're done. And then I think I did both versions last year that way. I typically build things individually and then mate them together, and I have the best success with that. I don't like splitting something because it makes it more difficult. Because in SolidWorks, it uses as a reference when you do a split. And so it's really hard to actually try to manipulate each half, because it tries to mirror what you did on one half on the other type of thing.
Okay.
And so let's do the top side of the case, and we're going to do a sketch. And we're going to start with a box. Let's do a box, not a there. Let's do a box. And I always do this because for whatever reason, I just have the best luck doing this. I just do center line, which is a construction line, and I will connect there, and I'll do center line to here. And I'm not using any keyboard shortcuts today because I've got a gazillion for SolidWorks as well. So normally I can actually do this automated. Let me connect this to here. Okay, so there's our box, and that's it. So if you've never used SolidWorks before, this is it. This is all the magic. I made this sketch. Now I want to make it a dimension to this, because let's put some fake dimensions. Let's do it 60 millimeters long by what is it actually? Is it Commodore's 235? So it's 23.5. So that's going to be wrong, but that's gives me a kind of a ratio for that I was looking at. Okay, so this is basically our cartridge top. And so we know that's completely wrong. And so we need to go back to our assembly or to the PCB itself, either way. But assembly is always good. And we're going to measure. So we know that our cartridge actually wraps right to the edge of this on a regular cartridge. So if you look inside of a dead test cartridge or any of the cartridge, you're going to find that the fingers go basically all the way to the edge.
Yeah.
So what we want to do basically is measure this edge to the back of the circuit board edge, and then we use the measuring tool to do that. And so let me actually do this face here to this face here, and that distance is going to be 65.278, blah, blah, blah. So it's 65.28. And so we know that's the length of it, and then we know the width of it. We do the same thing. And so we've got, this is 58.42. So knowing those dimensions, we can go back to the sketch we were in, and we know that, so this is 58.42, and this one was, what's that one? I didn't pay attention. You're fired. Okay. Oh, 65.278, that's right. Okay, so our sketch, so 65. 65. 78. Okay, so this is the 100% dimension of it. So we know for fact that you are never going to get a case to put on top of the board if it's the exact same size. We have to have space around it. And so
Yeah.
how much space can we actually have? So if we measure out a regular Commodore cartridge, we can measure the case out, which I'm going to do right now. And the regular Commodore cartridge width is, the width is 68.25. And the length doesn't matter in this case because we're
that's variable. Yeah.
we want. So basically 68.25 is a standard width. So you can see that we're at 58 here. So that gives us 10 millimeters, so 5 millimeters aside. So, and our case is going to be 2 millimeters thick or 2.5 millimeters thick. So it tells you how much space you're going to have along each edge of here.
Yeah.
So let's just make this 68 even. That's fine. And then this length here we'll play with. We'll make it 65 plus whatever the well, let's make it 70 for right now. Let's give us a little more space. Okay, so that's basically our entire cartridge case top. Doesn't look too great because we have, we have no visual reference for what it's going to be. So what we're going to do now is we select our sketch and then we're going to extrude this. We're going into features and we're going to extrude this to be a height. So in our case here, if we measure out the Commodore height wise, it's going to be, I think it's 10 millimeters. It's pretty common for all these, right? 10.5. I think it's 11 total. Let me look at how this one was. So 10, fine. So basically it's 10. And so ta-da, that's our cartridge have.
Yeah. Yeah.
That's not very good looking. And what we need to do is we need to shell this out. We need to cut it out so that the cartridge will actually fit inside of here, because obviously a brick is not going to fit on top of it. And so there's a lot of ways to do that. You can use the shell feature, which will let you pick a surface and then pick how much of shelling you want to do. So if you want it to be 2 millimeters, you can see now we've actually shelled out 2 millimeters. So that's how thick the entire case is going to be, is 2 millimeters thick. And so we've got a box basically.
Yeah.
And so to get an idea of what's going on here, if we save this part, we'll save to the PC. And we're going to call this top. My caps lock must be on. It is. Okay, so we do this top. There. The only reason I did that is because in the window here, it's a little easier to identify. Like we haven't saved our assembly yet. It's called a SEM4. So we'll save that at some point. So we'll go back to here and we'll do exactly like we did with the keycap itself, is that we will insert that as a new component piece, an existing part, and we'll say top. And then we can simply just drop it in here. And now we have an idea of, we just drag it around.
So do we now need to design those planes as well, and kind of so that we can do the orientation?
Yeah, so what we would end up doing is to make sure this snaps dead center of this case, is that because this floats and this doesn't float, is that we'll go into the PCBs, planes. And this is why I'm going to be in trouble too, I think, because so when I exported this originally with KiCad, I didn't tell it to use the board center origin. And so it ended up doing.
Oh, and I remember you telling that was.
So actually what I could do, let me do this. This might be an easier way of doing this. Let's replace this component. If this doesn't break everything. Replace it with simple 90 PCB. I don't think I actually saved that one. Let me look real quick in here.
You want to go to KiCad and export it again?
Well, I could do that, and I could re-import it at that point, because that's basically what we did. or I could actually just import the PCB and then stick the parts on top of it as well. Yeah, let's go back to KiCad real quick. And actually, we already have it on KiCad. We already did it. Let's just go re-import it and save it. So simple 90. There. So I showed you the colorized one. This one was saved everything with the references, because you can see when I look at
it sent us. I saw it immediately.
Yeah, exactly. So that's one thing that I keep forgetting to do when I upgrade KiCad over from 6 to 7 recently for this. Actually, I've been using 6 forever. I forgot to actually set that option on the export. Okay, so let's do save to PC. Document can save an empty sketch. Oh, I don't want to sketch. Okay, let's do save to PC. And I'm going to call it SolidWorks. I'm going to say simple PCB. Oops, I did not mean to do that. So one of the things you can do is you can save it as an assembly, which I just did and I didn't mean to. Assembly means it breaks all the parts apart, and then you have to go back and reassemble it yourself. If you save it as a part, it saves everything together. Which
in this case will be more useful, huh?
Oh yeah, absolutely more useful for sure. Yeah. Okay, so now let's go and go back to, let's see, let's just close things that we're not using anymore.
Yeah, because we don't need that anymore. We said we're not going to go that route.
Right. Let's see. Actually, I will save this because it needs the access that I made for it. And I will go and do this. This one I will get rid of. Don't save. Discard the changes. And here's our assembly. Okay, so what you can do in here is you can actually, an option, if you right click, is you can actually replace the entire component. And theoretically, you should be able to go and pick the simple PCB now, wherever it is.
And it will just exchange it, or that will be the theory at least.
Yep, it's exchanged it. That's the theory. And you say, okay. And then it's going to give me a ton of warnings about the fact that we no longer have mates connected correctly.
Right.
Because of what we did. Yeah, that's okay. So yeah, because it doesn't like the fact that now our keycap doesn't match and all this stuff. But you know, it lets you do things like I can map this to the actual XY origins now. Okay, so I'm going to get rid of all the mates that we had. So we get rid of all this stuff. So yeah, these are the things you learn when you are doing your board. It's like, oh man, I should have redone it the other way. So I'm going to float this board, and I'm going to look at the front plane. And this is my matching plane. I'm going to say it's there. So move this out of the way, move this out of the way. And I will go grab the next plane with my board here. And that way it's marked in coincident. And then we're missing, what are we missing? This plane here. So we're missing this plane. And so, okay, did that actually work? Looks like it. Yeah, so it doesn't move anymore now. So when I grab it, it doesn't move. It's locked to those planes. So I should be, you can verify by going through here and looking to see that they're all locked now. Okay, so we're locked, and then I can move this. I can do this later. I'm going to sketch there. I can move this later and add that. So we don't care about this so much. In fact, I can actually hide this.
That should just go away.
Yeah, I'll just do a, whoops, that's not the one I want to hide. I want to hide this one. Okay, I'll hide that one. So now we're back to here. So this is our top of our case. And so we want to do the same thing really, is we want to take our, we don't want to do the top plane because we want to be able to move the thing up and down. But we definitely want to have left and right and front and back to match this, the edge of it. And then, so on the cartridges, I actually like the finger to be up a little up inside. I don't want it to be sticking straight out of it because I think it protects the cartridge a little bit when you do that. So if we have this so that it's like this where
where it's a tiny tad recessed.
Yeah, I mean, it's 2 millimeters. I mean, I can do it this way. I can do whatever I want like this. So we have to figure that out. But we definitely want to have it so that it's centered. because it has to be. We don't have a choice in that matter.
Yeah.
So that's when we can look at our case piece here. So we're going to look at this side. So, oh, that's bizarre. Why is it off center? That's the top. How on earth is our case off center? Must have done something here. Oh. Yeah, I didn't center this when I designed this part of it. You can see that's the centerpiece here. I did this and I did this. So I didn't center these at all to the origin.
Okay.
That's okay. So one quick way you can fix the problem too, if you don't want to mess with this, which is just do this type actually. Let's just draw on here a sketch. This is a cheap way of doing it. Let's say, for example, you're using a step file where you don't have access to the data at all,
Yeah.
where you can't actually
Yeah.
grab it and manipulate it. You can actually look at a surface. So if you click on a surface, then you can actually draw a construction line.
Yeah.
And at that point, that construction line is cast through everything. So now I can say, this is a construction line. It has to be equal to this.
Yeah, you can
line.
match the construction lines. You can match
And I
them.
can do it through a construction line.
Yeah.
So if you got something really screwed up, you can do it that way.
Yeah.
I'll have to figure out what I did with that. That's bizarre. And then so one thing that's going to have a problem is you can see if I grab this, it's,
Yeah.
it's tilting and doing all kinds of weird things. And so we don't want that to happen. So we want to make sure that this surface is always parallel to this surface. And
Yeah,
that
it's
way
only
now
a
we
Z
can move
movement,
this.
really.
So now we can move this up and down, and it'll move up and down and forward and back, but it won't move left or right to here. So
Yeah,
you can
got
see
it.
we split the difference in here. So what we need to figure out too on here is say, okay, is this actually going to fit cartridge? We know that the Commodore cartridge itself is this width from here. Let me mark it. So
Right.
it's easier.
Right.
Here to
That's
here,
68 or whatever.
that's a real cartridge width right there.
Yeah.
We know that will fit in the slot.
Yes.
For sure. So then we want to figure out if we'll do normalize so that actually let me flip this around so I think it's easier to see top wise. So here we are. What do we want to do about the edge of this cartridge? And we'll ignore the fact there's a wall here because we're going to remove the wall so the fingers can pass through. But we're just going to figure out how deep do we want the, obviously we don't want the finger sticking out. So we want it like half of this so that there's a little bit.
Yeah, just a tiny bit indeed. Yeah.
Okay, so let's make sure that we don't just have some random amount. Let's go.
It was the wall was what 2 millimeters, so you're gonna set it to like 1 millimeter.
Yeah, so we can just pick this edge here and pick this edge, and then we can set the distance to be. What does it say? 17. Well, that's bizarre. Well, let me do this. This one to this surface. That might be an easier way of doing it. There we go. That makes more sense. It's 1.0 whatever. So let's do a 1 millimeter exactly.
Yeah.
So at that point, now this is locked to a millimeter. So now when we move our cartridge, it won't go left or right. Oh, we need to actually lock the board. I didn't lock the board. I need to do that. I must not have locked this surface. Okay, there to our board. Where's our board at? There. There, I forgot to lock that surface. So it moved around on me. Okay, so now when we do this, it only moves up and down. That's it.
Yeah.
And so now we really have a good idea, knowing that the cartridge, we know the fingers are dead center of the cartridge as well.
Yeah.
So that's good. So we could actually lock this to the center of the board. So we could do like this. So if we knew that what the board thickness was, and so we measure the board thickness, and that's going to show us as what 1.3, I think is what this is, or 1.58. So it's a 0.62 board. So it's 1.58 thick is how thick your board is.
Yeah.
So if we wanted to move this down to here, so it's over top of it, and we want to say this surface here, which is this edge, like this edge here, to here is a particular distance. we know it's 1.58 divided by 2, which is great because you can put formulas in SolidWorks. I mean,
Yeah.
you could actually put a real formula in, like
So you just can do math in it. Yep.
yeah, you can do full math in it too. You can do trig, you can do all kinds of stuff in it.
Yeah.
It's cool. And then so now we know for a fact that our fingers are going to be dead center of our cartridge, except for the fact that's not going to be the case, because this needs to be, actually it's right. There's some clearance things you need to make sure you've got enough space in here, but we're not going to worry about it for right now, especially for a 3D printer. It's not a big deal. So if we make another one of these and flip it upside down and snap it together, we would have basically like a regular cartridge at this point.
Right.
Okay, so we've done this, and then so you notice, Yuri, that if we did want to do just the button part here, it kind of pokes up through here.
Yeah.
And then we also need to make sure of this too. Let's make sure that whatever we've got for electronics in this particular package fits in a regular cartridge case, which it does. So we could actually use a regular Commodore case if we wanted to for this, because we don't have electronic circuitry sticking up inside of here.
Right.
Let me make this transparent. So you can see we've got an empty box in here, so we don't have any worries. We don't have like stacked EEPROMs or anything crazy in here. But we do have this little switch in here that's kind of cool. And what we could do, if we wanted to, is we could do a sketch on this surface. We could do a little circle, and we're going to use the center of this circle as a reference. And with SolidWorks, if you monkey with the mouse around here enough, it'll end up finding the center of your circle for you. So like you can see, there's a blue line that gets built right there.
Yeah.
If I follow it up, it goes in the center of this thing. Another option too is what I usually do is don't even do that. I actually draw the circle like this, and then
you basically center it and then do the cut.
Well, you can do it either by grabbing this over here and SolidWorks will snap to it.
Yeah.
Or you can make it concentric so that I select this as a concentric match, and then it snaps to it. There's a lot of different ways you can do it, but you're making it concentric either way. So it's pretty relevant. So we don't know what size this is. Let's make this circle size. Let's make this 5 millimeters. Okay, and then we're going to exit this. So now we've drawn basically a circle around your thing, and then we could either extrude this down and then chamfer it, or we could try chamfering this now. There's a lot of different things we can do for options. Now, one thing I just made a mistake on, which is great because it's a good part of the demo here. I just drew this on the face of an assembly. So you notice that I didn't actually draw it on the part. I put it in the assembly. So it shows up in the tree in the assembly.
Oh, yeah.
Which is a no-no because you can't do that.
Yeah.
But so I have to delete that, which is fine. But you can do it in real time if you want to, if you select the part first that you're going to be drawing on. And then you can actually say edit component, save assembly form, save and continue. Okay, I've got to finally have to do our assembly now. Let's see. Let's call this lesson. So lesson. Okay, so that's assembled. So now that it's in the tree, it's highlighted, and now we can go ahead and do a sketch on here, and it's perfectly legit to do it. And it'll be just for this part, and it'll actually move it to the part when you're done. Oh, come on. There we go. And then we will do a smart dimension, set this to 5. Okay. And so now we're still in the edit component thing here. So now we have the option of selecting that sketch and then doing something like an extrude cut. If we want to cut it down into the case, we can. If you want to do let's see, what else can we do? I'll probably do an extrude cut first. And I'd only do like 1 millimeter because our case is 2 millimeters thick. So you can see what we did here, right?
Yeah.
Put a little recess in here.
Yeah.
And then we can select this line here and we can make this a fillet. And we can make the fillet however big we want.
Yeah, that looks great. Yeah, yeah.
Let's do a little bit smaller than that. Let's do a 5 millimeter fillet. And then so now this is what we did.
Very, very nice indeed.
So
how close is the bottom of this case now to the PCB? Is it like almost like touching the PCB?
The bottom of the case.
Not even.
So the bottom of the case we made So it's split 50-50 with the PCB height. Because
Yeah.
we're gonna make a second one that's identical to this in shape wise. It just
Yeah.
pops in place.
But in this case, if you would make this a production, you could even argue that you could make the top half not even as high. There would be no need for that as such.
You're
Other than
absolutely right,
make it-
Gary, and I'll tell you how easy it is to do that actually. So it's a lot easier if you edit out of here. If you go into the piece that we did made, so here's the top, and you can see now
right.
we did it. And you can see the problem we've got now too. We didn't have a hole in this.
Right.
So there's a way to fix that, and I'll show you in a second here. But for making this, we go to the original, and I name everything pretty much. So this is like the main. So I know that's the main.
The main, yeah. Which
Yep,
now
so-
is at what, 10 millimeters? I think you made
So we
it.
go into edit feature, and it's set for 10.
Yeah.
So we want to make this, let's make it like 7.
Yeah.
And then we've lowered it to 7. And then
Right.
now what we've done this, and we can go back to our assembly, and now we can see how much more the button takes.
Yeah.
Lowered
Yes,
the entire thing.
That's looking pretty slick, obviously.
Yeah, so the problem now, we don't have a hole here. So let's go back
Okay,
to
so you still
our
need to
top
make the
piece.
hole. Yeah.
And we can either drill a hole, or you can do the smarter route and figure out this is going to be the button hole, or button, button hole, call it that. And then
Is
you
that
go
5
to
millimeter
sketch.
diameter hole?
Yeah, so we made the external part 5 millimeters. Or actually the internal part, sorry, which one we do here? I gotta go look and see what's what.
No, the stem is about 1 millimeter or something.
So this we can measure out. Oh, my Solidworks is having a tizzy about something. Ding, ding, ding. Okay. Let's go back. Oh, there's a sketch open. That's what's going on. So you can't switch windows in SolidWorks with the sketch open. Or you can, but it's you got to be careful that you don't monkey with something. Okay, so we can do this. We can measure out the diameter of this. So the radius is 21 mil. That's the radius is 1.75 millimeters. So that's how the radius. So it's double that for the diameter across it. So we know that our hole has got to be twice that. So we'll go into here in our sketch, and this is our outside. So we're just going to draw another circle, and we're going to use the reference point here. And we're going to say that it is going to be 1.75 times 2 would be that big, but we need a little bit of clearance in there for the thing to move up and down.
Yeah.
So let's make it, let's add 0.2 millimeters, which is cool. You can do in SolidWorks. You just add 0.2 and exit. And oh, this is an extrusion. Extruded it downward. So I guess I have to do.
But you're basically trying to create a cut, right?
Yeah, so I have to make. There's like I said at the last year's CRX. There's a million ways to do everything right and wrong.
Yeah.
I mean, so it depends on what you want to do. Let me just exit out of this. Let's do this. There's multiple levels of undo as well in SolidWorks, which is great. And so for this one, I'm going to put a hole in here. So I'm just going to do a surface, and I'll put a little. I can figure out where this. Okay, fine. I'm going this way. I'm going to make the hole 3.7, and I'm going to move it to here. Actually, here to here. I'm going to make that concentric, and there. That's our sketch for our hole. And then now we need to cut the hole by doing an extrude cut. And you can do it blind. And then so measurement, I always like to do, whoops, that's my bad. I always like to do an actual reference to something instead of just a blind measurement. And the reason being is that if you change the thickness of this case, it's going to screw up your whole design unless you've got a reference to this. So I like saying to a surface or up to next, either way. But a surface is pretty common. So I think up to surface, and I pick here. And now it's going to have the hole correct.
Yeah.
If I change the thickness of this case, it'll be correct without me doing anything to fix it.
Okay.
And so now we go back to here, and now we can see that we have our buttonhole, and
Yeah,
we've got
it's got a nice little spacing around it. Yeah.
Yep. And so this is not part of our design goal, but it's a good, showing you how you would do this. And then so pretty much, I think this is kind of ugly, this case, as far as, aesthetics wise, you guys start thinking about aesthetics. And so like this faceplate, obviously we have to cut away because the fingers won't fit through.
Yeah.
And so you can do it through the top side piece. I can measure it. It's usually depends on what your use case is. I don't care in this one because we're just going to cut it away. So we know that we need to have this wall removed, right?
Right.
And so the easiest thing to do really is to sketch on this surface, and we're just going to draw a box, and just a random box, and I'm going to take and I'm going to snap to this by doing a collinear, and I'm going to make this one here as well matched collinear. And as long as we don't really care about anything about here, you can leave it this way. It's probably not a good idea because if you extend the length of the case, you may go past this here. So you're probably better off actually snapping to here as well, making this collinear. Whoops, I goofed that up. I can do that to this edge, collinear. There we go. And then here wise, you can do the same thing if you wanted to, and that will follow the thickness of the case that we do. So it'll automatically do everything for you. So if you were to change your thickness of your case or anything at all about your case, then it would automatically fix it for you. And then so one thing I just noticed too, when I did the plane here, you got to make sure that when you cut this, we go the right direction, which we will do. We're going to go into extrude cut, and it's facing the wrong direction. So we swap this and we say up to the surface here, and presto. So we have actually cut out the endpoint. And so if we go now and take a look at our unit here, now we've got our fingers can actually, be seen at this point. So one thing we notice right away with this cartridge is that we've locked this in space and time ourselves, but this board is going to move back and forth inside of here if there's not something that's going to support these edges in here. So to keep that in mind in our design, typically you've got something that's super thin, or you've got like little walls in here that are just that prevent you from having an issue. This cartridge doesn't have it, but I've seen a few that actually do that. They've got little edges in here that basically they're referencing it. And that fixes that.
Yeah, they put those little carvings in them, like little
registration into it. Yeah, so we can actually do the same thing on ours, but we can make the cartridge port a little bit thinner if you wanted to, because the thickness doesn't really matter so much. But we also can't actually go much thinner this way, because when you look at a cartridge, there is a gap that's required between the finger and the edge of the case.
Yes, otherwise it would never fit over the...
Yeah, it won't fit in. So you really got to make sure that you've got the space in there. So I'm going to leave it like this for this design. And what we can do is either put pins in here to prevent the thing moving back and forth, or we can put in little walls inside of here that prevent it from moving back and forth. There's a lot of different things you can do, in this regard. It's all, again, depends on what your, design requirements are. But this is kind of a blocky looking case, right? And so there's a few things that we can do to make it pretty, but I like doing all the pretty stuff at the very end. Like this, I would normally do at the end and stuff. So we were talking about before about making sure that we can actually hold this thing down. So when we pull the cartridge out, it isn't like a rip the thing out of the back of it.
Right.
And so what we wanted to do was add some kind of like fingers on the outside of this. And that's a pretty simple thing to do if we just simply sketch on here and we just go crazy and just do something like this, where we just build a block like this, and we build a block like this. Okay, so we build a couple blocks, and we say, okay, do we want it to go all the way to the back of the cartridge, or do we only want it on the sides? Well, we could experiment here, and we can just do like, we'll do it like this width. It's going to be, let's make it 15 millimeters wide. And so one thing nice about SolidWorks is when you've got something like this, you could do a mirror of this if you wanted to, so it makes an exact mirror.
Right.
You can put in the measurement of 15 millimeters here if you wanted to,
Right.
or
Right. Right.
click this and say it's going to be equal. So now when I move any kind of change to this, it's going to change this automatically, which is
Okay.
great. So if you're doing something that's symmetrical, it's super handy. And just like if you want to have this line to this line to line up, you make those collinear, and now they're perfect. So
Yep.
now if I move this,
Yep.
they move
Yep.
together. Super handy to do. So now from a design standpoint, do we want it to be here, here, here? I mean, it's kind
And
of
in the
be
center, the center of that
kind of
cartridge.
centered, right?
perhaps.
Yeah. So there's a lot of ways you can do that too. You know, we can go back to this cartridge part piece here, and we can actually put a little center line down it. We can actually do a center line on here. I don't think, yeah, it'll do it here too. See, so there, I'm just actually doing a center line off of the center of this cartridge.
Yeah. Yeah. Yeah.
And then, so now I'm going to do a center line actually on the center of this one.
And
I'm
now
going
you
to
just
take
snap
this center line, I'm
them.
going to reference here, make it collinear, and presto. So now it's dead center of our thing.
Yeah.
And so now all we've got really is, you can see we've got wings that don't do anything. And we don't know the length out here, really. We haven't decided on a length yet. So let's just go and exit out of here. And oh, guess what I just did? I did the same thing I did before, huh? Where I put it in the tree instead of putting it into the item itself. So
Can you drag it? Can you drag it to the other one or not?
so if you go into here, into the top, and you go edit component, you cannot drag it into it.
Oh, that's
But what you
pity.
can do is and they should be able to let you drag it. I mean, it'd be awesome if you can do that.
Yeah, exactly.
You can do is you can do copy and paste it. I've done that before. But I think it's just probably end up being faster if I go into the component and just redraw it real quick, because I can do that pretty quickly. All right, so delete. Yes. And I'll go to the top and I'll edit component. And you don't have to do it on the component in your assembly. You can just do it in your actual drawing, but it's a whole lot easier to use like this reference. You could never use that in your actual part because we don't have that connector in the actual part itself.
Right.
Let me explain. Like, for example, I switch back to the top and all we have is this. We have no reference to anything at all.
Right.
So this whole reference actually comes from the assembly.
Right.
And so if you were to change,
which is awesome, eh? Your external parts offer the references here.
yeah, absolutely. And you can change the reference, and it kind of gets you into trouble sometimes too, because if you change something in the assembly and you go back to and like, oh, it tells you a warning, you know, you no longer have your reference available.
Right. Right.
And so, which is great. So you can go and fix that.
Yeah.
But I like having a reference in here. So I'm going to go to the top, I'm going to edit, and I'm going to do a sketch on here, and I'm going to do a box that goes from here to here. And I'm going to do a real quick center line on here. Okay. And then I'm going to center line this to here. And I will lock these together. Make this 15 millimeters. And then I will copy this, because you can do that too, copy and paste your thing in if you want to, which makes it even easier for you. I usually use a mirror for mine, honestly, because it's when I'm doing something symmetrical like this, it just draws both sides at the same time, which is great. And then I can snap this to here for collinear. Okay, so we're back to where we were. So I will exit out of here, and then I will go into an extrusion. And so now we can do the same thing. I have to flip this around. So it's going to extrude downward, and I'm going to say up to the surface of here. Oh, wow. I'm not sure why I went to that. Should go all the way down. Okay. well, let's look at this. We're going to get an idea of our little wings. So this is what we did for our wings. And so this gives you a surface area to push down on this thing, but obviously this is not very pretty. So what we probably want to do is round all these things with what's called chamfering, and or either way, or a fillet. A chamfer is more of a straight angle. The fillet's so rounded, and so you can do any kind of a size fillet you want to.
Yeah, it's amazing how quickly then your cartridge is coming to look very, very professional.
Yeah, exactly. And then so you notice that like on this particular case, you know, we've got this thing poking through here. We don't have a hole here.
Right.
We need to actually make a hole for this to pass through.
Right.
And when we do that, we probably notice that this is too close now at that point.
Yeah.
So we'll have to drag that over. So we'll have to figure out, do we like this even? And do we want to have this so that, this is solid actually. The reason I made it solid is it allows you to put a recess in here, like a little dip for your finger.
Yeah.
And so you can put your fingers on each side of the back of the cartridge and then just pull the cartridge out.
Right, right. And you could even do that same recess on the side pieces, left and right, that will allow you to pull the entire contraption out.
Right. So for example, if you wanted to put like a little fillet here to make it easy to grab a hold of.
Yeah. Or on the side, on the right-hand side. That's still
here you mean? Yeah.
That side, yeah, because then you can pull it backwards, pull the entire cartridge extender out.
Yep. And so yeah, this is all beautification at this point. So we do need to actually cut a hole here real quick. While I'm thinking about it, because we have to.
And a little oversized again, so that would easily fit, I guess.
Right, exactly. And also, so we know how much of a space we're gonna have to fix this too, because this is wrong at that point, even though it was a great idea to start with.
Yeah, it should have, the width should probably have been a little bit bigger.
So I drew a box, and then I'm going to do a reference around it. So I'm just going to do, that's 2 millimeters.
Okay, so you're going to make that
2 millimeters is enough, probably.
One is more than enough.
That's quite a bit, actually. Let's do like 1.5.
Yeah.
That's too big. How about just do 1? Okay, we'll do 1. And then we'll do the same thing here. This one, we'll do 1. And then we'll do 1 as well. And then we only have 1 left to do, which is down here. And so we'll reference here to here. And that's 1. Okay, so we've got our little border here. And clearly we can see we've got a problem here with our
definitely
like we're going to do. And so we need to cut this. So we're going to do extrude cut. And we're going to, I guess we're going to flip this, right? Nope, it's going this way. Up to surface here. Oh, that's not the surface we want. We want this surface. There, that makes more sense. And then we will do that. And then, so now we should have a hole.
Yeah, fantastic. Yeah.
We've got a hole. So it makes a lot more, you know, a bigger, better idea of what you've got. And even this 1 millimeter is pretty big, huh, Yuri?
Yeah, but still, you can see that's a little bit risky there with these side fingers.
Yeah. So if we go back into our side pieces here, and look at our sketch for this, we can actually see in our diagram, it shows you still actually, it kind of shows you where it is. If we had done, okay, here's a good example. We don't see our hole we cut here, but if we take that and move it up in the tree, it'll appear before.
Okay, yeah.
So when we do our sketch edit, now our hole is going to be there, because this happened in time before this did. So we put that ahead of it. So now we got exactly how much of a space we have in here.
So I think in this case, one of the decisions one could make is to say, well, instead of having this on the top piece of the cartridge, why don't we put this on the bottom piece instead, where you don't have the mechanical issue that you're creating here?
That is true. You could have it so it wraps around, but the only disadvantage that I think in this particular design would be the fact that if you're going to anchor it to the bottom half of the case, when you're
you're going to
holding it down, it's going to splay out those pieces.
Yeah, I totally agree.
Yeah. So again, you know, when you're doing your prototype testing, you're going to find out that that's basically what happens. Is that you're like, oh, that's wrong. So, obviously we don't have much time. I mean,
no. I think we're trying to show the concepts
Right, yeah. I'm not
Some
trying
of
to do.
this, yeah.
I'm going to do a finished case so people can play it and do this, and I'll extend the board out to be the right length and all stuff, get our files. But it gives you an idea of what goes into this. Now, for our bottom half of the case, we would do the exact same thing. We wouldn't have the cutouts, we wouldn't have the wing, or we wouldn't actually have the upper half of the, or the lower half of the wing. Or we could do an entire tall piece that goes all the way down and matches the the big foot that goes across the bottom too.
Yeah.
So there's so many different ways you can do this, and it really depends on, you know, like we're talking here, if we have these on the bottom, you may end up breaking the bottom part of the enclosure because the way physics works with it, you're going to be, you know, have an angle to it that's going to be a problem.
Right.
So you have to think about all these things, but
Yeah.
last of all the things you do is all your pretty stuff.
Yeah, all the pretty stuff. Well, and to
Yeah.
that, to the pretty stuff, a question came in. Could you put a logo on this plastic? I think you can.
Oh, absolutely.
Just
Yeah.
get
So
a vector logo, and then
you do a vector logo. You can do a regular, well, either vector or you can do a graphics. There's importers for JPEGs, things like that. It will convert it. It's not super great. You can do direct font right on top of it. So, for example, if I wanted to sketch on here, and I can go up to in the sketch thing, I can do this. I can say CRX, and you can select your font. This is one of the things about SolidWorks that to me is kind of quirky still, as setting like the, whoops, I don't do that. The size of it and the location of it, it's kind of quirky.
Right.
It doesn't have any great, like you're used to using like Photoshop or Adobe Illustrator. When you go to grab the font, you can actually move the font and see all the fonts, what they look like and all that. No chance of doing that with this. But you can literally, I can emboss this into the case, say that's what I want for it, and I'm gonna exit this, and I will go into extrude cut, and I'm going to extrude cut that blindly because I'm going to do it 0.5 millimeters.
Yeah.
And now, as a result of that, we've got this that's, you know, extruded into it. Now, if we wanted to emboss it, we could do the same thing. We'll just delete this, and so we'll do extrusion.
It's really cool how you can kind of use that work tree on the left to kind of go steps back and apply different actions to these steps.
Yeah, I'm gonna do this blind as well. So if I want to do this so that it's embossed, so it's raised, you do the same thing in a raised text.
Yeah.
Now, one thing we didn't really talk about today, that we talked about a lot at the last one is last CRX, was the fact that when you design for a plastic enclosure for production, it's completely different typically than designing for a 3D printed case.
Right.
Because with a 3D printer, you can print this case and you can make it work just fine. You would never be able to get this case to be made professionally, like in an injection molded setting, because you have to have drafts. You would never get this case out of the mold. You have to have an angle, a slight angle always to everything. And you can't have anything that's interlocking. So with a 3D printer, because you're doing it in layers, you can have things inside, like you could have a lip inside of a lip, and you really can do that with injection molding. So when you're designing your thing, you got to keep in mind, is this going to be something that's commercial that we have to actually get injected molded? Or is this going to be Yuri printing it on his Prusa printer?
Right. Now you bring up a good point there, and maybe we'll make that kind of like the ending of this.
Okay.
You'll do some work on this. It will get published. People can learn from that, pick it up from there. But you brought up a good point. Typically, the projects here, I presume, are going to be done either an SLA printer, FDM printer, or perhaps even like JLC PCB. You've done quite a bit of work with that on prototyping coming out of them, huh?
Yes. Oh yeah. I've done.
Is the FDM method good enough for them to accept a design? So would they be able to do this on their machine?
Yeah, the first they've got resin and they have FDM as well.
Okay, so the way they produce is basically.
As far as actual like real production goes. Oh, well, give you a good example. I've got some of my new Y modem cases here that JLC PCB did. And so because quantity is relatively low, we're only talking about probably a few thousand pieces for the Y modem that'll get sold. it's actually cheaper to go that route with JLC PCB. Let me stop my sharing here and I'll show you. So this is a case that JLC PCB made for me. This is a new Y modem case. And so I designed this in the regular SolidWorks, of course, but this has got like latches. So it's a snap together case. You can see I got little tabs.
Yeah, I'm going off video. So
oh yeah, there we go. So yeah, you can see there's actual tabs in here and they interlock into this half of the case. This has a display in it, and the board itself looks like this. Yeah. And so it actually fits like this. And I actually have a little push button that passes through. It gets kind of funny. Actually, I'll put this together so you can see if I can get it together. Come on now, there we go. So you'll notice that I did the same kind of little tampering recess thing that we did in our little lesson there. Gosh, this is the focus be better. So that's what I did for the little push buttons here. And it's just barely above the surface. So it's one of those things where you can push, but it's not in the way, not going to get hit accidentally type of thing. So, and then I have little LED holes that are here. You can see there's pass-throughs for LED. And I made the depth of those so that you can see the little block that's over here. I made them so they actually sit over top of the LED, so they don't have any kind of crosstalk, if you will. It won't have any light exposure for each one of them, so they're separated perfectly. So yeah, so basically this is $1.50 for each one of these cases. So it's $2 per case. So, and you look at the cost of injection molding, it's thousands of dollars to make molds. And then your plastic price is pretty inexpensive. But the final product that you get, because this is an actual HP, I think they use HPs for this one.
The HP, they
SLS, and they have different types of materials. In fact, they have transparent now. So it's pretty cool. You can actually do a transparent one. But when this thing all fits together, it just snaps in place, and I don't have screws to deal with.
And no screw anymore. So this is for low run, low run.
Right, like a few thousand pieces.
1,000 items. This is a very, very solid choice.
Yeah, it's a great choice for this. I mean, if I was going to do, like I said, more than a few thousand, I would have to go to injection molding, because at that point you're actually saving money. But the quality difference to me isn't really, different from injection molding. It looks just like this. This is an actual, production unit like this. So, and then I made this case so that you can grab a hold of it, as little fingers that you can pull the thing out, and so you can push it in with a flat edge back here into your port. So there's some design considerations, and when I did this as well, super simple, but you can design this easily with the SolidWorks Maker because it's a pretty simple case as well. There's nothing magical about it. And it's something that a lot of the hobbyists, I really hope they look into it, because it's a little bit intimidating, I think, when you look at a CAD program. Like, to me, FreeCAD, it's got a gazillion options and stuff. And I've been doing CAD for a long time, and it intimidates me. And I'm like, it's like Blender. Like, Keith, kudos to Keith for understanding all that stuff.
Because he grew up in that thing. Yeah, exactly.
And so, like, I've been using SolidWorks since 2007, I think now. And so I've seen all the iterations they've had since then, and it's grown. It's it's pretty mature product now, obviously, and the CATIA is used by General Motors and things like that for building cars and designing cars. So that's the high dollar and version of the software. But it's something that the makers can do pretty easy, and I'm super excited to help anybody that wants to actually design a case, because once you do it once and understand the concept that basically you're doing a sketch on a front plane or a top plane, and all you're doing is adding or subtracting material. It's exactly all you're doing is adding or subtracting material. You're rounding something off, you're cutting something, you're chamfering. So you're and the cool thing about SolidWorks is that you could cut something away and then add it back in at a different angle or something if you wanted to.
So it's woodworking on it's woodworking with a Control Z with an undo button.
And exactly, and with SolidWorks, there's no way wrong to build something. There's a million ways to build it, and so you learn some design things really early on that are kind of important. Like, if you want to do scaling, it's critical that you build everything and on the dead center of everything. So on your origin, so it's dead center. So because scaling actually goes from the center out and proportioned, and so I did a full-size model of the PET 2001 that I've got here.
Yeah.
I took my mic out and I measured every piece of it. I built every single piece to it. So there's the monitor separate. I mean, everything. I built the cassette deck. I built everything. I built it full scale.
Yeah.
And then, because my goal was to build a miniature PET that was functional with emulator built into it and a TFT display and all that stuff, which I did do, but never released it yet to anybody, but people have seen some of the prototypes. But to get the size of the TFT to fit correctly for the PET, I had to scale it over and over and over again. And I actually I 3D printed the faceplate of the PET. So I could actually put the TFT in there and go, okay, that's not quite right. And then, of course, you got to be careful because there's only so many different sizes of TFTs that are available.
Right.
So I end up with a 2.2-inch TFT and it ended up being exactly 0.30 scale. So not quite 1/3 scale. And that's exactly how I made it. But I was able to do that with SolidWorks by scaling it using the scale function. It's actually, you grab the part, you go into the tree, you say scale, it's at the scale size, and boom. And if you build it correctly, the whole thing just shrank. And it was perfect when it was done, which is great.
I think for the makers, this is, a lot of people over the past few years have gotten a little bit more into, okay, I now can make PCBs. I think this is going to be the next step. Now let's see if you can start making a case, simple case. And then even if you don't have a 3D printer or you want to have it done more professionally, get it out to a JLC PCB and, your repertoire of things that you'll be able to make yourself is just increasing very, very rapidly this way. I see you
talking about graphic examples. So this is
I remember you all. Oh, is this the big box? Oh yeah.
This is the entire box from JLC PCB with different samples of the things that I have made from them for testing.
Not sponsored, by the way. Not sponsored. Important to. Yeah,
they're not sponsored, but this is the cassette deck.
Yeah.
So that's the upper part of it, and this is the lower part of it for the PET. Let's see. So I have one here that's actually assembled that I did. This has got a white faceplate on it though. So like the cassette deck, actually the lid opens up, so it functions. The hinge is actually functional. So the hinge line opens. I have a piano wire in the hinge for it. And there's even like the little parts for doing like the switch and the back, the fuse and the little AC line. And so, and the keyboard, of course. So this was literally, this is 0.30 scale, but JLCP, they printed all this stuff in the pieces, which was cool. All different Y-modem cases I've got. So I've got bags of Y-modem cases. So this is for my Y-modem for 64. Yeah. They made all the cases for those as well. Let's see what else I got here. Oh, so this is the base plate for that in white. So I actually ordered like every type of plastic they had because I wanted to know the difference between the different plastics and the qualities and all that stuff.
Right.
Pretty much they're all the same, with the exception of the nylon. The nylon's a lot different than the others, and it's super cool. That nylon is a lot more expensive. What else did I got here? Oh, so I got another faceplate.
Yeah.
For the PET. This was a prototype for the SX64 for the DX version for the upper drive. That's actually electronic drive.
SX,
yeah. And so I have a resin printer. I actually have several of them. So I do a lot of this first and then test it because my resin printer is just accurate as this. But the quality coming out of that machine that they have there for HP is even better. And I don't have to worry about cleanup and supports and all this stuff. Right. And it's super inexpensive. So once you've got your prototype that you've made and tested to make sure it works, like for this case too, I did the same thing. I did it with my resin printer, checked the fit and everything, and then I went ahead and ordered, a bunch of them from them. But I think you're right, Yuri. I think this really is like kind of the next step that's going on. We've got great PCB stuff now from different companies. PCBWay also does.
Does some of this. Yeah.
They do this stuff as well.
Yeah.
So I built this as well. Flying saucer.
Flying saucer. Yeah.
Yeah, the flying saucer pieces. So
I could see it. I could see it fit in the Attack on Mars pinball machine.
Yep. So this is an enclosure for. It's a flight control system that actually I worked on. My day job, I do weapons and guidance control system stuff. So this is one of the controller boards. And so this wasn't actually injected molded when we were done, but I had JLC-PCB make a bunch of these up, and so we could actually check to see, because these are a lot more flexible than standard. Like we use an ABS fiber fill and the actual units because they're strong, but it gives us a really good, ability to move things around and flex. So that's one thing about accuracy wise. People ask me a lot about that. Well, how accurate are these? And I have to say they're accurate enough for what we're doing. There are some cases where you get shrinkage you have to account for. And we see the same thing with our FDM printers for years.
Sure.
That's why we do a little cube test to see exactly, how accurate your printer is and all that. But accuracy is really good now. And if you look at JLC PCB's website, it has a description of the plastic and the properties of the plastic.
Yeah.
There's a couple in there that don't hold real well as far as tolerance goes. And then there's other ones that do, and they state the ones that do and don't.
Right.
So, but like I said, I know PCBWay also has it. PCBWay also actually has crystal clear that you can get. I know that it was either Adrian or LGR or somebody went and got it was Parafractric.
Oh, he did.
Clear, crystal clear, Commodore Bredbin case made from them.
True.
Yeah, it was expensive. It's like $400, but that's a big piece of plastic though.
Well, and over time this will get cheaper as well.
Yeah, that's the thing too. Is you look at, you and I have noticed the price of everything has come down.
It's come down quite a bit indeed. Hey Jim, let's
wrap this up.
Let's wrap this up. What is it? We did well. We're only half an hour over. That's not bad. Well,
it's not too bad. Well, we're supposed to have a little bit of a talk in our group and about what we're going to do for next year, and hopefully it's going to be in person.
So, Jim, I presume we're going to do that on the Discord on the joint channel. Are we going to wrap up the
YouTube
the stream here?
Yeah.
This is how many virtuals have we done now? Was this the third one or the fourth one?
It's the fourth one, isn't it? So 2017, 18, and 19 were real, and then we've had 4 since then. So this is the 7th annual.
All right. So now hopefully we'll figure out a way to get together in person next year. For all those people that complain about that and have said about that, the best way you can help is 2 ways. A, you're a valley mogul, and you typically turn on your heating in the house by burning hundreds. Get in contact with Jim, or maybe you own a nice property somewhere very close to an airport, central for everybody to fly into, that we can use and do that. Or maybe you are MGM and you haven't figured out how to get yourself out of the hacker situation, but you need your hotel filled for a certain amount of dates. Again, get in contact with Jim. If you want to be, everybody wants to get together, people. It is super expensive. Be part of the solution and think with us on that. This is we're past the COVID and all of now, but unfortunately the whole world has now figured out ways to make these type of live events just too expensive when it comes to the facility, because we would need a facility where we can set up, leave it overnight, go through the whole night if we want to. All of us would love that. If you want to be helping with that, we'll be in that forever.
So if you've got a big warehouse building someplace.
Yeah, exactly. Something, and let's see if we can make it work. Otherwise, we're gonna, we'll always have a virtual element. I think that will be there no matter what. But I think, I had fun. I hope everybody had fun.
And, so let's give some thanks, because we've got, all of our presenters that came, and so those guys that those guys make the event for us. Really. So get in.
All the artists again. Great
all the
show
artists.
again. Holy moly.
Let's run down the line. So we have Gideon, thanks, Matt D'Amico and Saj for doing Bitscape again. Chris Sakula, David Youd, Arthur Dorderson joined us from the UK. It was great. Mark Lemmert, Jim Happel, Keith, Robin, Mike Hill. So you, Yuri, and all the admins. So if you're in our Discord, you're going to see a whole bunch of orange people on the right-hand side. Those are all the admins, and that's all the CRX crew. I think there's 12 of us maybe in there.
Something like 12.
I think something like that.
So,
that actually behind the scenes that are running everything. And So it looks kind of smooth now after year 4, but you know, there's still fires all the time. So that's what happens. So it's all these guys. So thank you for all you guys for all your help for all these years as well.
Tim,
And
thanks to you. Thanks to you for doing this for another 4th year. You know, you put a lot of time and effort, a lot of time. People don't understand. You don't sleep much. You have multiple day jobs, and you always make sure that everybody feels welcome to this event. You do
well,
a
it's
fantastic job.
got to keep the spirit alive in the community for sure. You know, that's what it's all about, really.
Yeah.
You know,
Yeah.
we got to see that a little bit myself again, which was nice, little bit of a primer for this. When we went to VCF Midwest, which is great. But I can't forget Slay Radio.
Yes.
We appreciate
Slay
you.
Radio. For
We
bringing the
love
two
Slay Radio. I listen to it every single day.
Yeah.
So, all right, well, I guess that's it, huh?
We'll see you on the
Signing
Discord.
off for the 3rd day of CRX 2023.
Thanks a lot.
See you.